Hello, and welcome to the full course session on AutoCAD Essentials for Mechanical Engineers, your gateway to mastering one of the most important tools in the manufacturing and engineering industries. This is a certified course session, so make sure to fill out the form in the description after completing the session to claim your certificate. You can proudly share your achievement on LinkedIn to showcase your new skills. At Skill-Lync, we're committed to providing industry-relevant advanced engineering courses. We partner with industry experts to offer top-notch training that equips you with the skills needed to excel in your engineering career. Don't forget to subscribe to our channel for more insightful tutorials and updates on engineering tools and techniques. Hit the subscribe button and stay tuned. Here's a brief overview of what we'll cover in this training video. In the first chapter, we'll introduce you to the fundamentals of AutoCAD and its role in the mechanical engineering industry. You'll learn about the importance of drafting and how AutoCAD drawings are utilized in manufacturing, quality control, and assembly processes. We'll start with an overview of AutoCAD and cover drafting principles, the interface, and basic drafting tools. In the second chapter, we'll dive into the precision tools of AutoCAD that are essential for creating engineering drawings. You'll learn about coordinate systems, perspectives, and drafting settings like object snap and dynamic inputs. We'll also cover basic editing commands such as move, copy, and mirror. In the third chapter, we'll explore the techniques for navigating and visualizing complex mechanical assemblies. You'll learn essential navigation techniques like zoom and pan, as well as selection methods to help you focus on the most important parts of your design. In the fourth chapter, we'll focus on making your drawings more readable by adding text, dimensions, and other visual aids. You'll learn how to edit text, styles, colors, and more, along with advanced editing techniques like stretch, scale, and rotate. In the fifth chapter, we'll cover the concept of manufacturability, teaching you how to use AutoCAD tools to ensure that your designs can be successfully manufactured. We'll explore commands like B-hatch, P-line, and Fillet, and learn how to check key measurements and dimensions. In the sixth chapter, we'll introduce you to the principles of quality assurance in engineering drawings. You'll learn about GD&T requirements and different dimensioning techniques to make your designs more readable and easier to inspect by manufacturing and quality teams. In the seventh and final chapter, we'll cover tools that help you collaborate effectively and enhance productivity in AutoCAD. You'll learn about external references, layout management, plotting, and productivity tools like the AutoCAD Design Center and tool palettes. Thank you for joining us. We're excited to have you on this learning journey. Make sure to subscribe for more updates and detailed tutorials. Complete the training, earn your certificate, and share your achievement on LinkedIn. Let's get started with AutoCAD Essentials for Mechanical Engineers.
Hello everyone, I'm Devanand. I welcome you all to this course on computer-aided drafting, that is CAD, through AutoCAD software. It's a very popular 2D drafting tool that has been used widely world over, and I'm glad to have you all in this learning platform. So moving forward, so what do you get out of this course? What are the skills that you acquire in your portfolio? This is what we look at. So the prime skill is the two-dimensional drafting skills. So we look into what 2D is all about and how AutoCAD helps us, but this is a very key primary area that we'll be focusing on. Because once you're familiar with 2D drafting, you can expand that skill set to 3D and henceforth. Because now almost all the design industries directly model the 3D models and take 2D drawings out of it so that they can productionize them. So this 2D is a very needed fundamental for each and every engineer out there. It can be a mechanical engineer, automotive engineer, but also an electrical engineer who can use these drawings, these plans to create wiring harnesses and PCB diagrams and so on and so forth. And this AutoCAD has been heavily used in the civil domain, wherein they use this for creating site layouts, creating quantitative drawings, and measuring site plans and all those things. So it's an extensive tool set that you'll be using. Then we have the all more important geometric dimensioning and tolerancing skill. This is a very important skill set that each and every engineer uses in the practical domain. Actually, this is more important because most of the issues created in the production line or in quality arises out of wrong tolerancing or wrong dimensioning techniques, because the desk engineer, that is who creates this drawing, needs to understand how the component is being machined or produced so that it arrives at the final form that he or she designs. A casting technology will have a different tolerance, whereas a 3D machined component can have a very minute tolerance support. So tolerancing is nothing but the margin of error, the machining error that a tool can produce a component to. So we'll dwell a lot on this in subsequent weeks. We'll focus more on this so that you'll gain practical skill sets to employ these techniques onto your drawings. And then we have the file management techniques. In most of the courses, you won't get to know how you manage the files that you keep on creating, the design files. The general practice when we create files is that we'll name it as file 1, and then sometimes we overwrite it or sometimes save it in a different location. Or if we keep on working on it and deem that this is going to be the final one that I'm going to publish, then you rename it as _final. But then there comes a small revision to it, then you rename it as _final, final. So it goes on and on. So when you look back those files, it's difficult to review which is what and when it has been revised, why it has been revised, and what should the version I should refer to. So these questions arise out of. So this is a proper hygiene that we look into. How can we name the files, store them, retrieve them, and process them? So this will help you a lot on the due course of time when you start designing or modeling your creations. And then you have the project management skills. We'll ponder upon this during the last week course, because once you're a proficient 2D drafter and also 3D simulist, then how do you take forward the design from the inception, the conception stage, to the final product? What are the challenges involved in it? How do you plan for the risks? How do you take contingencies in the process? So let's dwell a lot on that. So at the end of this course, you will be familiar with these 2D drafting techniques primarily through AutoCAD and have a sound knowledge on geometric dimensioning and tolerancing skills, and also have a fair view on file management techniques, and then a very sound structural knowledge how to handle a project and how to handle different stresses. In this course, we have 12 core contents. Each core content focuses on a key area that you would face in the industry. Each week has a course content of 2-hour sessions each, and for each of the weeks we'll be having different assignments. That'll be assignments grouped together or individual one, but that will test your skills to make sure you have understood the concept very clearly and can able to apply them at a very faster rate and with minimal errors. So this will help you practice your skill sets to achieve the level of perfection that you have set targets on. And finally, you will have a capstone project which will combine a lot of different techniques that you have learned throughout the course. It will be a challenging one. So at the end of the capstone project, you can take with you a rich knowledge of how you have applied this technical know-hows of AutoCAD 2D into a practical one. So this will enhance your confidence level and also a very good demonstration of the skill sets that you have acquired through a lot of hard work that you have put into this course. So splitting on to the week contents, in the first week we introduce you to the basics of drafting and also through the different CAD technologies that are available and how it has evolved, and also look into the brief of AutoCAD system and a brief on the drafting fundamentals. So this we have named as course Preamble. And next, which way? Lay of the land. That is, once you are familiar with the basics of AutoCAD drafting techniques, you have to understand how you can change the viewpoints, explore the drafting, a zoom or a pan. So those kind of techniques where you can manipulate the screen so that you can approach the drawing much effectively is what we'll look into in week 2. That is which way, lay of the land, exploring AutoCAD interfaces for drafting settings and specifying the dynamic inputs, specifying the limits, the units, and also looking into editing fundamentals such as move command, copy, array, and so on. So next we have the action part, because once you have ready the framework, what you have to do, then executing them. So in here we have something called as a steering wheel, a navigation techniques that AutoCAD has into it, wherein you can do all the manipulation techniques into this. And also once you're starting and proceeding with lots of dimensions, lots of drafting tools into it, then you have to select a few and then edit. So we'll look into those techniques, selection techniques, where you'll look into box technique, fencing, multiple and single select, and so on. So next we have something called as Emend. Emend is another word for editing. So once you have started creating your 2D drawing, of course you'll have to edit a lot. So editing does not mean correcting alone. It means creating a new dimension or a new feature from previously available drawing features. We'll look into it more, but the techniques what we'll look at it is using stretch command, extend command, trim command, and so on. So this will help you to work faster and more better way so that you can bring structures to your design ideas. And also we'll look into the other editing techniques where you'll enter the text commands and edit the style, color, line type, line weight of your drawing so that you can give another dimension to it. I mean dimension as in the visual dimensions that you can give into your 2D drawing. Differentiate between different areas in the drawing. So we'll look into more on that in this Emend section. Next is a very important area in the domain of mechanical industry, that is in manufacturability. So here the techniques that we look into is creating of hatching, the plain fillet chamfer techniques and all. So hatching means the internal cross sections of how it look into. So these are very key to make the designers understand that how the assembly is going to come into, and also it helps the assemblers, that's the line executives, to understand where the fillets are and how they should do the assembly and all. So why this fillet and chamfer comes in, because two components that are going to mate together to come together as an assembly and serve a different function. So these chamfers, fillets are very important to make sure they have the proper interfacing techniques. So those techniques, that is the fillet, chamfer and all, we'll look into the manufacturability area. And also we'll look into key inquiry techniques, wherein we'll measure the distance, the radius, angle, etc. in this segment. Next we'll learn it as the quality assurance one, wherein we'll ensure that the quality is met through the drawings. As we had discussed earlier, this quality means the geometric and dimensioning techniques, and also we'll look into how we can dimension our drawing. And the same gets continued to the next section, where we'll look into more quality and management tools, and also a little bit on file management techniques, and also we'll look into the tolerancing, leader, multi-leader, and dimensioning edit techniques. So next we'll focus on productivity enhancement. How well can you work around your way with the drawing? Because as and when your drawing becomes complicated, you have to be using advanced techniques so that you can deliver the results very quicker. So towards here we'll look into blocks and geometric constraints, and also working with layers. So this will make sure you stand ahead of your peers and deliver good and quality drawings. So next, once you have created drawing, how to demonstrate it to your team and make sure others are benefited out of it. How do you collaborate effectively? So here we'll see into how can we use external drawings and use it that value addition to your drawings or supporting your drawings to other projects and so on. So we'll go for external referencing, and also we'll look into AutoCAD Design Center tools and also the explode function. So next, what we have here is once you have collaborated and then publishing your work, broadcast die work. So here we look into the plotting techniques. Plotting is nothing but generating printable drawing views that you can publish out, and we'll also look into the different plot style that you can use, and also we'll give out a brief on the capstone project that you have to work on. So you'll start working from your week 10 onwards and focus on week 11 and 12 parallelly on working on your capstone project. So next we'll look into how we can work smarter. So here we'll look into different layout management techniques, model space and paper space terminologies that AutoCAD uses, and also how to effectively use floating viewports. And finally, in the epilogue session of this course, we'll look into the project management techniques that each and every one of you need to be familiar with so that you can support your team effectively. And also we'll look into again a brief on capstone project and support you on that. So with the brief on syllabus, now let's move forward to this course week on the preamble session. And in week 1 we'll cover the following topics: the drafting technique, what it's all about, why drafting is required, and what are the different technologies that people use to create the draftings. And also we'll look into what our orthographic projections are about and how to visualize the 3D models into 2D layers. And next we'll look into the CAD, that is computer aided design, how it has evolved and where it is now. And finally we'll look into the AutoCAD software brief, the working space, where are the tools located, how to work around with new files, creating and saving them and all. And next we'll also look into key techniques, drafting techniques such as creating a line, a circle, arc, ellipse, usage of erase command, and also the oops command. And the next we'll look into a brief on the assignment, how we can go about and what are expected out of your assignments. So now coming to why a technical drawing is required. What do you mean by a technical drawing? What is intended out of a technical drawing? So a technical drawing typically tries to answer the 5W and 1H. So what are those basically? The first W is what. So what is this drawing? What's the purpose of this drawing? What is it intended to tell to the manufacturer or the designer or whomsoever? What is the purpose of the design that you're putting forward? The next W is why. Why do you need that drawing? Why do you need that function? So this drawing describes that. Next, the drawing also describes who is the designer, because this is a very key area that most of the people miss out. But in industries, many people work on a common project, so we need to track of who has designed and how it has evolved. That is how it has been modified, by whom, the originator, the modifier, then the publisher. So all these details need to be captured. Next is when. So when was this drawing actually first published? What are the revisions it has undergone? Is it the final one, or is it a pre-final stage, or is it just in the nascent stage? All this needs to be captured in the technical drawing. And next, where. Suppose you have different offices in your industry, wherein maybe the same domain is spread across different locations. Then you need to keep a track of which drawing originated from where, so that it will help you to organize them and monitor them effectively. So now answering all the 5 W's, then move on to 1H. That is how. How do you manufacture the component? Those kind of data, the instructions are embedded into this technical drawing. So typically a technical drawing needs to answer all those things. So now look closer to the image that is here. So what do you infer out of this? This is where a detailed technical drawing comes into. Actually this is the creation of Leonardo da Vinci. Helicopters. This is a way back. He's a very rational design thinker, so he has actually drafted this. This helicopter uses cloth or a very light material, a filament that used to create the lift, but actually it was not conceptualized or not able to productionize at that point of time. But recently many individual scientists and local DIY innovators tried doing it, and they were quite successful in doing this. But the point is, this drawing is very vague. What material should I use it? How much the entire size should be? What is the dimension ratios? With that, this image is very difficult to draw in those details. So this is where a technical drawing comes in. It will help you answer all those 5 Ws and 1 H, and so it can be easily reproduced and worked upon. But again, Da Vinci is of course the king of designs. Okay, moving on. Have a view of this drawing. So here you can see, even though it's in a different language, it's in German base actually, but with the different views you can make something out that is kind of a burner that uses some logs, and there is some chimney, there is some vents, there are some areas where you can put the charcoal in. So you can infer some amount of information out of it. So this is what we were speaking earlier. A technical drawing must help the productioners, the manufacturing area, or the other designers to understand a language, a technical language, and replicate them. So this is one such example of where a technical drawing can help you out. This is another example of how the technical drawing can help the manufacturing domain or the industry. So this is actually a fighter aircraft from the World War II generation, a German fighter aircraft. It's called the ME 109 G2. So this drawing typically shows you how to assemble this vehicle and which components it's where. You have the gunner area, you have the propeller area, and also there's a detailing on how your profile section varies at different locations and how are your instrument clusters positioned, all those things. So a technical drawing helps you to understand how to put things together. So now let's look into drafting fundamentals. Having understood what is a technical drawing, let's see what a technical drawing literally means. Wikipedia states that a technical drawing or drafting is the act and discipline of composing drawings that visually communicate how something functions or is constructed. Because if you can recollect, we were talking about the same. We were talking how the designer conveys his idea through visual media, that is through drawings. How do he convey that drawing is intended to satisfy a function, or how it is manufactured or assembled. So that is the crux of a technical drawing. The ISO name, that is the International Standards Organization name for this drafting, is Technical Product Documentation. Documentation means that you're storing it for ages to come. That is, you're indexing it, you're properly locating it, and then storing it. So that is where this drafting comes in actually. So as we discussed earlier, it is a two-dimensional information and it is language independent. A technical drawing can work across geographies provided they all have a common understanding of what a technical drawing is. They need not understand the metrics, the units, but still based on the instructions that are provided in the drawing, they can translate and then effectively visualize them. So a technical drawing is heavily language independent because it's a language, it's on its own. So next, they are bound by rules or standards. That is, you have to draw a line of this thickness only for a normal line, and a construction line has to be drawn in such a way that it is replicated the same throughout the world. And what paper sizes that you use, you have A4, A3, A2, so that it is the same everywhere that is being employed. So this technical drawing is bound by rules or standards that will make sure it is language independent, and it also houses a wealth of information of 2D data. So to sum it all up, a technical drawing conveys the geometry of the design, the dimensions of the design, the tolerances of which it has to be manufactured, and what is the material it's going to use, and what is the finish of the design once it comes out of the line. So next is, what are the different viewpoints? This is a very popular drawing or a cartoon that will tell you that even though the object is the same, based on different planes of projection, that is based on different views, it will give out different information. That is, here you can see a couple of scientists who are experts on their own domain construct the visual image of the object differently based on the plane of projection that they have. That is, each and every one of them have a different point of sights and viewing methodology, that is the ray of sights. So they term the object, that is here the elephant, as a spear, a tree, a wall, a rope, because it's keep on deviating from the viewpoints. So reiterating, a technical drawing, as spoken earlier, has to be language independent, has to be very strong with 2D data. Then how do you convey those data in a structured way? So that's where you have the orthographic projections that are being used in drafting techniques, wherein you will keenly define what the object is, as seen it's located in the center, and next you define what is the plane of projection, that is, on which plane do you see the projected image to it. So here you have different planes of projection. You have the horizontal plane, you have the vertical plane, and also you have the picture plane. So the same object, when it's moving on to a different planes, how it's been visualized. And next is the point of sight. From where do you look this object from? And what are the rays of sight? Because you might have learnt about this perspective view, wherein if you see a railway line, a railway track basically, even though they are parallel to each other, based on your viewpoint and the rays of sight, they will tend to merge at some location. So that's called a perspective view. But in orthographic projections, as your rays are parallel to each other, they never converge, because basically you have these lines are parallel to each other, and as your rays are parallel and your point of sight is at infinity, you'll get a perfectly parallel view. So this is called the orthographic projections. So if you understand this language of orthographic projections, you can visualize the 3D object into different 2D planes so that everyone can visualize the object effectively. To give you a further example of how the orthographic projection can work in, take a view of this butterfly valve. So you have 3 dimensions that you can look into. You have the X dimension, the Y and the Z dimension. And if you're considering a viewpoint from here to here, and so this will be your front plane, that is in front of you, standing here and viewing this object, and so the plane is this one, the Z and X plane that you can see here. So the object will look something like this. So this is your front view. And next, if you go underneath to it, that is, you look the object from below and through this plane X and Y, you will have this. You're looking at the bottom view of the object. As you can see, only the bottom side and the remaining part of this handle here. Next, if you're seeing from the top, that is viewing at the same XY plane but from the top direction, you have something like this, wherein you can get the detail of how the handle sits into here and where is the bolting structure, how is the plane view and all this thing. Next, you can view from the right and left hand side also. So that will show you how this flap is located, what is the angle of it. So if you come to the right side and view, this is the plane here, and you come to the right here and see through this, this is how it will look into. And if you come to the left side and see it, and this is how it will going to look from the left side. So now you can visualize all these views together to visualize the 3D view of this. So this is what you are intending to do with 2D drafting. You are essentially going to convert this 3D model or a 3D design into separate 2D drawings so that the designer, the drafter, the assembler, the manufacturer, everyone can understand that once they have machined in putting together all these views, they'll get this final component. So this is the power of orthographic projections, wherein you break down the 3D model into separate 2D models. So now you can also see one thing. We have spoken about the left view is actually on the right, and what we have spoken about the bottom view is on the top. So we name it as the first angle of projections. So it means that in a 4-quadrant plane, we take in the first quadrant, that is this quadrant, we keep the object on top of it and view on the respective planes. So that's called the first angle of projection. So it's been represented by this symbol. In certain countries, wherein in UK and US, they use the third angle of projections. So the visualization is the same, but the thing is they look into the third plane of the space, so that your left and right will stay in the same location. So that is, the left view will stay in the left, right view will stay in the right, and the bottom on the bottom, and top on top, and so on. So that's called the third angle of projection, and there you will have this view interchange between these two. But in India, we predominantly use this first angle of projection. So this will give you a fair idea of how the images are to be positioned. So this is what we are speaking about. Based on the standards, you have to follow certain standards, so that if you put in this symbol, it is understood that you are always referring to the first angle of projection, and hence this image is always the right view of the 3D model. Hence you have to be very careful on communicating that this is actually the first angle and putting the views correctly in their respective locations. So having spoken about the different viewpoints and the orthographic projections, and also based on the drafting techniques, let's see how drafting technology has progressed. We have initially seen Leonardo da Vinci penning his ideas onto paper, and once they have mass productionized this, that is, once they wanted to create a lot of blueprints, so this is how they were working on. Several engineers put together, they were drafting the viewpoints, they are duplicating the images so that it can be distributed and worked upon. So there were individual drafters, and then there were area managers that will oversee the work, the projects, and they have dedicated compartments, you can see here, wherein they'll store the blueprints. They have to be named, they have to be indexed, and then they have to link between different drawings and all. So much of manpower and so much of human time was spent to create and recreate drawings. Whereas now we have the advent of computers with high computing capacity and visualization capacity, we can create such designs very fast, very quick, and very efficiently. So simply put, this one engineer, it's replicating the work being done by this whole mass. And in fact, in a fraction of time that earlier these people have spent in creating the drawings, he'll just create in a whisk of a second. So this is how the drafting technology has progressed. So this drafting technology, as we've seen, with the advent of computers, it had advanced a lot. So let's see how it had evolved. So initially, Patrick J. Hanratty, who is widely regarded as father of CAD or CAM. So CAD is computer-aided design and CAM is computer-aided manufacturing. So with the advent of mainframe computers in the 1900s, 1930s, 40s, so he designed the initial software called as Pronto, where is numerical control programming software that can create the 2D designs. So those codes, he was pioneer in bringing out this drafting techniques onto the mainframe computers. So next came in Mr. Evan Sutherland, where in 1960 he invented the Sketchpad. It featured the first graphical user interface. The initial Pronto was command based, you have to type in the lines of code to replicate the product, but the Sketchpad was a breakthrough innovation wherein you can visually plot those 2D drafting. So this is what something you call as what you see is what you get. So that is a basic of this graphical user interface. You can directly visualize them as you plot them. So this was a very big breakthrough in 1960, and next in 1971, same Mr. Patrick Hanratty, he founded his own company and invented Adam software. So it's an interactive CAD program again, but written completely in Fortran. Fortran is a language that was widely used that can be adapted to different computers seamlessly. So this served as a bridge wherein they can manipulate the software in different machines and attain good results. Next came in AutoCAD. In 1982, AutoCAD made a breakthrough through taking this CAD software to the masses. Masses as in, earlier the mainframe were restricted to big research institutions, wherein with the advent of personal computers, AutoCAD took the CAD software to everyone. So this is a very revolutionizing point in the CAD history. Next came in Pro Engineer in 1987, wherein they generated modeling techniques that uses the parametric technique. It means that you parameterize the dimensions and put in constraints so that you can scale it effectively and whenever you want. This was widely picked up by a lot of industries where they have a base model and then they have scaled it up to different versions. So this will help them to quickly accelerate the work that they put into. So this was again a revolution in the industry at that time. Next came in SolidWorks in 1995, wherein it opened up this 3D modeling to the masses. It was very cheap, very efficient, and even now it is in the forefront of 3D design. This, as you can see, the names, the Sketchpad, Adam, AutoCAD, Pro-E, SolidWorks, it's all still there because they are pioneers of this domain and they have constantly evolved themselves to make use of the best of the technologies that are being made available each and every year. So they have constantly re-visualized themselves so that they stay in the forefront and advance the domain of CAD and CAM. So this is how CAD has evolved. So now people directly create the 3D model. In some domains, they actually scan the model and then generate 3D models out of them. They don't draw them anymore. They take a 3D scanning out of the model and then generate the 3D image. Next, also you have the 3D printing technology, wherein you have the additive manufacturing technology, which is different from the deductive technology, that is the traditional technology, wherein you remove material to create the final design. So all your 2D designs are based on that. Wherein in 3D printing technology, wherein additive manufacturing, you create layer upon layer to generate the final 3D model directly. So that is how we have progressed. But point to be noted is the basics will remain the same throughout. So that's why we emphasize on the fundamentals of 2D so that you can apply those skills to the advanced techniques that are available here in terms of 3D models and printing and all those things. So let's look into the features of AutoCAD. So it was first released in 1982. It's a very powerful 2D and 3D CAD application, and it has separate tools for separate industry. It has an electrical tool set, it has a mechanical tool set, and also it has a very dedicated architectural tool set. So wherein they can use those tools to create specified drawings, and it has a very powerful mobile and web app capability. So now AutoCAD has migrated most of its work towards on the cloud so that you can work seamlessly anywhere. No more you're constrained on your desktops or your PC. You can view the models on your mobile, you can collaborate effectively, transfer them, need not store it in a local PC, you can upload it on the cloud and then design on the move. So it's a very powerful capability from AutoCAD. So this is a analysis from Enlift where they've estimated that there are nearly 125,000 companies that use Autodesk for their modeling. It contributes to nearly 33% of the CAD market that is available here, followed by SolidWorks, and then you have Dassault Systems and LabVIEW and so on. So in the 2D domain, the computer-aided design and engineering domain, AutoCAD is a very, very powerful and widely used tool. And in the industries that you look into, it's predominantly used in the civil industry, followed by the mechanical industry, and also they are being used in computer software, hardware industry, where they are used to write in the architecture of their different platforms. And so going forward on this PowerPoints where you can use as ready recognize, we have specified areas that you look into for the procedures to use the functionalities, and next there are also highlighted useful tips for different functionality areas. So previously we had seen the course pointers and the tips that are displayed in the PowerPoint slide. Now let us look into the AutoCAD interface. So now we have here the desktop, and this is where the AutoCAD application lies in. So let us open it by double clicking on it. So this is as we said earlier, it's a very powerful tool with lot of tool sets that are featured into this software. And now we have this workspace here. So let us start off with a new drawing so that we can explore what are there in each and every toolbar or ribbon here. Okay, so let's click on the start drawing. So this will create a new empty drawing to us, and as you could see here, we have an array of icons, menus, and different tabs, a command space, and all this. Let's view each and every one of it. So the first thing that we observe is the workspace area of AutoCAD. So workspace means that the tools that are available in the screen pertains to the application that you're working with. If you could see here, we have now 3 predominant workspace settings available for us to operate. We have the drafting and annotation. This pertains only to 2D drafting tools. If you can see here, what all the icons and the tool sets that are available pertain only to 2D drafting. Whereas if you move on to the next one, we go to the 3D basic modeling. So this workspace and the commands will get updated for your 3D modeling tools. And if you move on further to the modeling section, you have advanced tool that is available for this application. So based on what you need to work with, you can set up your workspace. And ideally you can customize the workspace that you work on. So as and when you start in, what should my workspace contain them? So this is where you list on which is what's required for you to work. So let us pause this for a moment and come back to our 2D drafting workspace. Alright, now let's see what are the various key areas that we need to look at. So this is your drawing space where you will execute the drawings, and the first and foremost location where you will process the files is this one, the big A for AutoCAD here. You have all your file related commands listed here. You have the new file, open file, save as in a different format. Then you have the import facility, export and publishing options, and also drawing utilities where you set in the file description and the preferences. For example, you set in the properties, units, all those things you can set in here. So this is your application menu. And following which, the bigger one, this is your ribbon, wherein you can call in the relevant commands that you want to work with. For example, if this command is copy, you can click on it to generate it. And if you hover on this object, you will get the info tip. And if you hold it further, you will get an extended menu tip. For example, if you want to know about the R command, hover over it, it shows creates an arc using 3 points, and still further it shows how it is generated. For further help, you can anytime press on F1 to look into the command section to see how it is getting generated. So you'll have all the details here that will help you understand the background behind each and every command so that you can use it into your drawing. So now you can explore each and every one of this. So this home tab contains almost all the basic drawing commands that you have. You have your draw commands and extended command menu, modify commands, annotation command, layers, blocks, properties of each and every line or the layers, and then grouping commands, utilities where you can measure the distance and all, and then the clipboard, and then the final view one. And in insert ribbon, you have the block insertion, block definition menu, and then references, import sections, data linking. If you are taking an external data object and linking to it, parameterizing it, then you can use this. And then linking and extraction of the data that is from your file, linking to another source, and so on. And again set your location from where it is. So this it's an advanced one, you can still look into it. And in the annotate section, because in home you do have the annotation, it's a basic one. In this you can specify in each and every definition to it, and also you can mark in the center lines the specification of leaders, and writing in tables. This is very useful when you are printing it out in a layout format where you have to specify the table data and all, and then give out markout information, and also specify the annotation scaling. In the parametric tooling, this we'll look into in the later part of the course. This is kind of a customizable drawing that you can draw. you give an input dimension not as an absolute value but as a relative value. That is, you name it as X or correlate with another one. That is, a line A is 3 times that of line B. So when you're scaling the line A, B line gets scaled automatically. So this is what meant by parameterization, or again constraining. Constraining means even the length is constrained within this boundary, so that you'll get a warning message and saying that no, it is exceeding, so you have to revise it. So like that, setting a constraint for the design also helps in when you are doing advanced drafting. And in view menu, you can control the way how you view the file, view the layouts and all, and control the icon description, the navigation bar and so on. And then also we can do a drawing compare with the latest softwares, that you can compare two drawings side by side to see how the revisions are varying with each other. And again, in this palettes where we have the property menu, and also here when you click on a object and then click on the properties, it will show what's the line type, what is the line weight, what's the color, what layer it is, all this thing. And next is your interfacing. This is kind of similar to what you work on Microsoft Word or PowerPoint, where you can tile two windows vertically together to do a side-by-side comparison and all. So this is the View tab, and in Manage tab you can see advanced commands, and this one is of very particular interest. We'll try to cover and look into in the other sessions. So this is something called a macro. It's a very powerful tool. This macro is used to do a repetitive task by automating them. Suppose if you want to measure the boundaries of a given object each and every time, and whatever object it may be, that is with different drawings, you can set in a macro command to look into the boundaries of it and then giving out the total length of the boundary. So this is a very powerful tool that is used to automate repetitive decisions that are being made. So this is called the action recorder. So this is similar to the macro that you find in Excel or Word that is used to automate things. And then you have the customization panel, the application panel, the VBA macro. This is what is used to record the functions and load it. And then what are the different CAD standards that you are applying to. And then finally, this is again a processing capability that will help to fasten your Autodesk interface. And in this output tab, you can control the way how you are exporting your or printing your drawings. And in add-ins, suppose if you have an additional third-party software that can work seamlessly with AutoCAD, then you can use this to integrate within this menu workspace. So that's how. And finally, collaborate. Again, how well we can work with others with other drawings and see how it correlates. And then this is an express tool where you can put in the tools that you are requiring to use for frequently. So here you have your text commands, modify commands and so on. And this is internet link tabs that you want to download and use. So this we won't be looking into. So finally, this is what your ribbon is all about. But these are all pictorial, graphical interfaces that help you to work faster. But traditionally we have something called as a menu bar that we frequently use. Typically in the modern versions of AutoCAD, it's been automatically hidden, but still you can take those out. So if you click on this down arrow button in the top, you can see an icon called show menu bar. So this is the classical form of the menu bar, wherein this again the file, whatever this application menu is listed here, and then all the content inside the ribbon is structured here. Everything is included here in a classic format. For example, if you go in draw, the same one whatever is here, so you also have the 3D images in it, because basically if you want to take this, then you have to change the workspace and then bring into it. But in the classical menu, you can have everything on a same platform. So here you have the line or is. For example, if you see in the normal ribbon, if you want to draw a circle, when you click on the circle drop down menu, you can see different pictorial representations and the selection of the options. Whereas if you go in draw and then click on circle, you have the same but in a limited structure. So both are essentially the same, but this is where you will get everything in a quick and fast manner. Again, you have dimension, the modifying commands, the parametric commands. Okay, yeah, so till now we have seen what is the workspace is about, and what is the application menu, what is the ribbon, and how to access the menu bar. Next we have the quick access toolbar. This is called the quick access toolbar. This has the commands that you use frequently during the working of the project. You have the new file, open, save, save as, and then this is open from a web and mobile app for taking an existing drawing from the cloud, and then publish or save to the cloud, the web and mobile interfaces, then a printing option and all. So this is your quick access toolbar, QAT. And you also have the undo command and the redo command. This we'll look into a little bit when we are drawing something basically. So now we can again customize this access, so you can add in whichever you want it. Suppose if you want to add the workspace command into here, then you can do it here so that you can quickly select from here. So this is the advantage of the quick access toolbar. And next we have the view cubes. So this is called the view cube. So it's used to manipulate the viewpoint of your screen. If you recollect the presentation, we were talking about the different views and then the planes of projection. See, in this, now we are in the top plane, and subsequently you can see this onto here. So this is called as a UCS, user coordinate system, UCS icon. So here you can see now it is in the XY plane. The green line is the Y and X is the red line. So this top view is listing the XY plane, and if you want to see the front view, you can see the different arrows. You can click on this arrow to see the front view. Now you're getting the X and Z axis, and this is the left view. You have the Z and Y axis and so on and so forth. So this is your view cubes. And also you can use this cursor to rotate about the pivot axis, and you can select which one you want. And likewise we have the rotate option along this way also. So this option is what we call as a view cube. And here again you can specify the perspectives that you want to look into. So if you recollect the presentation, for a technical drawing viewpoint, we'll always look into the parallel view. But suppose if you're working with a 3D and if you want to look into a perspective viewpoint, also you can select the rays of sight in here. So this is your view cube setting. And next you have here the navigation bar. So here you have the navigation wheel, the pan option, the zoom to extends, that is, so now clicking on it back zooms back to its extends the boundaries, and then you have the orbit option, and then also you have a show motion, that is to record and so show a sequence of camera animations. For example, if you are taking a plan view of a civil building and you are creating some viewpoints to it, and then you can sequence it and show as a glided view to that plane. So this is an advanced visualization technique that you can employ to convey the essence more effectively. And next here we have the status bar, where we have different options that you can go into. Here it will show the selection of the model or the paper space. We'll look into each one of it detailedly, but the application is that it's a kind of a quick access, but more of an option menu where you can select the snap setting, this is the grid display menu and all, and also the annotation scale menu and workspace editing. So this is your status bar. And next you have your layout tabs. So now this is your model tab, and then this is your layout tab, paper based tab, and so you can have different views to it. And then here on top you have the file tabs, wherein you can keep on adding different drawings and going. So now coming to the most important area, this is called the command line. This is a very powerful attribute of AutoCAD, frequently used attribute of AutoCAD. This is what differentiates AutoCAD from other 2D softwares. Whatever we have seen so far, the ribbons, the menus, the status bar icons, invoking of navigation bars, the layout specifications, everything can be triggered through commands. For example, we were seeing about the circle commands. Normally, if we want to do it, so I have to click on the circle command, then it will ask for sequence of different points and then so on. So for example, if we want to take this option, then I have to manually specify and then select it. Oh sorry, I have taken for a different two object of, so let me draw one more circle to demonstrate it. So it's a tan radius, so I'll select the first and second object and specifying the radius of it. Okay, so this is a graphical way of doing it, but I can replicate the same way faster by using command. So I'm just entering the command C, typing on the keyboard. It is directly prompted onto here, and clicking on it opens the circle command, and into here, down here you can notify what is the next command AutoCAD expects the user to feed. It says circle specified center point for the circle, or you can enter any one of the respective menus to convert it. So let us now look into the undo command also. Let us roll back a little bit. So let us roll back until this creation of this circle. Okay, one more step. Okay, so let us recreate the circle just by command. So what we have done was, we had created a circle and created one more, and then created the third circle with tangent radius. So selecting first, second, and then radius of it. Now we've got it. So with this command prompt and then entering through keyboards increases your model creation time. The rapidness of creation is magnified a lot. So very good user of AutoCAD relies only on the command prompt windows to perform almost all of his operations. So for each and every command that you work on, try and look into the command prompt intonation so that you can repeatedly use it and take it to your benefit. So the next point is also called the toolbar. So right now the toolbar is not visible. So if you want to do it, go to tool and then click on toolbars. You have different options that you can select from. In AutoCAD, let us select one tool that I need to work frequently on. Let us select this draw toolbar. So here you have all the draw commands available in whatever listed here as a toolbar option, so that you can quickly work on. This you can also have as a floating menu, so that if you are working on a bigger project, and if you want to quickly click on the icons, then you can use it. But the recommended practice is you always use the command line to select and draw your drawing. So now let's look into the draw commands that are available to us, and let's start first off with line. But before that, we'll also look at two features that we are going to look into today: erase commands and oops command. We already have drawn some good circles here. Let us try out the erase command here. So for that, you type in erase and then click on enter, and then you can select the objects that you want to delete. So when clicking on these 3 objects, you can see that the select objects, each and every time one is been incremented, and total there are 3 objects, and click on enter to execute the command. Now the objects have been deleted. Now if we want to revert this, we have to type in oops, OOPS. So now it will get back to the command whatever you have already done with, that is, it will erase or roll back what you have done it earlier. There is a very small difference between this undo and oops command. We'll look it for in the next sessions. But this is to start with. But alternatively, if you want to delete, you can also click and drag. Click once and then drag to select the objects, because basically you are using a selection option to if you long press your left mouse button, you are using the lasso button, or if you press on once and then click on the other end again with the left mouse, you're selecting with the fencing option. So now you can alternatively click on delete to delete them, but the background effect is using the erase command to delete it. So this is about the erase and oops command. So now let's look into the line command. So for this course, we'll explore only through the command prompt window, but parallelly you can also look into this. The line command is available in the ribbon here in draw tab, and also in the draw menu as line. So coming here, you type in L. If you type in L, it will start the line command. So first it is required to specify the first point, and as you could see, there are two windows that are hovering nearby. The first one where it is highlighted for entry, and the second one. So basically it mentions the axis what I want to enter. The first one is the X. Let me enter 5 units of X, and if I want to go to the next, I have to click on the tab key, and with the tab key, next I'll enter the next command, that is 10. So it means that I'm fixing the first point with an X axis as 5 and Y axis as 10. I'm clicking on enter now, and hence now the first point has been fixed. Let me zoom using scroll button. So I'm zooming out. You can see here on the X side it has moved for 5 units, and in Y axis it has moved in 10 units. So this is your first point. So now it will ask for the second point. So we have different options. So let me pick a point directly. So I'm graphically picking a point in here. Alternatively, we could have entered the first point also graphically, but let us proceed further. So I'm picking a random point here. So now that first line has been executed. This line command does not terminate until you press the X option for exiting or press enter. So I've used this command menu to present. So if you can click on this up arrow, you can see the sequence of commands that you have already executed. So this is where you started it. You have pressed the button L, and that has prompted the line command. You have specified the first point numerically, and the second point you have specified graphically, and to come out of the command you have clicked the X button to exit from the line command. So let us do once more. Let me again click on L. So now I'm getting the line. So now let me pick on a point graphically here, and next point here, and then again if I click on enter, again it terminates the command. So you can either terminate the command by clicking on enter or by pressing X to come out of the line command. So now this is basically the line command that you want to go. But here let us also look into the coordinate systems and how we can effectively use to work around your drawing. So let me delete it. So I'll use erase option to delete these two. Done. So let us start a line afresh. Let us draw a rectangle in different methodologies that we look into. So first we'll start off with the coordinate system of absolute. That is, the X and Y axis are going to be defined as an absolute dimension. Let us click on L, line. So I have taken my hand off the mouse, so we'll do it entirely on the keyboard. So the first point, let us assume we start from X of 5 and Y of 5. So let us type as 5, 5. So the first point is plotted. The second point for the length of 10 in the x will be 15, 5, because the y-axis is not going to change. That point is going to remain the same. So on the x side, we are incrementing by a unit of 10. So 10 plus 5 is 15, and y is going to remain the same, so it says 5. So next, as we discussed earlier, the line command keeps on continuing until we manually terminate it. So let us continue drawing it. So on the y side, we are going to increment by 5 because the height is going to be 5. So in x, we are going to maintain as same 15, whereas in y, we are going to increment by 5 units. So from the base of 5, it is 5 plus 5, so it is 10. And again going in the next direction, so here again specify your x in absolute. So you are coming back by 10 units. So from 15 you have to come back to 5. So it is 5 in x, and y remains the same as the previous point, so 5, 10. And you have to close back. So entering the original point is 5, 5, and then clicking on enter again to terminate it. So now let us have a look at the commands that we have already entered. So with the line command, with the specifying of L, we specify the first point at 5, 5, and the next point as 15, 5, the next and 15, 10, and so on. So here you have to see that you have calculated the values and then specified it exactly as it would be drawn on a paper with absolute dimensions. So this type of drawing is called as an absolute coordinate system methodology. So next is the relative rectangular method. To look into that, so let us erase this off and start afresh. So I'm clicking on line command again and specifying the first point as 5, 5. So now the second point, ideally let me say that I have to go only to 10 units in the x direction. So to specify that, I'll use the command of alpha at the rate of, that is shift and pressing 2. So alpha and 10, 0. This means I'm incrementing along the x-axis by 10 units, but in y-axis I'm not incrementing any. So you get the same desired effect. Only this thing here, you need not worry about the direction. The plus always denotes on the positive side and the minus denotes in the negative side. This is what you have to keep a note on, but you can enter incremental units as and when required and need not worry about computation of the exact coordinate position the point is going to fit in. So the next point, let us go. So in x-axis we are not going to increment anything, so it's 0, and in y-axis we are going to increment by 5, so at the rate of 5, and so it should be in the first point. The other rate should always be in the first thing, so at the rate 0, 5. So the next one again at the rate. So now I have to decrement in x by 10 units, so and click entering as minus 10, and y has no change, so 0, and then now coming downwards in y, so x should be 0, so at 0, minus 5. So as you have seen, this is quite faster than the absolute coordinate system because you are specifying only the incremental commands and you are using just the positive or the negative signs to specify the direction. So the positive side in the x-axis will always go from left to right, and in y-axis from bottom to top. If you want to reverse the direction, that is if you want to go from right to left in the pane, so then you have to specify a negative, and again from top to bottom it's again in negative. So this is the relative rectangular coordinate system. So let us come out of the command by clicking on enter. So now let us again expand this window to check again what we have done. So here we have specified L command and specified the first point 5, 5, and then used at the rate command to enter the x and y direction in increment. But please note that I have made a mistake here. the alpha, the other rate should always be intimated in the front to indicate the system that I'm going to go in relative rectangular coordinates. So resuming here, we have specified again at the rate of the incremental in a negative direction to go from right to left and then from top to bottom to complete the rectangle. Okay, so that's it. So let me use the erase command to erase the sections. You can have a note at it here. This is not a single object, it's a separate line. So that's why when you use an erase command, you have to select each and every line to delete them. So having selected all the 4 objects, so complete the erase command by clicking on enter or space. Basically enter would work anywhere if you are working in this drawing area, and if you are working in this, then you can specify space, click on space to come out of the command. Okay, so now let us move on to the third methodology of drawing, specifying the coordinate system. So that is called as a relative coordinate system again, but instead of rectangular coordinates, it's called as a polar coordinates. So polar coordinates as in you specify the relative angle to the previous point. So let us demonstrate it. Let us go into the line command again as L, specifying the first point as 5,5, and now the second point. So the rectangle, there is always an absolute degrees to it. So the next point would come at an angle of 0 degrees. Let us show it. So the start point is again is at the rate of, you click on the incremental x, but rather it's not an incremental x or y, it's actually an incremental distance, and based on the angle it will determine in which area it want to go. So the incremental distance is going to be 10, and you have to specify the angle by clicking on the less than button, that is you click on shift plus comma. So by clicking on that, you have the relative, because at represents the relative coordinate and angle represents the polar, so together is relative polar. So now we say that it's going to go on the x direction only, that is from left to right. So you specify the angle of 0, and now again the next one. So the distance, incremental distance is going to be 5, and then the angle is going to be in 90 degree, that is upwards. So you specify as 90. And now again at the rate of, now the distance we require is 10, and now the angle you have to go from right to left, so it's actually the other side of, so is 180. So going on a polar coordinate system, so its angle is 0, 90, 180 and 270. So we have specified at the rate of 10 less than 180. Then to close it, the relative distance is 5 and the angle is 270. We'll come out of this by pressing space. Yeah, that's it. So this is the relative polar coordinates. Let us look into the command once more. We are specifying the start point as 5 and 5 and specifying the relative distance as at the rate of, please keep a note on here, always the relative carries an alpha at the rate of, and then if you click on the comma, it assumes that you're referring to a relative rectangular system, and if you click on the less than symbol, then the system understands that you want to go to a polar coordinate system. Enter the decrement. Earlier you have to again specify in the relative rectangular system, calculate again the incremental distance is whether in the x or in the y, but in polar coordinate you just have to specify the incremental distance irrespective of the direction. The direction is taken care by the angle. Okay, so this is the relative polar coordinate system. So they also remember the angles are always plotted in the anti-clockwise direction. So the base is 0, going anti-clockwise, 90, 180, 270. So this is how the relative polar coordinate system works. So this sums up the line command. Next, let's look into the circle command. So let us erase this off. So circle is invoked by the command C. So in circle there are actually 3 types of variants. So let me cancel this. Let's look into the types of circle and then come into. So here you have 3 categories. So one, you indicate the center and then the radius or the diameter. The second part, you specify either 2 diametrically opposite points or through 3 points. So the third method, you specify a circle based on tangent to 2 objects and then specify the radius, and other method is tangent to 3 objects. You can see different use cases from these examples and how you can replicate them in real life situations. So first let's start off with the center radius. Each and every command can be selected from the command menu itself. So let us look directly into the command menu only. So let's invoke by pressing the C command, the circle. So now if you read down the command line, you can see the input that is required. So it says specifies the center point for the circle or specify one of the methods. So let us start off with the first method, that is with the center point, radius or the diameter. So let us specify the center point as 5, 5. And now it's prompt for the circle. So by default the command is radius. And if we want to alternate to the next one, is we have to press in the D. So let us now enter a radius. So let's specify a radius of 1.25 and press on enter. You have your circle. So one more thing, if you hold it on the over on the circle, you can give a object type menu wherein it shows that this command is a circle and this is by this layer of white, and so this layer is the indication is 0 and the line type is again by layer. So everything has been categorized by layer, but this is the rollover object wherein you can get info about the separate object. So now let's look back into this command once more. So we have invoked the circle command through C, and we have specified the center point and specified the radius as 1.25, and we've got the radius. So I have selected it, deleted it. So now let's go back to the other command. So let's go back to circle, specify the radius as same. Now let's click on D, enter D to change the command from radius to diameter. So now it prompts for the diameter. So if you could notice, each and every time the previous entry point is being taken as reference. The earlier prompt was saying that specify the radius of the circle or diameter, and in angular bracket it shows as 1.25. That was because the previous entry was 1.25, so AutoCAD assumes that the entry can be the same, so it prompts for that. So if you want to use the same dimension, you can click on enter to use it. And here in diameter, when we change it as diameter, it just multiplies by 2 and prompts that do you want the circle diameter to be 2.5? If yes, let's press enter, and so the same circle has been drawn with that diameter of 2.5. You can see here the diameter is specified as 2.5. Alternatively, if you don't want to invoke the previous command but rather enter for yourself, go into the dimension command and type in 2.5. You're free to use in whichever command you want. But if you're doing a replicated task, you can always click on enter to take in the previous dimension or previous entry. So this sums up the first method of drawing a circle, that is by specifying the center point and then specifying either the radius or the diameter. By default, the command is radius. So next, moving on to the next part, that is the 2-point circle. So again, invoke by circle command by C, and then for invoking the 2-point, so let us enter 2P. So which letters or alphabet should you use? It's highlighted by the dark blue color listed here. So by typing that, you're invoking the shortcut to that command. So now let us create the 2-point. So now it is asking the endpoints of the circle diameter. Please keep in note the first command is specifying the center point and then specifying the radius or diameter. In the second command, it is specifying the points on the circle, and if you're selecting 2 points, it is the end-to-end diameter. So let us say the first point of the diameter is 5, 5, and the second point, let's assume the diameter to be 10. So it would be 10, 5. So you could see this is the first point 5, 5, and this is 10, 5. So based on these 2 points in extreme diameter, it has plotted the circle in the 2-point method. So going back here, you can see invoke by C command and specify as 2 point. It is invoking the first endpoint of the circle's diameter and the second endpoint of circle's diameter. You can also note that we are always using the keyboard command, but once you have started drawing images and you want to start from one edge to the other in the drawing, then you can choose very well. For example, if I am drawing a line here and then I want to continue a circle, so let me come out of this and then specify a circle with the center point as here. Then I could select in. So this green line we'll talk about later. So this snapping points. But see, so based on this we can also select graphically. The other way of doing it is again picking the center point or whichever is required, and if suppose if I want to draw a circle with the radius of this line, then I can also select this object so that it can draw with this radius. That is, based on the selection, it can use the same dimension to utilize in this. The other way of doing is again typing the diameter radius that you want to do. Yeah, right, sorry, we had talked it earlier. So this is one thing, and okay, the next part is using the 3-point methodology. So we'll go into the circle point again and selecting the 3 point by entering 3P, and now so you can select any 3 points on the screen to select on which one. So based on the direction of the third point, the circle is plotted in whichever direction it wants. So the computer computes circle that passes through all the 3 points. So this is how you plot the 3-point circle. So let's look back into this. So you are specifying the 3P command inside the circle menu to invoke this menu and use the first point, second point and the third point to draw the 3-point circle. Okay, so now last part of the circle methodology, that is using a tangent methodology. So invoke that, go into the circle command and click on T. So using that, a tangent is required. So here it's asking for the first object to which the circle should be a tangent. So for this command to work, for the tangent radius, you require a minimum of 2 objects already drawn in the screen, and for a tangent command, you require 3 objects. So as you can't see any object here, it won't take the input reference. You can see the warning here. It says require a tangential object snap and selection of circle, arc or line. So let us come out of this command by clicking on escape. So let us draw line in this way, 2 separate lines, some random lines. So now let us invoke the circle command and tan radius command. So now let's select the first object as this line. So I am selecting this line and this one. So the next input is, as we have selected the first tangent and the second tangent of the circle. Next, it's asking for the radius. So based on the radius, whatever we specify, the circle will get located. Suppose if I am specifying a radius of 5, it is located in this manner, so that the end circle is tangent to the first object as well as the second object, maintaining a radius of 5. Let us repeat the same command with a different tangent radius to see how the circle gets positioned into it. So let us give a radius of 1.5. See, now the circle of 1.5 radius is drawn. It might not contact these two objects, but if we extrapolate this object, it will be a tangent to this circle. So this is how we can position this. So later on we can see like how we can manipulate these commands to take an object for reference. So I'll quickly show you something. So basically, so what I'm doing is I'm just extrapolating these lines to the object, and then I'm trimming it off these. Okay, let me roll back. So basically I want to trim this out. Okay. So selecting these three objects, and I'm trimming off this line and also this one. So now coming out of this, so you have got a neat structured object, that is, you have a circle, then you have two tangent line, and then you have an object. So we'll dwell a lot into the extend and trim commands, but you can see how well you can use these commands, that is tangent to tangent radius and all, to draw your images. You can also see the same thing represented in your examples, whereas here the example states that there is two different objects, and the third object of 0.175 is drawn in such a way that it has created a new dimension, and the other one, the tan to three different objects, is used to position a circle within three boundary conditions. Let us try and simulate the same condition and see how it fares. So let us remove all. So for this tangent, there's no direct command available. If you click on tan, this is what has been displayed. That is, it selects a 3p, and then there's again a tan2 command, but if you try and enter it, it will throw out an error. So let me simulate this to you. So creating a circle and then selecting 3p and then tan2, then it will show as an invalid point. Okay, so but there's another command. So to show it first, let us draw random 3 lines and then try and position the tangent to it. So we are selecting in the graphical menu tan and selecting the first object, second deferred tangent, and third. So this is how the object gets positioned within itself. So let us replicate this but with a different command. So let me delete this out. So there's a separate command called AI_circtan. So here it will select the tangent spec, the enter the tangent spec for object 1, object 2 and object 3. So this is an indirect command. This is a quick tip for people who require this tangent command through the command prompt. Okay. Yeah, so this sums up the circle commands. So what we have seen here is there are 3 different categories. we have the center radius, center diameter. This comes in the first part, and second part we have the 2-point method, which specifies the diametrically opposite points of a circle, and 3-point we specify 3 points on the circumference of the circle. And in the third methodology we specify the circle tangent to 2 objects and specifying the radius. And the last method we specify a circle to fit to tangent to 3 objects. So next let's look at the arc command. So arc basically draws a curvilinear arc through different methods. So the first is specifying through 3 points, arc drawn through 3 points with the start point, end point and the center point. So next you have the module for start center end, start center angle and start center length. So here the first two is common, that is start and center is common, where you specify the end or the angle or the length. In the next module what you have here is you specify the start and then the end point, then defined based on the angle or direction or radius. And in the next command what you have specified is the center point and then the start point, end point, and likewise angle and length. So depending on the requirement, which points is available to you for reference and which points are required to draw the arc, you can start with. So let's start with the first method for 3 points. So to type in this, you click in A and it will select the arc points. So you can select the start point of the arc, and next it asks for the second point and then the third point. So this is the first method where you will draw an arc through 3 points in the draw area. So this is the first method, and moving forward the second method, wherein if you want to select, sorry, let me go back here, the arc command. So the second is specifying the start, center and or the end. So in order to invoke this, so let us go with the 3-point method itself, the arc center, and based on the command, if we want to invoke the second model, that is the next point is the center. So first you specify the start point and next you specify it as the center point. So now it will go into this module of execution. So here now first as your second given the start point, now we are specifying the center point. Next it will ask for option of either going to specify the end point, that by default, or selecting the angle or the chord length. So let us first start with the end point of the arc. So as you could see here, the first point is fixed here and then the center point is fixed, and now it is asking for the end point. So based on your specification of end point, your arc is getting defined. So if I am clicking the end point even outside here, it is selecting a line through which it is getting truncated. So for this arc, you have your start point, you have your center point and the third point truncated by this. So this is the 3-point arc command, but again with a start, center and an end point. So let us go back to this same command, start center, specifying the first as start point, then entering C to select the center command, and now so again specifying a center as here. Now let us choose the method to choose the angle. So we'll click on A. So now it will ask for the included angle. So suppose if the angle is 45, so this is the included angle of it. So line drawn to here and this angle, let us draw a line for more clarity. So this is one command, we'll look in deeper here, but quickly let us see what is the angle between these two parts. And so yeah, the angle is 45 degrees. So this command draws an included angle between the start and the center point. So moving forward, so we have the third command in here, that is start, center and the length. So this length actually the chord length, so let us select this. So the start point, and to select the center, press C. Sorry, let me come back again. Select the arc, specify the first point as start point, then mention the second as center, specify the center point, and then click on L to go into the chord length mode. Now you specify the chord length between these two points. So supposing the chord length to be 12, so the arc is drawn with a chord length of 12. Let us draw a line between these two and measure the distance between this. Okay, let us measure. Draw back again. We have to measure the distance. So distance between this point and this point, the distance is 12. So this is your chord length. So this is sums up the modeling of this arc through this method. So you again select the 3-point arc, which is a basic, but you start off with the start point, and when prompted you enter the center through C command, and then specify either it's the end or the angle, included angle, or the chord length. So for the angle, if you specify the negative command, it will take the negative direction. For example, if you give in -45, it will change the direction to it. So this is one part that you can note on the start, center and end point. So next, let's look into this start, end and angle command. So here you will start off with 3-point, but you'll go further, specify the start point, and instead of center you specify the end point, and then select one among these. So let's take it further. So let us create an arc, and we specify the start point, and then we denote that it's going to be the end point. And then see, by default it is asking for the center point for the 3-point, but we have to prompt that no, we are going into the sub command to it. So first let us select the angle as A, and now we have to specify the angle, what is your included angle. So here again let us simulate the negative angle. So if we click on -45, so we'll get an angle like this, wherein let us replicate the arc again. Let us click on enter, so that the arc command is getting replicated. So we'll specify the start point and the end point as E, and then as angle, and now let us give 45 degree positive. So see, this is the positive angle and this is the negative angle, which we have invoked by selecting the start point and the end point and specifying the included distance. So the next command is start, end and with the direction. So this direction is a tangent to the start. So based on the tangent line, an imaginary tangent line, you can draw the arc. So selecting the arc command, start point, specifying the end through E, and then specifying the direction as D. Now see, this yellow line is the imaginary tangent line to which you can draw your arc to. So based on this, changing the direction to it, you can either draw the arc downwards or upwards, or you can change the direction based on the start point. So this is your start point, end point and direction based arc. So next we have the start, end and the radius. So the start point, the end point, and specifying R for the radius. Now entering the radius is 5. Alternatively, you can also click on the control command to quickly change in the direction. So what we have given is the radius as 5, and so here you get your direction. radius through 5. So the start point, end point, and finally the radius. So this is the second part of your arc command. The third part. The first part is the 3 point, the second part is start, center, and the subsequent commands. Third part is start and end. So now let's move on to the next part where you mention the center point and then the start point. So typically this is the inverse of the second module. So you just get interchange. Instead of the start and center, you go with the center and start. This might be useful when you have the center point, but you have to determine the start later. So let us go into this way. So you click on A, and now in order to go into the center mode, click on C. So now the first prompt is for the center point, and the subsequent menu is only one. There is no option here. Only the start point is allowed here. So now click on the start point. Now select the method, that is the end point. So as you saw in the previous methodology, it's the same. So you can select this, and so going on the next one, you specify the center and the start point and the angle, that is the included angle. So 45, pressing again the control, even without entering the negative angle, you can specify in this way. So pressing on enter for 45 degree of included, but with a direction reverse. This is your arc, and replicating the command again using center and the start point of arc like this, and then specifying the chord length, say 45. So this doesn't fit between the start and end point, so it shows an invalid. So let us take a normal point. So center, arc, center, the start point, chord length. So specifying the chord length as this. So this is the fourth option that we have got here. So this sums up the arc command. So also we have one more thing called as the continue. This creates an arc tangent to whatever the object or the last line that we have drawn in an image, so that instead of prompting it further, so for example, if we use the continue command here, it automatically picks out from the last point that we have constructed. We need not specify this point. The last curve was this, so it has started from this. So this is the start point command. So now we can either complete this by mentioning the end point only. So based on end point only, this command works in. So if my end point is this, it gets in. So we don't have the option for selecting the center point or the angle or the chord length, but rather only the end point. But this is useful to continue from the previous point and drawing tangent to that point. So this sums up the arc segment of the draw command. So next let's look into the ellipse section. So before that, let's erase all of it. Okay, so ellipse is invoked by the command el, and before that, let's look into what are the options available in ellipse. So in this ribbon, you can see the ellipse command. So ellipse you can draw by specifying the center point and then the end point of the first axis, and then specifying the half length of the second axis. So as you know, in ellipse you have the major axis and the minor axis. So by these two commands, you specify the major and minor axis by specifying either center or the end point and axis. Okay, so going in, third option is the elliptical arc. Let us look at it for later. First, let us look into only these two, the ellipse through center and the axis. So you invoke the ellipse command by el, and then so it asks for the axis endpoint of the ellipse. So you specify the first endpoint and specify the other endpoint. So by this you are defining the first axis. So next you specify the distance of the second axis. So based on the distance, it can act as the minor axis or the major axis. Suppose if that axis half length is smaller than the first distance what we have mentioned earlier, then it becomes the minor axis. If it's larger, it becomes the major axis. You can see the direction change here. So let us click on here. So by this you have constructed a perfect ellipse through specifying the two endpoints and specifying the axis. So this is your second command here. So now the other command, let's go in here. So let us select the center point. So we have defined the center point of the axis and the end point, and again selecting the other axis length. So the two ellipses are created in the same way, but except one is by specifying the two endpoints and then the axis length, the other through the center endpoint and the axis length. So going through it again, if you can see the center point axis again, the endpoint. Also there's a command wherein you can specify the rotation. So if you click on the R, now this ellipse is rotated along an imaginary circle point. So as you can see, that circle based on the view axis line, you will get a new ellipse. So based on rotation of this imaginary circle along an axis, you will get an ellipse. So this is the other way of representing these two curves. So this is the center, the endpoint, and rotation. Based on the rotation, the axis is defined. So let us simulate this mode. So we select the endpoint of the axis and then again specify the rotation to get the similar effect. So this sums up the ellipse generation through center and axis and endpoint methodology. Next we have the arc method. So you invoke the ellipse command and click on A to invoke the arc. So here you are expected to specify the endpoint of the elliptical arc, the first point, and then the second point, and then specify the distance. So until that point it is same as the earlier. Now comes the additional parameters. So now you can select the start angle from which point is going to start, and then the end angle, so at which point it gets completed. So this gives you an elliptical arc. If you click on this object, you can see what is the original ellipse and what is our arc point. So now moving forward, again selecting the arc command, we can also specify by selecting the center and the end point, specifying the distance, and again specifying the start point, end point. So it means that you are indirectly revoking these two commands, but specifying start and the end angle, you truncate the ellipse to form an arc. This is the arc command that goes into. So we have additional arc commands that can be invoked. So we'll use this command itself. So now we'll specify this. Now we also have a parameter called a P. If you click on P and enter it, you again specify this. Instead of the start angle and the end angle, you specify the start parameter and the end parameter. Based on that, the included angle is computed and figured out. So instead also you can go for the explicit mention of your axis. So in parameter window, wherein you can specify the angle of start and end. So by this you can interchange between your start angle, end angle, or the included angle or parameterization for elliptical arc. So this sums up the function of ellipse. So this is a perfect ellipse that you are drawn. But there is also a system variable called as a P ellipse, that is a polyline ellipse. So what it does is, you can see here you have the P ellipse. So now it is in off condition, that is it will create a true ellipse object. If you click on 1, it's a P ellipse. So now you construct a ellipse So now this is a combination of separate polylines. So each and every point is considered as a polyline object. This is not a true ellipse. This is a true ellipse. You can see here it is seamless, but here it is broken into segments. So this is just a rendering option, but you can also make use of this. This is a hidden command. So let us revert back to the command. So let us go back and make sure we always create a true ellipse. So this sums up the ellipse command. So we have erased everything, and so with this we have completed week's 1 session. So now we'll move back to the Power presentation slide and let us summarize the learnings what we have for this first week. So in this course preamble, we had briefly looked into what is drafting is about, why it is required, and what are the different technologies it employs. And we had also looked into what is orthographic projections all about and what is the first angle of projection. And moving forward, we had a brief overview of what is computer-aided design is and how it has evolved over the ages. And then we had discussed on the AutoCAD features and benefits. And next we've also looked into the AutoCAD interface, the workspace settings, the menu bar, application ribbon, all those things. And next we have also looked into these topics of drafting. That is, we have looked into how to construct a line, a circle, arc, ellipse. We have discussed on different methodologies, how we can invoke them, and what are the commands pertaining to them, and what are the different methods it can be employed. And also we have looked into the usage of erase command to erase each and every the previous commands, and also to retrieve the last erased object. We also have seen the utilization of oops command. So following this, you can look into the assignment to have a practice session. Thank you. Hello, welcome back to Computer-Aided Drafting Course using AutoCAD software week 2, Lay of the Land. So last week we had a look at the course preamble. We had an intro to AutoCAD, the interface, and also we had looked into a lot of basic commands such as line, circle, ellipse, arc, and so on. So this week let us look into the lay of the land. That is, we'll cover the topics such as the drafting settings that will help us to navigate and perform our designs more effectively. We'll look into each and every command. For example, we'll look into object snap techniques, snap and grid, polar tracking, and quick properties. So these are covered in the drafting settings. And next we have the dynamic inputs. This will help to input the key factors very quick. So we'll look into that too. Then we'll look into specifying the limits, the units, and then we'll look into the options that is available in AutoCAD. And also we'll look brief into using the undo and redo command. So following these topics, we'll also look into editing fundamentals such as the move command, the copy command, array command, break, mirror, and offsetting. So using all these learnings, we'll try and execute an assignment for this week. So now let's move over to the AutoCAD interface. So here we have a new drawing, and let us look into the drafting settings. So the drafting settings is available in the menu bar, the classic menu bar under tools. In tools, you have the drafting settings. You can also invoke this by specifying the command D settings onto your command prompt. Let us do that. So I'm closing this one. So type in D settings and you'll get the same. So this drafting settings will help you to do the most frequent tasks or the intended drafting techniques that you want to employ. So let's start off with this tab, the basic tab, the object snapping. So in this object snap, you will use the commands to snap the next point to any one of these basic requirements. So if you hover over this object snap on toolbar, you can look into the details. So this will enable the snap command on or off. So this also can be actuated by using the function 3 shortcut. So when you enable this, you have the other options that is available to you. But if you disable it, these won't be available. That is, you are not going to snap it. So let us quickly see one example what the snapping means about. Okay, so let us turn this off and look into. So let us draw a rectangle first and then try to fit a circle into the rectangle. So now let us use the rectangle command. This is one such command. We'll look into this in the later part of today's course, but let us quickly prompt this one, rectangle. So we just specify the first and the last endpoint, the two corner points. Now we have got the rectangle. So now this is going to be single object. Now let us try and fit a circle into this rectangle. So remember, we have turned off the snap command. So as you can see, I'm not sure where I should place my center point and what should be my radius, because this rectangle is of arbitrary dimensions. So in order to know that, I have to use this measure command to look into what is this distance. So let us use this quick. So by hovering here, we can see the width is 15.9938 and the height is 8.2647. So we have to do the calculation to figure out the midpoint of this rectangle so that I can set my center point and set the radius using the height. So this complicates things. So this is where it is beneficial for us to go into the object snap technique. So let us turn that on by pressing function F3. So you can see the command has actuated object snap on. So now let us try and repeat the same step. Let us take a circle and you can see something pops up here. So one thing that is if you hover it here, you can understand that it is snapping to the endpoint. And when you extend it, you can see how far you are extending from that corner point and what is the angle pertaining to it. If you could recollect the relative polar coordinate system that we are talking about in the previous week, you can see it is showing a relative position 18.6696 from the point at a polar angle of 180 degree. And if you go this way, it's 90 and so on. So now it's again snapping to exact rectangular polar, that is, it is snapping in the 90 degree 180 degree perspective. So but we also wanted the center point. So let's look into how it can be actuated. So let us go into the D settings. So now as you can see, the object snap modes have been enabled as endpoint, extension. This is what we were getting at. So let us look into what other object snap modes are available. So this first endpoint will snaps to the closest endpoint that is available. It might be a line, an arc or multi-line, whatever it is. It will always look to the endpoint of it or the corner. Whereas in this extension, it will look into a relative distance from that endpoint, and it will also plot you a temporary extension line so that you need not execute a separate construction line or a drafting line for that purpose. If you enable this and make sure you're turned on this snap tracking also, so this will ensure that the cursor is aligned to the path that you want to take. So okay, let us also see in this function. Let us take off this object snap, that is function 11, and look into. So here I can move over the cursor whichever way I want. But if you click on the object snap, then you can make sure. So now I have turned on the object snap. So now you can ensure that the cursor is snapped on to this object. So this is the function of the object snap tracking menu. So as we were discussing, we had looked about the corner point and the extension menu available. So let us look into the more settings there. Yeah. So next option we have is the midpoint. So this is what we were looking at. That is, if we want to plot the center of the circle through the midpoint of both the minimum and maximum dimensions of this object, then we can enable this point. The midpoint specifies the center point of any object, let it be an arc, ellipse, line, or what a spline object also. The computer will compute the midpoint and then give you a snapping track. It denotes to the center of any curvilinear object, that is be an arc, circle, ellipse, or an elliptical arc. Whereas this geometric center represents the geometric center point of a polyline or a 2D polyline and spline. The next command, the node, is useful when you are tracking to a dimension text object or a point object. So with that, you can define the object by nodes and hence track it to those nodes, because these will be hidden. For a text box, this will denote the boundary of the text box. That is typically hidden because you are looking only at the text dimensions into it. So this will help us to position the text box in such a way that the objects are aligned. So next we have the quadrant. So this option will snap to a quadrant point of an arc or an ellipse or an elliptical arc. This intersection is useful when you have an intersecting objects, multiple objects, and you want to find or snap to the exact intersection of those objects. So this is a useful command when you want to execute a drafting command from an intersection point. So next is what you have, the extension. So here it will draw a temporary extension line as we had seen, so that you can specify a point outside the object. And next you have the insertion point. So this again snaps to the point where the object, as we had seen earlier, the nodes of a text, it denotes the boundaries, whereas this insertion, it denotes to the point where we had located that object, so that it will snap to that exact insertion point of the previously inserted block or text. And this command is perpendicular to, so when you're drawing any object and want to position it to perpendicular to a secondary object, you can use this command. So next you have a tangent to command. This we had seen last week where you were using the tangent option, where you can see this icon, so that will list to tangent to the selected object. So in certain case we have also seen the default tangent option that is turned on by default. So this is used to draw a line that is tangent to any arc or circle. So this is a default tangent snap point. Then also we have this command called the nearest point, wherein it will snap to the nearest point that is available to that object. It need not be an endpoint or a midpoint, but it will look into the shortest point that is available to the existing object. Next, there is this apparent intersection. So it means that this will not be applicable for us in the in the 2D space, but imagine if two objects could be intersecting in the 3D space, but maybe in the current view what we having, that is in this plane of projection, it might not intersect, but it might be intersecting in the other view. So the software computes that apparent intersection and allows you to snap to that point. Then finally we have parallel lines. So this will help you to constrain any object and making sure you stay parallel to that. These are the commands that are available to us for placing quick input setting. So let us enable all and check how we can do this, place the circle within the rectangle. So now we have enabled all the options. Now let us look into the circle again. So now as you could see, here you have multiple commands. So you have here the different nodes, and then you have the midpoint here, and then this command says it's perpendicular to this line, and here you have the end point, and it also shows what is the distance between from the midpoint, and then again snapping to here, and then it also shows the center point here. It's shown by circle here, and then it shows the perpendicular symbol because these two lines are perpendicular to each other, so it shows the perpendicular intersection of this point, and also it shows the extension from the other corner to this point. So these are the different nodes. So this is your nearest point, nearest extension node. Let us go into the command to look into further. See, we were talking about the nearest intersection node. So this is where you get the nearest point. So I can pick this point that is nearest to this. So now, as we said, now this circle center point is being located. So now we are getting the geometric center of this object. So now let us click on this. So it has snapped onto the geometric center. Now for the diameter again, this is what. So I am looking into the midpoint of this, but rather we can also select anything else, but our objective was to snap to this midpoint. So now here we go. So you have got the perfect circle inscribed into this rectangle. So this snap commands is what helps us to do such quick tasks. So let us look into some advanced features. Let us plot a line. So now if I want to draw another line that is perpendicular to this line, this be the starting point. So if you can hover here, you will find a point where it is in the perpendicular location to it. Suppose if we are not able to get the exact nodes, what we can also do is we can press in the control button and right click on. So here you have an extended option to select what is your intended one. So let us select this perpendicular one and see where it gets snapped. So you can see we are now overriding the other options and looking at a point only perpendicular to this object. So this is your perpendicular line. So now this is how you enable a option that is dynamic. So you execute a command, click right with control key button. So now you can see a parallel segment and all. So now as it is overriding this, so it shows that the second line would be parallel to this line. So this is the in drawing menu access of this snapping points. Okay, so coming back to this object snap, so we had a detailed look onto usage of this object snap functionality that will help us to quickly execute the fixation commands that we are looking into. So next let us look into the other snapping command we have called the snap and a grid. So now what we have looked at object snap is snapping to a previously set object, but this was helpful, the snap and grid, wherein we have to snap to a point on the workspace in an incremental step. This hotkey is F9 for enabling this snap on. As you could see, whatever operation we had done earlier is with this snap on turned off. So let us enable the snap on, and then the default spacing is equal spacing of X and Y with an increment of 0.5. So let us quickly see how it's going to create. So let us create a line command. So if you could see, the cursor movement is not smooth. Actually, it moves in steps. This is what we had specified with the incremental command. So actually, in the x-axis and y-axis, the cursor is moving in incremental steps of 0.5. So let us start this command with line. So let us start with this point, and as you can see, it is going in incremental steps of 0.5 only. So for your understanding, let us draw two lines nearby. And see how the distance fares. So this is in 10.38307 and this is in 11.18. So this again depends on the units that we have specified into. So let us look into that in the second part. But the key takeaway from this snap grid setting is that you are snapping with an incremental x and y. So this snaps goes off when you are out of the drawing command. So now you can see the cursor is moving free, but if you go into any command, that's where your snapping takes place. So now let us go back into this settings menu. So this is the function of the snap, and next we'll specify how it is going to snap, whether it is going to snap in the rectangular manner, that is in x and y, or it is going to snap to an isometric mode. And also we have a polar snap. So let us enable this. So now you can see this is your rectangular coordinates in the grid mode snap. So now when you give in the polar, so it will snap in the polar angle. So based on that, for example, if the snap value is 0, it is for a uniform snap spacing in x. If we specify an alternate unit, say it is 0.25, so your snapping is enabled in that manner. Okay, so this is the function of the snapping object. So typically we will use the grid snap only because we are snapping to the visible grid points in the screen. So this will help better to do our normal task. But if your situation warrants that if you want to do a polar spacing, you can explore that to your requirement and then execute it. So the next step is your grid. So if you can see this, now we have turned off the grid and see it is a plain blank space. So you can enable it back by setting in the F7 button. So when you're enabling back the grid, it will help you to position it much better. But if you want to work in a gridless environment also, you can enable it by turning it on or off. The same settings, the quick settings of this, the D settings is also available on your status bar. So here you can see it's the grid mode and it's the snap mode enabled. So in this drop down menu, you can also select from the whether it's a grid snap or polar snap, what we have seen here. So let us go back to this menu, the snap menu, and so here we have the options to where this grid style is located. So where should the grid be displayed? In the 2D model space or in the block editor mode or sheet layout. So we'll look into it in the next stages. But here it is the how far the grid has to be spaced within each other. So you can play with it based on your requirement, based on the scale of the sheet. For example, if you are working on any civil based project that span for kilometers or hectares together, then in order to constrain everything into your domain, you can select your grid accordingly. So this 0.5 might be 0.5 mm or 0.5 meters or 0.5 kilometers, whatever it is, based on the units that you are specifying, your grids get spaced accordingly. So next is you have the behavior of the grid. So right now by default we have always the limit adaptive grids, that is whenever we are zooming out or into it, the density of the grid is getting adapted. Whereas if you take away, it will remain the same. So the difference is when we are zooming out, it is the spacing is getting adapted. Whereas if we go back and remove this off, you can see the grid has been removed, and hence you are working with your overall units that is available to you. And this command is used when you are working out of limits. This also specifies a grid to be displayed outside the working limit that you are working on. And this is a user control system, that coordinate system that we have discussed earlier. So whenever we are this can be enabled so that the grid always follows the plane that we had selected based on the user. So this is about the snap and grid menu. So now let's look into the next desetting command. So let us open back. So here we had seen snap grid in the previous step. Now let us look into the polar tracking. So this enables tracking mode on with respect to the polar coordinates. So let us turn this on now and see how it increments. So now let us quickly look back into a ellipse. Let us construct an ellipse. We are specifying the center. Now you can see the snapping is respect to the polar coordinates. So look at the angles at which it gets snapped to. So it snaps at 0 degree, 45, 90, 135, 180, 225 and 270. So these are the snapping polar coordinates. So let us look more into this detailed settings. So here you can see the increment angle we can again settle based on what is the angle that we require. So based on the increment angle, it will snap automatically. So our increment angle was 45. So that's why it was snapping to every 45 degrees. So if you specify the increment angle to be 90, now we repeat the same command and you can see that it snaps to only 90 degrees. So there is no 45 degree snapping here, and it snaps to the next 90 degree. So by this, based on your requirement, you can enable the polar tracking on by F7 and specify what angle that you need to do. But if you want to specify any custom angle, then you can enter any new angle. So let us say it has to snap at every 132 degree. Then so you will have an additional setting that will help you to snap in increments of 132 degree. See, this is where our 132 degree comes in. So this helps you to customize the polar tracking that you want to do. So other options in polar tracking is you can either track the objects along the orthogonal direction. Orthogonal means absolute to 0, 90, 180 and 270. Whereas also we can track using other polar angles. So based on your polar angle settings, it can also track with all the polar setting angles. So this is one option that you can look into. And next, what is the angular measurement? So right now what we are used here, these angles are absolute in nature, but you can also make it relative to the previous angle that has been set in. So this is relative to the last segment. So this is about the polar tracking methodology. And next, let's quickly look into the 3D object snap methodology. So if you are working on a 3D modeling, then these will help you out. It is similar in structure with respect to the 2D object snap, except in 3D option you also have additional facing that you can snap to the edge or to the face of the 3D object or to the edges available, the corner, and with respect to planes you can snap it. So this is available for the 3D object snapping. AutoCAD result shows that once you start working on 3D, and snapping basically computes the distances in the background and extrapolates it for us for quick reference. So this can also slow down the performance. So based on the requirement, you can select which is what. But here in the 2D snap, this computation is pretty fast, so you can enable everything, or if you don't want other snapping to interfere with your work, you can select only which is necessary for you. So next, what we have here is the quick properties. So quick properties helps you to look into the details of that object in a faster manner. So right now by default it is not enabled. So you can enable it by clicking on this icon or Ctrl+Shift+P. So this is available also in your status bar over here. So if you click on this display quick properties and click on OK, you can see that this quick properties icon has been turned on. It's also enabled by the command QP mode. So what does it do exactly? So let us draw a rectangle and maybe draw a circle of arbitrary dimensions. I don't know what it is. So previously when we wanted to investigate, we were using this measure commands. We'll look into the measure commands in detail, but we were predominantly using this to check what its dimensions were. But now as you can see, we had enabled the quick control option by pressing in Ctrl+Shift+P, and now if you click on the object, you will get a opening menu stating what is this object, in which command it has been executed. So this is a circle command, and what is the layer and what is the length. See, if you could recollect, if you hover on the object, you can get the top 3 info of this property in the info tip. But in the quick properties, you have additional input also. It is showing the center point, the location of the center point with respect to the axis in the user coordinate system, and then the radius of it, the diameter, what is the circumference, what is the area. So you get a collated information of that object pretty fast with this method for quick properties toolbar. So when this is heavily used when you are investigating an already existing drawing, you are doing a quantitative analysis onto that drawing, then this is what will help you. So consider it's a complicated object. Say let us draw a polyline. So let us look into this detailed polyline, rectangle and polygon towards the end of this session. But let us quickly draw a random image. Consider this is a boundary fence of a playground. So what is this? So this is a polyline and the info pertaining to this. So you can also edit what details you want to look into. So you can see this is for customization menu for this, because we were expecting the area, length and all. So let us enable this for a polyline object. Let us enable the vertex coordinates and then also maybe the line weight that we require, and then click on OK. So now if you click on this, you get the additional detail. So it is show that the vertex point, the overall area, what is the length and henceforth. So this is the additional data that you can use in through the quick properties toolbar. So by default, AutoCAD does a multi-selection option. So if you click on these 3 objects, all 3 will be highlighted and the common properties will be listed. But alternatively, you can still select which do you want. So now the rectangle is also being quoted as a polyline. So and hence that's where it is getting grouped together. So by this you can use the quick properties toolbar to evaluate the properties of that object. So let us go back into the menu and see about the quick properties toolbar. So here this is the collation operation, wherein in the palette whether you have to list all the objects or only the objects with the specified properties. So you can alternate between these 2 options, and then this command specifies where the palette should be located. So right now by default it's in the cursor dependent one. So where our cursor has been located, based on that it fixes onto the top right quadrant with a distance of 50. So but if you want that to be a static point based on your cursor location, it always stays in a single location. It doesn't vary from object to object. So you can use which is comfortable for you. And next is the palette behavior. So what is the maximum number of rows that it can have? Suppose you have multiple number of rows, and then you can enable this object so that whenever you're defaultly having that palette, it will be in the collapse state with listing only 3 properties. So let us do this. So when clicking on it, you can see the palette is in collapse state, whereas if I hover on it, it will get expanded. So this is a space constraining method. So based on your requirement, you can work on it. So this is about the quick properties toolbar. So now let's look into the dynamic input modes. So in the first week, we had seen during the construction of line for polar and coordinate system, relative coordinate systems. So we were using different commands to specify the dimensions or inputting the values on the screen itself. The other way was doing on the command screen. So let us do a graphical inputting. It's called as a dynamic inputs. So to enable that, you can go into the you have to turn on the dynamic input mode. So to do that, you can either do by going to the status mode in customization and enable the dynamic input tool here. So once you enable this, you will get a pop-up here stating the what is the dynamic input mode. So currently it's in off mode. Let us turn it on. So now the dynamic mode has been turned on. So let us remove this object and start afresh. So let us draw a circle. So prompting by C. You can see the dynamic input has prompted here. And now in this dynamic input, there are 2 information that is available. So once it specifies the user what he should do next. So it is prompting the command prompts first thing, that is the specify center point. So what is the tool expecting out of the user to do at this point? So it is asking to press the center point for this circle. And next you have the dimensions. So for the center point, we have earlier see it is a absolute coordinate or relative, whatever it is, we can specify based on this input. So by pressing on the tab, we can circle among the selection. So this is what the dynamic input is about. So once we have clicked on it, so next input is what is being expected. So it is asking for the radius of the circle. So this is the usage of the dynamic inputs. So you can also see here the other command that is expected. So it is asking specify radius of the circle. We can enter the dimension that is required directly or press enter. So now if we press the dimension and then click on enter, the circle of 45 is drawn. Or if we press on enter directly, it will take in the previous dimension what is already there, the enter or space button. You can see it on this screen here. So if you press on it, it is taking in. So this information is displayed in the dynamic input screen. So let's look into what other info is coming into the dynamic input. So in the drafting settings tab under this dynamic input, you can see what are else getting captured. In this dynamic input, we have the pointer input enabling and then dimension input enable, and also we have dynamic prompts that are listed. So in this pointer input is where once you have entered the first point and then it will prompt for the second input and so on. So let's look into this. In this setting you can see by default it is referring to the polar format as well as in the relative coordinate system. So when typing, we can change to the next value. So polar coordinate, as you could recollect from the week 1 session, when you are specifying a less than angle, it is selecting this. So by pressing on the comma, you can change from the polar to the Cartesian format. So when we are pressing on to the angle system, when from the Cartesian format, it will switch back to the polar. So let us do this once. So let us draw a line. and you could remember the polar system is in place. So that's why you're getting the next point as polar, but rather you can specify by entering the next point. So let us go to the Cartesian coordinates. So by prompting the first x point as 50, then specifying the comma, now the mode is been changed to Cartesian format from polar. So now let us give the next point as 34. So now we'll come back out of the line command, go into the settings tab to see what it has been reflected. So even though the default is here, on the dynamic input screen we are moving over to the default setting by forcing it using comma or angle symbol. So the same happens when we can switch over from the relative coordinates to the absolute and vice versa. So relative coordinates is being used with the @ symbol, and if you want to revert back to the absolute coordinate, you can enter by the pound sign. So this is how you interchange from one dynamic input setting to the other when drafting. So this is the visibility of the tooltips that are going to display. So by default, whenever a command asks for a point, this tooltip is going to execute. So this is about the pointer input setting. So next is the dimension input settings. So where you can see what are the dimension input fields it has to look into. So the maximum it can show is up to 2 dimension input and is by default. For example, if you want to input multiple dimension fields, then you can select this command and execute. So it will show what is the output dimension of that point that you're going to specify, and what is the length change it is going to change when you move the cursor, and what is the absolute angle, what is the delta angle change, and what is the arc radius. So based on this, you can input the dynamic dimensions. So this is about the dimension input settings. So next is the dynamic prompts. So whenever we have any queries or doubts, so this first input from the command will be displayed in this thing. So we also have the drafting tooltip input. So whether what should be the size of the input box and what should be the transparency. So we can control this based on this drafting tooltip appearance. So this is about the dynamic inputs. So next, let's look into the overall option segment. So in each and every command tab here, you can see there's an option command. So when you click on this, you will get the options command. So this is the application menu option, and it pertains specifically, let us look only into the drafting command as of now, because others you have the file control menu, how the display should be, what is the resolution of it, and how and where it is saved, what is the format of saving, and what is the format of export, all these things. But currently let us focus only on this drafting setting. So here, what is the auto snap setting that it should look at? Should it be displaying to the marker, and should it automatically snap to the point, that is move the cursor to the snap location that it has found, and whether there should be an auto snap tooltip that is enabled, and whether there's an aperture box that is shown. So, and also you can vary the colors what you have to shoot. So by default the color is green, but you can customize it as per your requirement. And then what is the auto snap marker size? Should it be this way or should it be enlarged? So you can have a control over this. And what is the aperture size or the crosshair that you can say? So what is the size of that, and what is the tracking settings? So based on this, you can customize the view that you have. And in the drafting tool settings that we had seen previously, you can control the transparency and the size of it. So now we had invoked this options command from the dsettings command. So now let us look into how we can invoke this command using the command prompt. So by clicking in OP, you can get the options. So alternatively, you can also go to tools and then click on options to get your options command. So this is the way of accessing the options command. So now, having looked into the object snap commands, so let us quickly look into a short tooltip that can help you to accelerate your snap commands. Assuming you're drawing a line and you want to draw another line that is perpendicular to it. So as you can remember, in the object snap command, we had enabled almost all the options. So it is snapping to multiple points. So supposing you want to snap to the perpendicular point here, so how can we do this? So when it's prompting for the next command, it's called a transfer command. You can type in the expected one. So if you prompt it for perpendicular, you type in the first three letters perpendicular. So it will enable that perpendicular snap so that you can snap to that particular point. So this is alternate to what we had spoken earlier, that is through pressing Ctrl and right click and to select whichever we want, but rather we are using the dynamic input setting. So we are specifying the requirement from here. So it always prompts when you are clicking on to the next point. So now this point is getting snapped perpendicular to this. So this is the a dynamic input object snap functionality that AutoCAD offers you. So now let's look into the other lay of the land commands, that is to understand AutoCAD more, to look into the methodologies where you can control your drawing is what is limits and units. So in limits you specify the hard boundaries of your model space. So the model space is where you are working on. So sometimes if we don't specify the limits, it will go outside the boundary areas and it will be difficult for you to bring that into your drawing space. So when we are looking into the layout space and model space, we'll look in more detail in it, but just let us now enable the limit controls by typing in limits. So now by default, let us turn the limit on first. So let us type in on. So now the limits have been turned on. Now let us specify the limits again by clicking in limits and specifying the lower left corner as say 0,0 and upper right corner say let us restrict to 100 units. 100 units in the X and 100 units in the Y axis. So now let's try and draw a circle with a center point of say 150, 150. So now the circle is not getting executed and is still waiting for the center point. Why? Because as you could see here, as we had specified the limits to be 100 and 100, the specified limit says that it is going to be outside the limits of the model space. So by this you can restrict the command that you are going to work on. So this is a very mandate, and I would recommend you to set your model space limit first and then work on your drawing. So this is about the limits command. So you can also view the limits in the format setting and then drawing limits. So this is the way of limiting the model space. Next, let's look in the units. So we have been speaking about a lot on the units, because earlier whatever we are speaking in the dimensions, we always speak about certain units in the X direction and certain units in the Y direction. So what are both those units? We were speaking in architectural terms, it might extend to kilometers, and in engineering terms, it might be very precise, say in microns. So how do you limit that? So you use the units command to specify the drawing unit limitations. So here you get two types of units, one for the length and one for the angle. So you can specify what is the type that you're going to use. So the variants what you have is architectural, decimal, engineering, fractional and scientific. You can explore each and one of it and pressing by respective one. So if you change to the architectural unit, you get it by inch and foot. And in decimal, this is the default, you will get the units in decimals. And in engineering, where it is in inches but still the resolution is higher, so you can specify the precision accordingly. And in fractional, when it goes to fractions of those units, so then this will help you out. And finally we have scientific, where it's either astronomically a huge number or a very small number. This you can use to specify the scientific precision. So based on the type that you have selected, the precision also varies. So you can select it whichever suitable to it. and then again specifying the angles, whether it's in decimal degrees or in gradients, radians, survivor units. So you can select whichever is appropriate to you. And also when discussing on the angles, earlier we had mentioned that it is always anti-clockwise. If we want to override it by selecting on this, so the direction will get updated. That is always, it will look into the clockwise direction. The positive will be always in a clockwise direction. So let us roll back to the basic default settings, and this is the variation that you can look into, whether it's meters or kilometers, and hence whenever you start your drawing, always make sure that you have enabled your limits. For example, if you are working in a paper of A2 size, specify those limits. So basically you'll be working within of stream, so specify those limits. And secondly, specify your units that you work on. Specify it as inches or millimeters, so that you are keeping track of those units, and this is going to get captured in your final drawing also. So this is the unit command. So now this pretty sums up the basics what we have looking at the lay of the land. How about you navigating the tools available in AutoCAD to suit to your requirements? Next, let's look into two frequently used commands for navigating through the commands, that is the undo and redo. If you could recollect, we were using oops command to undo any mistaken erasing option. So let us redo that. Let us use the erase command to delete this object, and we were using oops to revert back the erase command. Alternatively, we can also use the U command to undo it, and redo command to redo it. So this redo should immediately follow the undo command. We were talking earlier that oops and undo are, even though they are doing the same task, it is slightly different. So oops always restores the object that has been deleted earlier, but undo do all the actions that were done earlier. So this is what we were seeing about. This icon undo in the quick access toolbar can also do multiple actions. So it can roll over to so many actions and the commands that were executed on. So you can see whatever commands have been undone. So the number of commands that were undo were the oops, then the erase command, units command, group command, then limits command, everything has been undone. So the same way you can redo in whatever commands you want. So whatever we have undo, we can redo. So we had undone 18 commands. So now we can redo back this 19 commands. So this is the facility for undo. And earlier, when you use the command of U only, it will immediately undo a single task. When you type in undo, it will ask you how many commands you can undo. That is the command way of doing what you had done earlier in pictorial. So let us undo 15 operations. So likewise, if you want to do multiple redo, you type in M redo, and let us roll back these 15 commands. So this is how you work around with the undo and redo commands to do your thing. The only thing you have to note is undo and redo does not do system level activities, system level operations. That is for if you had given a print command or save the file. So those things cannot be done. It will always do on operations that you have performed. So now let's start looking into the editing fundamental commands that we were speaking about, and first with the move command. So we'll start off with a rectangle first and plot it something like this, and then take out a circle. So now what we want to do is, I have misplaced the rectangle in this position. I wanted this rectangle within the circle. So in this case, you need not delete it and then move. Assuming that these two are of the correct dimension, but only the location had been changed, then you can use the move command to affect that. So in order to do that, you can type in move, and it prompts for this object selection. So we want here to move this rectangle from here into this circle. So this object that is required will be the rectangle. So once you have clicked in here, and it will prompt for other objects also. So you can terminate it by pressing enter or space, and now it will ask for the reference point from which the object has to be moved. So we can, based on the different endpoints that are available to us, we can select it. So assuming that this endpoint with reference to this, I have selected it, and then I am moving across and clamping to this nodal point. So by this we have moved this object. So this is the function of the move command. Let us explore what else it can do. Let us undo by pressing Ctrl Z, or rather U command. So now we have undone the move command. Let us replicate it again by moving. I select this object again, press enter, and instead of this I want to specify this as the base point. So this object with reference to this base has been selected, and then you can, instead of specifying the other nodal point or a trimming point, you can also specify the distance that you can do. So you can specify as either a polar coordinate or a relative coordinate system. So consider at a distance of 8 with an angle of 140. So this is how it's getting positioned. So this is the move command by using the relative distance as input. So this sums up the move editing command. Now let's see the copy command. So in copy, what we are doing is we are duplicating the entry of a previous existing object instance. So let us type in the command. So it is copy CO, and assuming we want to duplicate this object, selecting and clicking on enter, and the base point from which it has to be displayed. So selecting this corner as base point and then pressing it here. So as in line and other commands, the copying won't stop until we manually come out of the command through exit or enter. So this is the way of copying. So in copying, what we do is we are not deleting the original object, we are creating instances of the other images by specifying the start point and locating it elsewhere. So this is the function of copy. So alternatively, whatever we have spoken about the earlier move and the copy commands are all available in this modify tab and also in this modify menu. So an extension to this copy command is the array command. So you can very well look into the copy command itself. Once you select the object and selecting the displacement point, it will ask for the final endpoint or specify as an array. When you do it in such a way, when you specify A, now it looks into the number of items it should replicate to. So let us give us 5, and so the same copy command, but in an array sequence it is executing. So this is one way of replicating the array mode into copy command so that it is executed. But let us roll back and look into the dedicated array command when you want to do such things. So in order to do that, let us remove temporarily the images and try and recreate a smaller rectangle file. So now let us look into the array command directly. So by typing AR, you can prompt the array. So you select the object, press on enter, and you have an interactive menu asking which type of array do you want to do. It's a rectangular array or a path based array or polar. Let us look into each and every one of them in the graphical user interface first. So let us select this rectangular path. So once you have clicked in, you can see that you will get an additional ribbon tab over here specifying the inputs that is required. So what you do have here is, this is a rectangular type of array with the column details, row details, and the levels between different layers. So, and then also there's a property tabular with which you can edit the array command totally. So if you want to have 6 columns with 4 rows each, you can see it is being replicated onto the screen. And what is the spacing between the columns? Say if you want to space it evenly as 8 units and the distance between the row as 3 units, you can update it the same way. So likewise, the overall distance is being computed, the total distance between the first and the last. So alternatively, by editing on this, you can control the positioning also. So suppose if we specify a unit here, the spacing is adjusted without adjusting the number of elements. So likewise, in the columns, you can replicate the spacing. So if you want to constrain the arrays within a given boundary, you can go for this. Or if you want a specific dimension that needs to be put in, then you can use this. This levels also denote if you are working on different layers, or then you can use this command. Then comes the associative property, wherein the object is an associated array from the base. You can use this. And suppose if you want to override the base point, then you can also denote this. So let us look into resetting of the base point. So if you click on this, so now it will prompt us if you want to shift the base point to a different location. So suppose if you are moving the base point to here, and hence your objects remain same, but the referencing starts from this point. So when you change the spacing involved relative to that base point, it will get adopted. So this is the specification of base point. So suppose if you want to move array this object with reference to a different object, you can choose to change the base point reference. So let us revert back to the original base point, and this is how you are getting the array screen. So let us revert back and recreate the array and look into the command prompt of doing this. So instead of selecting on the GUI, let us type in R to select the rectangular array. Alternatively, you can also type in ARRAYRECT array rectangular to directly prompt for the rectangular array object. Okay, let us revert back a little bit. Yeah, type in now array rect to directly opt for the rectangular array, and now you get the rectangular array option. So now whatever options you have seen on the top in the interactive menu, you can get the same here. So you can select whether it's going to be an associative or not. So if you click on AS, it will ask for a prompt to turn it on or off. By default it's on. So if you want to turn it off, you can do so, and specify the base point by setting in B. And so you can alternatively say at which key point it should be located, so that based on this the base point has been modified. And now again the number of count of the columns and rows can control by count operation. So first operation is for the columns. Suppose if you want to have 5 columns and rows as 6, you can specify so, and then the spacing between each and every column through yes, specifying for the column first and then the rows. So every time you do this, you will get back to the base array rectangular command, so that you can keep on looping it out until you are settled with the overall output. You can also get this expression way, wherein you can specify the overall distance. So this is by saying that the total rows is 15 whereas the space between is 5, and incremental elevation between each and every element say 2. So you are positioning between these rows in this manner. So you can use the total or expression command to do additional operations that you intend to do. And next, if you want to come out of it, you can click on enter, because by default exit command is already filled into the tool. So by clicking on enter, you can come out of this screen. So this, what we are seeing is the second way of doing it through the command prompt. So we have reverted it back. Now let us look into the other way of doing it. Array, clicking on this object and clicking on just enter specifying rectangular. Now by default it has been plotted, and now we can use the grips to edit it. You have a starting point, end point, and then number of column command and number of rows command. So by hovering over here, you can see the specification. So by this you can graphically do all the operations that you have been doing by selecting the ribbon or through commands. Let's now try and increase the number of columns. So hovering over this arrow shows that the number of columns is 4. So you can click on this and then drag along the axis to specify the number of columns. And similarly to the number of rows, we can edit it graphically to modify it. So next we have internal editing to specify the distance. So here the distance between the first with respect to the base point is 5.24. So by clicking on this and editing, so now each and every object will be equispaced based on the values, and the same for the rows. So this is the way of editing the array dynamically onto the screen. So next we have the grip of this edge to continuously change the number of rows and columns together. So based on the position of it, you can either have a equi-element row or column, or separately the rows or column. So this is the rectangular array methodology where you can replicate it. So this is very much useful when you have equi-spaced elements and they are larger in number, so that the copy command won't work that much. Then you can use the array command to execute it. So now let us go to the next part of the array, which is called as a polar array. So in polar, what we're going to do is we are going to position the object in a base to a fixed center point and then revolve them. As you could see here, this is the reference object and we had picked the center point as here, and the other objects have been positioned along this center point. So here I have zoomed out using the mouse scroll option. So here you can see this object is same, whereas the other objects are equi-spaced and also they have been rotated. If we click on this icon and remove the rotation and direction, you can see it is the object is retained the same, but the direction is also retained. If you click on rotate is where you will get the object rotated based on the angle of the position. So now this is called the polar array. So here again you can specify the number of objects and the angle by selecting this grip. So here we can specify the angle between the items, but you can notify here, even if we increase the angle, given the shape of the item, it is getting restricted. So now the angle between these two is 47 degrees. If you want to fill in more items, you can type in here to position it, maintaining the distance between them. So here you can see the fill command is used to specify the first and the last angle item. So based on this, the items are filled and their angle is getting adjusted. So assuming this angle to be 275, so the same number of items will get EQ spaced. If you can recollect the previous one, we have specified the total distance between the first and the last column. So likewise, in the polar array, you can specify the overall distance and fill the angle between them. So this is the way of doing polar arrays. So then again we have the associative behavior as we discussed earlier, and then relocating the base point, and then rotation in whichever format we want. So the same can be effected in the graphical way and also in the command prompt way. So this sums up about the, and also you have the number of rows. So it means that you can replicate in the outer or in the inner direction. So based on the requirement. So we have specified the number of rows, and then you can specify the distance with which it will get EQ spaced. And so do wait for some time. Maybe with the computer capability, it will get a little bit time to get it rendered properly. So wait and then look into this. So this is specifying the polar type of array with the number of copies and then replicating the number of rows. So this is about the polar array. Next we also have something, the array along a path. So let us roll back. So let us draw an arc following the path. So let us draw an arc with a starting and the end point as these. So specifying the radius of the arc. So let us assume this is the arc. So let us replicate this object along this path. So let's go into the array and select this object, select as path, and we want to have this along this path. So as you could see, now same as in the polar coordinates, we can see the same effect here, but now it is being replicated along the path. So based on this, the handle, again you can control how many replications are there and what is the distance between the replication. So you can see the number of items that you want to specify, what is the spacing between them, and what is the total number of distance between the first and the last items. And also you can, same way what we see in the polar coordinates, you can specify how many rows that you want to plot to. So it is plotted from the base point in the exterior manner. So it's always a positive unit. So this is how you vary the number of rows and number of spacing based on a path that is chosen. So this is very useful when you have something to trace along a path or something. Then you can use this command. For example, you are positioning a hole on a spline in a drawing, then you can draw that spline and then use this path command to replicate the multiple holes along the spline. So this is one way of doing it. Then again you have this align items, so you can take in so that you can have the same view. So it depends on your control, but as you could see, when you take off this align, so the first is object has been taking the same shape, but it will get into the path. It need not necessarily trace the path. So that's why this align will make sure that the distance between each and every object is maintained, this corner is maintained, and hence it is replicated. This option by default is enabled, but this is to draw in the 3D path. So next, again you can specify the tangent towards which it has to be drawn. So based on this, you can control the angle of how it's going to get placed. Then also you can specify the current measuring method, how it's going to be spaced between each and every path. So whether it's the spacing or dividing by the total. So here the total distance is 62. So based on the number of items, it will get divided by the total distance. Whereas in the measure, only then you will get the distance highlighted. That is, based on the distance, the number of items it will get automated. So this is a way of controlling the arrays on a path. So this is about arrays. So feel free to explore into the command prompts for each and every methodology. Essentially whatever you have in this ribbon is replicated here, and based on your requirement you can highlight and then explore. So this is about array tool. So now let's look into the break command. This is a very useful command. It can be used as a standalone tool as well as a merge tool with others. It is similar in application to trim command, but let us look into this basic command. So first let us draw a rectangle, and then let us draw a circle passing through this. So assuming you want to delete this part, an erase command deletes the entire object, but you want to delete this portion alone, then you can make use of this break command. There is an efficient command that is available called as trim that we'll look into the next sessions. But let us see how we can use this break command to do the same. So this break, what it does is, it breaks the object, a single object, into multiple objects and removes away the selected part. So it's actually two parts. It is converting an individual object into multiple objects and then removing which is not required. So let's look into one way of doing it. So click in break and select which object you want to break in, and by default the point that you select is automatically selected as the first point. You can see here the highlighted part. So now alternatively you can specify the first point by typing here and specify that this is the point that you want to break and this is the second point. So as you could see, now this rectangular object is being broken at these points. So similarly you can replicate the same by removing for this circle. Break object, selecting first point as here, and now selecting the second point. So now we have got the object like this. So this is one way of utilizing the break command to trim out the areas that is not required to us. So this break can also be used to split a single component into multiple without deleting anything. Assuming we want to convert this rectangle line, this unit as a single part and this as a second part, we can also do the same by using the break command, specifying this object, selecting the first part as here, and then instead of mentioning the second part, you can press in alpha and then click on enter. So now what's happening is, this has been split into two entities. So thereby you are splitting the object based on the point that you are specifying. So this is one way of using the break command to effectively split a component into two different parts and remove the second part that is not required. So next let's look into the mirror command. It's a very frequently used command that will help you in a lot of time saving activities, because most of the components are designed or almost symmetrical. So in symmetrical components you can recreate one object instance and then use that to replicate in other instances with respect to an imaginary mirroring surface. So let's see how we can replicate it. Let's assume this is whatever we have created earlier. This image and this image has to be replicated onto this surface. So let us use the mirror command. So type in mi, will prompt the mirror. So select which objects you want. So let us select this all and click on enter. So now it will ask for a mirror line. About which axis should it be mirrored? So suppose if we're drawing a line here over and above this line, so let's see, if we draw it here, about this line it is getting mirrored. Suppose if we draw in this way, it is mirrored vertically. So vertically and horizontally depends on which line you are using, and again which part, the angle. So suppose you want to always do it in the horizontal way, then type in F8 to trigger the orthogonal mode. So it will get automatically snapped out to this axis only, either the vertical or the horizontal axis. So this will help you to ensure that you are not missing out on the perfect horizontal or perfect vertical. Then once you click on the end line, it will prompt whether you want to erase the original or not. Because sometimes we want to erase the original object and retain the duplicated image only. Then you can do, but by default the no has been selected as the default, so you can click on. So this is the mirror command that you can use very effectively. In certain cases you need to use an array frequently. In certain cases you need to use a copy or move command, and in certain situations where mirroring will help you. So these are the frequently used editing tools that will help you in designing your drawings more effectively. Next is the offset command. So offset is used to create a new object at a specified distance from an already existing object or through a specific point. So this is very useful when creating or duplicating image and not worrying about the dimensions of the new object. For example, if you want to fence a given establishment, saying, so consider this as my plot area, and I want to ensure that I create a bank out of this area. So now we can make use of the offset command. You can click by O, offset, and specify the distance through which it has to be. It has to be a positive non-zero number. So assuming we have to offset through a distance of 5, and selecting the object to which it is getting offsetted. So and then based on moving your cursor inside or outside, you can position where it is an internal boundary or an external boundary. So this is the predominant use of the object offset command, because we need not now worry about the dimensions of the external object. Only the internal dimensions with which we know of, or the external dimensions with whichever data we have, we can create the other data only with the distance of separation between these two images. So this is the usage of an offset command through distance. So next we have the offset of through. So that is well replicated when we see some situations like this. Suppose we have a line here and we have a different line, say like this. Let us take away the ortho mode. Yeah. So now I have to offset this through this point. So this is where your offset command and through comes in. So we need to select this object and through this point. See, it basically it's a combination of a move command or a mirror command or so, but still you can get an offsetting of this through this point. So the commands that we have spoken about earlier, the move, copy, mirror, erase, it's all can be used in a combination within each other to suit our requirement. So based on the base point that you have, based on the distances already set, or based on the boundary condition, you can feel free to choose the best tool that is suited for that approach. So this sums up the offset image. In offset we have one more command called the multiple offsets. So in multiple offset, it's a extension of the through command. So you can see here by clicking on O and selecting through offset, selecting which object to do, and then when it is asking for the next point, you can see you also have an option to do the multiple offset by entering AM. So once you do that, it goes into the multiple entry points. So based on the first object, you can create multiple entries. Say the first is 5, next assuming it's an EQ space is 10, 15 and so on and so forth. So you could see all the objects are equally spaced between this. Suppose if you want to get back or undo one step, you can press on U to remove that alone. The difference between this undo and the overall undo is that, let us try the overall undo, that is the system based command. It will remove off all the offsetted images. So the undo command inside offset helps you to undo only one step inside this command. When you're doing it externally, it will remove all the commands. So this is the difference between the undo into offset and the system based undo. Now let's start a new drawing, and in this now let us look into the other drawing facilities, that is the polyline, rectangle and a polygon. So to start off with, let us look into the rectangle. So we can invoke rectangle by specifying REC. So once prompted, it will ask for the first corner point and the last corner point. So this is what we have been seeing. So let us dwell a little bit deeper into the rectangle. So as you could see here in this command, when you initiate rectangle, it will also ask for what are the different properties that needs to be included. So it gives in the chamfer, the elevation, fillet, thickness and width of it for the first point. So this secures the basis of the rectangle. So in the closing step, you can also specify, instead of specifying the corner point, you can specify the area or the dimensions and also specify the rotation. Let us look into one by one. So for the first point, when we are specifying, we can also have the option to define how the rectangle is going to be chamfered or filleted. Chamfer and fillet will look a little much deeper into the manufacturability section. Right now we can understand that you can use this command. If you type in chill, then it will ask for the first chamfer distance. So let us say it's 0.5. Let us assume it's a uniform chamfering of 0.5 mm, and the other chamfer distance also 0.5. So it will get updated in the memory. So similarly, we can specify the thickness or the width of the line. So let us just check what the chamfering has brought into. So as you could see, the borders are chamfered by 0.5 mm using this chamfer condition. So this gets stored in the memory. So each and every time you do it, it's get updated. So by default it's 0, but as you could see, when you prompt the rectangle again, it shows that the current rectangle modes is that chamfer has been updated as 0.5 and 0.5. So likewise, if you override chamfer and go for a fillet, so right now the fillet radius, let's say it's 0.5, and now draw the rectangle. You can see the corners are filleted by a radius of 0.5 mm. So this is the inbuilt chamfer and fillet feature in the rectangle option. So next is the elevation, thickness and width. So elevation and thickness is majorly used for a three-dimensional rectangle for an extrusion surface. So let us demonstrate it in a single go. So elevation, we'll see that the height of the rectangles, let it be say 5 mm, and let us specify the thickness of the rectangle be say 2 mm, and the width W, the width of the line be say 1.2 mm. And if we draw it out, you can see we are on the top view right now. So we have specified the thickness, the elevation and the width, line width of it. So this can be better viewed by changing this. Let us go to the front view. So you can see here, this is the rendering that it has been done. So let us orbit a little bit. So this is the rectangle that you have got. So this is the line width, and then we have the thickness and the width. So this is a 3D functionality. This is just for understanding, but as we are dealing with the 2D drawings, so this would be of less importance to us. So let us come out of it. But you have to remember that you have to undo the changes that you have done. As you can see, the inputs have been updated here. So you have to go and update the chamfer is updated to 0, fillet again updated to 0, elevation updated to 0, thickness to 0, and width as 1. So now you can go on, proceed, draw your so this is, we have to still make the width as 0. So let us do it, rectangle and width to be 0, resetted. So now you get back to the original shape. So this is the function of a rectangle. So now the first object what we have seen is rectangle using the first corner point. Now for the second point, we also have the option to choose the area of the rectangle or the dimensions of the rotation. Let us look into the area first. So let us say the area of the rectangle required is of 120 mm square. So this should be calculated based on what? The length or the width. So let us specify the length. By default it's in length, yes. So what is the length of the rectangle? Say it's of 52 mm. So based on the area that we have entered and the one of the dimension, that is the length, the other dimension is plotted and the rectangle is plotted. Let us just quickly have a look at this object, or rather let us invoke the quick properties menu and see about this. So you can see here the area is 120 and the length is 108. So this is based on the input. So the length, so this is the 1 minute. So we can do a quick measure and see the length is 52 mm that we have specified, and hence the width is 2.3. So this is the actual measure that we had entered it. Right. So this length is the circumferential length. So it's the peripheral length. So the sides are 52 mm and the width are 2 mm. So totally 108.6 is the total length that is showing in this quick properties. So this is one way of doing with respect to the area. Let us look into the other one, that is specifying with dimensions. So now we'll give the absolute dimensions. So the length will be 52 and the width will be say 5, and you'll get it based on the start point. Remember our start point was here. So based on the position we can interchange it. So now the third part is rotation of the rectangle. So we can specify which angle it should be. So rotating angle, let us say, is 45 degree. So once that angle is fixed, next we can proceed on to say what is the end point or the area or the dimension. So these are the different ways by which we can draw a rectangle. So next the part is the drawing of a polygon. So polygon can be invoked by the command POL. So the first prompt is the request for the number of sides of the polygon. So by default the number of sides is prompted as 4, and we can choose whatever we want. Suppose the polygon has a side of 8, and then specify the center of the polygon or edge of the polygon. We have two options. So going on with the default option of center, by picking the center of the polygon, then comes the two selection criteria, whether the polygon is inscribed inside a circle or circumscribed about the circle. So these two are imaginary circles about which the polygon is going to get constructed. So if we go in and go by the default of inscribed in circle, the radius of the circle is asked for. Let us assume the radius of the circle is 15. So now this polygon is inscribed within a circle of dimension 15. So this you can very well see by looking into the the height of the circle. So let us draw a circle to be sure. So let us control click and then find the geometric center. So now let us look into our inputs. So what we have specified is the radius of 15. There you go. So now this polygon has been inscribed within the circle of radius 15. So this helps us to eliminate this process of drawing a circle and then inscribing it within it. So this is the process of creation of a polygon within a circle, inscribing in a circle. So now we'll go and create the same polygon of 8 sides with specifying the center but circumscribed about the circle. So we'll specify the radius of circle 15 again, and now you can see that now the circle, let us also draw a circle to quantify it. Again, control and right click to select the geometric center of this, and then the radius of the circle is 15. As you could see, the polygon is drawn over and above the circle. So this is the circumscribe operation, and let us also show this inscribed circle to show you the difference between it. So the polygon is inscribed within the circle in this first command and outside the circle in the second command. So this is the way of constructing a polygon. The next way is again the polygon command but with the edge. So supposing let us have a surface, say with this orientation. Remember we had given the direction as 45, so it remembers the same orientation. So now let's say the polygon edge is aligned with this line, so we can make use of the command of edge to specify the edge point of it. So assuming it is figured out in this edge, so you can select the edge point, thereby you can control the dimension of the polygon. So these are the different ways of executing a polygon. So next one is the polyline command. So why we have kept it at the last? Because one thing you can observe here is whenever you click on the rectangle or the polygon, always it shows as a polyline because internally it gets constructed through a polyline methodology only. So now let's look into the polyline method. So polyline is that you can draw a line as well as extend it to a polygonal arc or an ellipse based on the requirement. So it combines a line, a circle, arc together. So in order to simulate this, you can type in p line for polyline. So it will start off as a line. The initial command is the same as a line, but once you have specified the point, before the next point you can also have the option called as arc, half width, length, undo width. So let us see one by one. So let me keep on drawing the line. So this is same as in line command. The command gets continued unless you are terminating externally. Next you can extend it through the arc command. So once you click on arc, your arc modules get included here. So whatever the first point that you have given will be the start point. Next it expects a second end point, whereas you can also specify the angle or modify from the end point to the center point, and then based on that selection you can go for example, if you go for the center point, then you get the other options what you had seen earlier in the arc. That is, you can either specify the end point directly or specify the angle or the chord length and so on and so forth. So remember, until you stop it, it will keep on executing. And suppose I'm specifying with the radius of the arc as say 33, and with this dimension I'm using control key to vary the dimension. And okay, 55. So with this, now I intend to close the circle. So with this, what we can do is type in CL, and the AutoCAD does the closing operation by itself by connecting back to the original one. So this is a faster way of doing a drawing. Suppose if you are very clear about the nodal points and the dimensions, then you can keep building on it and then quickly figure it out instead of going by separate commands for line, circle, arc, merging and all these things. So this is a powerful command that once you get mastered, then you won't be going to other commands, individual commands, but rather work on this itself. So this is to sum up all the drawing commands that we have seen. So let's try and replicate this drawing that we have seen in the screen. So this is a spacer element, an assembly element, which also have hexagonal nuts bolted onto it. So here what we can see is the spacer element is of a major dia of 150 mm and the through-hole dia is 90 mm. So these bolts are M8 bolts with a pitch of 1.25 and there are 8 bolts equi-spaced on a pitch circle diameter of 120 mm. So let's try and draw this onto this AutoCAD environment. So to start off with AutoCAD, let us specify the limits and the units. So first let us enable the limits, turning it on and specifying the lower corner as 0 and 0, and let's specify the upper corner, say for an A2 size paper where we typically draw the engineering layouts, and so it has a height of 594 and a width of 420. So we'll keep the same dimensions, 594 and 420. So now we have set the limits of this model space based on a A4 mm dia, and next let's invoke the units, and so we are operating on millimeters, and let's keep a precision of 2 units and in degrees only. So we have updated the system command units to millimeter. So always ensure that you have specified the limits of your model space and limits as a best practice so that you don't miss out during the layout publications and so. So now let's see how we can draw it. The drawing has been hosted in this bottom right corner so that you can have a quick reckoner when you're following this video. So first off, let us start and draw the spacer. So the spacer outer dia is of 150 mm. So let's start with the center point of here and then stating the diameter as 150 mm. Let us zoom a little bit to accommodate it, and now draw the inner circle. So we need to snap to the same point and then choose the diameter again and specify as 90. So that's it, we are done with the spacer element. Now let us draw the hexagonal nut. So to start off with the nut, the dimension required is M8 bolt with 1.25 pitch. So this M8 is a metric measurement of nut. So nominal dia of this nut will be 8 mm, and so the across flat. So let us quickly show you how it's going to be. So the hexagonal bolt will be of size 6, and let's say this is the center of the polygon. Okay, so let's give within the limits here, and so the bolt typically will be inscribed in the circle. So let us quickly draw one hexagonal bolt like this and look into the terminologies. So typically this face and this face is called across flats, wherein you put in your wrench to tighten the nuts, whereas these edges from this to this is called across corners. So these are the two terminologies that you can describe the hexagonal bolt or nut. So here then you have the through hole that is going to come into it. So let us go to the geometric center, and also let us draw one more circle to show that. So this is an inscribed circle because basically you're chamfering out the edges of the nut. So this is the representation of your hexagonal nut. And you have to also showcase the nut specification, the inner dia and outer dia by virtue of the screw element. So the nominal dia of the nut will typically be hidden because it's the bigger one, whereas the smaller edge is what is being visible. So the typical nomenclature is that for an M8 bolt, the outside dia, that is across corners, would be typically 15 mm of dia. So when you are drawing a polygon, so you have to make sure that you are inscribing it. So typically what means is this across the corners, so this circle should be of dia 15 mm. So that will quantify this M8 bolt. And then we have drawn the nominal radius, but we'll draw the minimum radius. So typically the minimum radius is 0.85 times of the nominal dia. So to quickly open up the calculator, let's see here, 0.85 times of 8 mm of nominal dia will be 6.8. So the inner circle would be typically of dia 6.8. Okay, so let us draw this onto our model. So the requirement is a polygon and it has to locate here. So the number of sides is 6, and so we have to position it from here. So the requirement is it should be located on a pitch circle diameter of 120 mm, so that its radius is 60. So you need not draw a circle and then inscribe onto here. What you can do is again control and right click and give in the distance from. So select this point and then use your coordinate system referencing to say that at the rate of 60 units at an angle of 90, so that will get pushed in there, and as we had seen earlier, it's going to get inscribed within a circle of across the corner dimension of 15 dia. So the diameter of the circle, so as the radius, so it is 7.5 mm. So this is your bolt, and now let us draw the nominal dia, and we'll pick up the geometric center, control right click on the geometric center of this, and then specify the radius or the dia as 8 mm. And now also let us draw a circle that is inscribed within this to specify the, let us zoom a little bit to do, okay, let us specify the midpoint here to draw the chamfered edges. So now this would be hidden bolt, and now let us draw the minor dia, 0.8 times of 8, 6.8 dia, and now as a representation we have to trim out the other quadrant. So to do that, let us use the break command, and selecting this object, specify the first point as an extension to here and the second point as to here. So that's it, we have got the bolt, hexagonal bolt. So now let us use the array command, the polar array command, to replicate it. So we give the array polar, and the objects are these. So the center point of the array will be the circle, and the number of instances will be 8. So that's it. So with this we have drawn the flange plate, the spacer element with the bolted hexagonal nuts. So now we'll have a recap of the session that we had today, the lay of the land. So what we had looked at is different drafting settings, the object snap commands and polar tracking. Those commands have also been replicated in the last exercise that we had. So this will help us a lot in accelerating our drafting process. And next also we looked into the dynamic inputs that are available to us, and how we can circumstate from the absolute to relative polar and henceforth. So by using comma, at the rate of, angular and pound symbol. So by this also we can get a floating tooltip of what is expected next out of that command. So those comes in the dynamic inputs. Then we looked into setting of limits and setting of units of the entire model space, and next we had a look at the options that can be designed to suit our needs, customized based on our needs. So after this we also had a look at undo and redo commands. Next we looked into different editing fundamentals: move command, the copy command, array command, the rectangular array and the polar array, and then the break command, mirroring and offsetting. So then we also had a hands-on exercise of a spacer element bolted with 8 hexagonal nuts. So with this we conclude week 2 of the session. So next, have a look into the assignments and have a good practice on it. Thank you. Welcome to week 3, start camera action. So the past week what we had seen was for the which way lay of the land. So we had seen different drafting settings, object snap, dynamic input settings, units, limit specification, and various editing fundamentals such as move, copy, array, break, mirror, offsetting. So with this, you also had a hands-on experiment on assignment 2 that would have given you a great clarity on the various editing fundamentals, and hope by now you would have got the grasp of AutoCAD, the basics of working around with AutoCAD. So the past week, whatever we have covered will be your most fundamental repetitive usage of AutoCAD tools. So this week, we'll look into different navigation techniques and selection techniques. So in navigation techniques, what we'll see is zoom, pan, steering wheel. So this is why we have named our session as start camera action, because we'll be using these tools to navigate around our drawing to make effective deletions and so on. Next, we have the different selection techniques. So once we have navigated to a specific portion of an object, so how to select the different instances that are interested to us. So we have the box command, fence, W polygon, C polygon, and additionally select commands using add or remove objects. And next also we look into some more drafting, 2D drafting fundamentals for solid and donuts. So these are again 2D objects but filled images. So we'll look into this section in detail, and also look into a hands-on practice of drawing with whatever learnings we had in week 3, 2 and 1. So now let's start off with zoom functionality. So this zoom functionality is very useful for working with large drawings where you have to specify each and every dimension specifically and work on it and then move on to the next character. So towards that, AutoCAD presents the functionality called as zoom, so that you can invoke by the command C. So this is the zoom function, and so when you invoke the zoom function, you can see what are the parameters that AutoCAD allows us to perform. So first you have a dynamic zoom, wherein you can specify the corners of the window to zoom into the levels that you want, or a scale factor. And also we have additional commands, that is zoom to all, or zoom based on a center, or have a dynamic zoom, zoom to the extents of the drawing, roll back to previous zooms, scaling the zoom, or zoom to the entire window, or zoom to a particular object. So let us see each and every functionality in detail. So towards that, let us construct a drawing first. So let us come out of the zoom command. So let us just construct a simple rectangular plate of dimensions 200 cross 300, okay, with 4 M8 holes drilled across the corners, and this rectangular block is going to have 5 mm fillet on the edges. So this is the component that we need to draw currently. So before starting off, always do remember, you specify your units of operation as well as the limits of the operational page. So for specifying the limits of the paper, just let's quickly review what are the different paper sizes that are available for us to use. So you might have heard about the A4 paper size that we'll be typically using in the printing areas and for our regular use. So using that, we'll build on the other paper sizes. We have A3, A2 that are being predominantly used in the industries, and also we have A1, A0 sizes for specific requirements. So let us quickly look into how it is construed based on unfolding the A4 paper. Okay, so towards that, let us quickly draw a rectangle to drive that point. So let me just quickly go through the dimensions initially and then later come back again this showing what are the individual dimensions so that you can make a note on. So first let us draw an A4 size. So we'll use the rectangle command to randomly specify a point. So as you could see now, I've taken away the command prompt for faster access. You can enable it on or off by using the hotkey Control+9. Okay, so using this because sometimes it might delay the processing of your the graphical cursor movement. So towards that, you can turn it off by using Control+9. Okay, so now let us quickly draw a rectangle and specify a random point here, and the other point, let us use the rectangular coordinate system, relative coordinate systems at the rate of 297 as the width and 210 as the height. Okay, so this is construed as your typical A4 paper. So now it is in the landscape view. So let us construct the A3 paper. That is, imagine that you are unfolding the paper on the breadth side. So as you can see, this is your breadth, right? So 297 mm is the width of it. So we are unfolding it in that dimension. So we'll pick up the rectangle command again with the same starting point as here, and here now we are unfolding on the width side. So let us specify the same 297 as the width and then put on comma. And so typically you are unfolding on the height of it, so you, that is, this will get multiplied twice, right? So your 210 mm of your A4 width will get multiplied twice, so you'll be getting a 420 mm. This is where we'll be using a zoom functionality. So let us quickly use the command zoom all functionality. So I'm invoking the zoom command by Z, and then now I'm using A to specify all. Okay, sir. Now the screen window has been resized to make visible the entire object in place. So now this is the A3 paper that you can see here by unfolding a A4. So typically it means that placing two A4 sheets side by side along its breadth will give you an A3 paper. So now let's repeat the same step for an A2 size. So in A2 what you do is you unfold it in this manner, right? So you just keep on unfolding. So you are unfolding like this onto the breadth, and again you unfold along the breadth. So always you unfold along the breadth of the paper. So now let us specify one more rectangle with the same starting point as here. And now if you could recollect, the width of the A3 paper was 420 mm. So we'll specify the width, but remember now we are unfolding on the breadth side. So the breadth is 297 mm. So what we have specified here. So as we are multiplying on that, see, you are multiplying on the width of it. So 297 cross 2 is your height. So and then retaining the same breadth. So see, we are retaining the breadth of this paper as 420, whereas we are unfolding based on this length. So this length was 297 mm for us. So now what we have got is, we have got the A2 paper by unfolding an A3, and before that we got an A4. So now let us proceed to get an A1 by unfolding the A2 along its breadth here. So let us repeat the command of rectangle and with the same starting point. As you could recollect, we are unfolding the A2 paper along its breadth, so that breadth is going to be 594 mm. So at the rate of 594 cross, and we are multiplying the width of it. So what we have got was earlier 420 mm of A2, so that would be 840 mm, and here typically you have got the unfolding here, you have got the A1 size. So I have now used the scroll up and scroll down of the mouse to demonstrate the application here. And now let us unfold this A1 along with the width here to get the A0 size. So starting from this point, okay, and the next is multiplying 594 the width by twice, so we'll be getting 1188, and the width to be 840, the same as the AHN. So this is how you have got the overall object. So now we can see typical bits of it. So this the extended area of this page is your A0 size. So typically if you're drawing a component based, suppose let us draw a rectangle here to just to get the perspective. So what we have spoken about earlier was the rectangle of 200 mm and 300 mm. Okay, let us keep it as 200 mm and 300 mm rectangular plate. Okay, so with this is your, so typically if you are going to draw this, so you can't position this object into your A4 size. So at max you can maybe try and squeeze it to your A3, but remember you have to place your annotations, the dimensions, the title sections and all those informations into your page. So based on your paper size is where you have to determine what the drawing that you are using. Suppose if you want to position this object into your A4 size itself, it's within those limits, then you have to apply your scale command that we'll be looking into later. So this is the importance of specifying the dimensions of the workspace that you're going to work around, so that later when you take a printout message or something, then it will be easier for you to position it and then take it in the correct zoom option. So this is why we keep on emphasizing and saying that you always need to specify the limits of the working space that you are working on. Okay, so this is a brief on utilizing the limits. So let us quickly delete them all. Okay, and let us get back to the task in hand to specify the limits. Exactly, yeah. So we have to specify the limits of the pages. So let us start with 0 and 0, and typically most of the drawings will be of the A2 size, so those will be 594 cross 420 mm in dimensions. Okay, so now the limits have been set, and to also to confirm the units that they are in millimeter, yes, they are in millimeters, right? So after ensuring your limits and the units, let us start with the task. So let us draw a rectangle and specifying the point as in here. So let us say, let us start with here, some random point. So the width is going to be 400 mm and the height is going to be 200 mm. So with this rectangle plate, now we have construed the rectangle, and next task is to fillet these rectangles around. Okay, so one way of doing is using the fillet command inside the rectangle that we have seen earlier. So we have to do that, but before that let us try and draw the M8 holes that we intend to position it. So towards that we understand that we have to zoom into this page. So let us now look into the various zoom options. So let me invoke the command prompt here to have an idea like what are the different zoom options that are available to us. So clicking on Z to invoke zoom. Yes. So right now we have different options such as all, center, dynamic extents, and let's look at one on one. So this all extents will zoom to the entire drawing in the current view. So let us select A command to see how zoom all invokes in the current view. So you could see all zooms to the grid limits or the current extents. It zooms to the entire extent. So typically it means that the extent that we have specified is of the A2 size, that of 594 and 420 mm. So typically in that manner, this is the A2 size that is available for us with a length of 594 mm and 420, and of that our drawing has been placed in this position. So this is how the zoom all can give a bird's eye perspective of where your drawing is, and it also shows whether if the object is outside the grid limit also, then it can show and extend like where our object is positioned. So this is one quick way to zoom out and view the drawing as in a whole, this all command. So now the next zoom command is the center option. So right now what we are speaking about is we have to draw Emend holes into the plate. So the object in hand is the rectangle. So we'll use the C command to invoke the center, and it will ask for the center point of this. So let me quickly disable this command prompt to zoom and specifying the center, and center we have to zoom in this way. So I'm clicking the dynamically selecting the center point. Once I've clicked in the center point, the next requirement is to specify the magnification rate. So typically the height that we are going to do demonstrates the limit of magnification. If we specify a small value of height, the magnification will be very high because the area of the window is going to be very small. Whereas if we give a bigger dimension, the area is going to be larger, and hence the magnification is going to be small. Let us look into closely each and one. So let us say specify a magnification of size 5. So imagine you're zooming onto a 5 mm or 5 unit width of the screen. So you're zooming into the object of height 5. So as you can see, it has gone inside the object now. Maybe so that's why you have to select your magnification height as required. So we roll back using the Ctrl Z option for the undo. So now let us repeat the same zoom command with center option with a larger magnification height. So let us give the height as 500. So that means 500 mm is going to be the width. If you remember, the width of the page that we are currently having is 594 mm, the limits. So if I click on the 500 mm, say the height or the width of the window is being specified as 500 and the zoom is done accordingly. So based on the requirement, you can specify to the object in hand, and with the height of zoom you can zoom in or zoom out based on the application. So this is the zoom to center option. So next we have the dynamic zoom option. You can see it here. So now what this dynamic does is it allows us to specify the zoom window using a rectangular view box. When we move around the cursor, you can see the view box moves around and allows us to select which is the view that we are required to see. And we can also, extend or zoom in or zoom out of the requirement window. So the rendering is slow, so I'm turning it off in the command prompt. Yeah, so specifying zoom and specifying the dynamic control. So what we can do is, in order to change the size of the view box, we can click on the screen to modify the length of it. So once we have frozen what is the view requirement, then we can click back on the screen to allow the pan of the window. So suppose if we want to have a zoom window of small size and looking particularly only on this corner study, then we can position it here and then click on enter to zoom onto that scope. So this is the facility of dynamic zoom, where we need not specify the exact dimensions of zoom window that we require to do. So this is the option of a dynamic window. So next, the command is the zoom to extends. So we'll try it out directly within here. So it means that it will zoom to the largest possible extent that is available with the objects. So now as you can see, we have zoomed to one of the corner of the object. So So now let us invoke the zoom to extent. So it is invoked by starting by typing the letter E as the first one. So once you click on E, so now the zoom has been affected to the extent of this current object that we have in hand. Suppose if our drawing is really small within the existing limit of the paper, then we have an enlarging effect, that is the object fills the screen. Suppose if the object itself is of a bigger size and that it occupies the limits of the page, then maybe it doesn't have the intended zoom that we look into. So then maybe we have to go into other options. So let me repeat. This zoom to extent typically zooms to the outermost portion of the drawing. So as recalling, the limits of the paper is the limit of your extension that is possible. If the object is small, then you will be getting a zoom to the object. Suppose if the object itself is filling to the screen, maybe you won't get the intended zoom that you require. Then you have to move out to other zoom commands. Earlier what we have seen as a dynamic zoom to a specific subsection of the object or other commands. So this is the zoom to the extents command. So next we have the zoom to the previous view options. So we can roll back to 10 different zoom options that we have invoked earlier. So this is different from an undo command. Undo typically rolls back the action that you have done. So it might be say a drawing action or a deleting action also, but this zoom to the previous restore only the zooming actions or viewing actions. So that is invoked again by selecting Z and invoking the P command for previous. So when we first click on that, it will go to the previous zoom that we have invoked. That is what's the zoom to the extents. So likewise you can repeat this to the latest zooms that we have invoked. So this is about the zoom using the previous commands. So next what we have is the scale command, that is zoom to the object based on the scale that is required. Let me hide that. Okay, so now zoom and specifying the scale command using S, and so it asks for the scale factor. As you can see, the scale is mentioned by the alphabet N followed by an X or an XP. So X means the number of times the scale has to be invoked. Suppose if you are giving a factor of say 2x, then the zoom is invoked 2 times for the object on the current position. For example, let us see if we given 2x for the given object and given previous view, it zooms twice into the screen for the object to locate. So let us go back to the previous zoom by invoking P command, and now let us repeat it with the scale command, yes command again, and now let us see what NXP does. NXP is that scaling times to the paper space units. So let us repeat the same command to have a view of it to XP. So based on the paper space that is available, it is doing so. Typically, maybe now we may not be able to see the difference, but which different layouts that we are using and different for each paper space by defining the different dimensions, then we can specify the option of the scale relative to the grid of that paper space. So typically we might not be using this. Our normal scale command itself can be taken, but if there are specific requirements for different paper spaces, then you can use this scale to paper option. So next zoom command what we have is, so zoom to window specifies against a rectangular corner wherein we can specify the room. So it's typical to the dynamic zoom, except here instead of a prefix zoom window and the dimensions, you directly specify the zoom area by specifying the limits of the screen. So this is zoom to window option. Next what we have is the zoom to the object command. So now we can zoom to a separate object that we have. For example, okay, so towards this, let us zoom back to the extents. Okay, so now let us construct a circle, that is the Emend hole. This point, the x-axis is going to be 50 times, but y it's going to be at minus 50, and the diameter, let us specify the diameter and at 8. So we have the Emend hole here, right? So okay, now I had used the scroll option of the mouse, but let us say that we want to zoom to the specific object of this hole, then we can use the zoom to object command O. So now it asks for the what are the objects that are being selected to look into the maximum zoom that is available. So let us click on this object, and to complete the command let us click on enter. Zoom object. So now the object has been selected, the Emend hole, and now when clicked on enter, the zoom is gone to the maximum most possible zoom that is possible with that object in the extent available. So this is the zoom object command. So now let us roll back to the overall extents of this object, zoom extent. Now let us finally look into one more zoom command called as the real-time zoom. So that typically saves as the default option that is available, as you can see highlighted here as real-time. So typically what it does is you can invoke it by pressing the enter command. So once it's done, you can see the cursor has changed to a lens view. So by left clicking the mouse and moving vertically up, you can see it zooms into the drawing, whereas you move vertically down, then it goes to the outwards zoom out direction. So based on that, you can zoom to the object in hand, right? So, and in order to come out of the command, then you can click on the escape option. So one more point is that, as you can see, when we are zooming using the real-time zoom, we can see that we have come out of the object that was available. So in order to quickly roll back to the required space, what we can do is you can click on again zoom and then click on extend to go to the object in hand. So this is what the full application of the zoom command is used to quickly move around the workspace as well as move around the objects in hand to have a quick and fast editing. So this is about the zoom command. So now we have seen what are the different zoom commands and how it can help us through the command prompt. So now let us see like how we can invoke using the other different commands that are available to us. So first is you can invoke through the regular view. So you can click on the zoom command here in the regular menu bar in view, and then you can select the zoom as real time, previous window and all other options. So but in the ribbon view, so this is of different requirements, that is to select what are the view menus that are required. So this is not in the ribbon but in the menu bar, view menu. So this is one way of invoking view and zoom command, and typically you also have the navigation bar that is available here. So there again you can see the typical used command of zoom is either the extent or which is required to you frequently, then you can select it. For example, if you want to always zoom to a specific object, that you can click on this so that it will be always available upfront for you to select it. So likewise, whichever is required, you can select it and that becomes as a regular command here. So this is the zoom option from the GUI navigation bar that is available here. So until now we have seen what are the different uses of the zoom command. So now let us look into the other command, that is panning. Panning means that moving around the workspace with the same zoom limits but to a different object in focus. So to invoke that, let us take a different zoom as a real-time zoom. Okay, so let us say we are here. Now we have to maintain the same zoom but pan out to a different location. So the command is P for pan. So once you click on that, you'll get a hand icon. So when you click on the left button, so you can see the page has been held, and now you can move it across to go to the view that you are interested in to work on. So this is the pan option. So pan again can be accessed through the navigation bar here, the pan here, or alternatively in the view bar you can select pan from this object. So one more thing of doing is normally you can also invoke the requirement by clicking on right click, where you can see pan and zoom is also typically listed out in the normal action menus. So these are the different ways of invoking zoom and pan command. So typically why we are using these commands is to ensure that the viewing space focuses on the current object of working. So what earlier we have seen is we can also do away with this command line using Control plus 9 menu, so that we can still have that view area in scope. So likewise, we can also enlarge the graphical area. So typically this is our graphical area that we are working on. We can enlarge it by using an option called as a clean screen. So that will remove the other object, that is the toolbars, taskbar, so that you can have more operating space. This is one tip that you can use to work on, because once you are familiar with the AutoCAD menus, then the prime mode of operation will be through command lines only. So as you are very familiar with the shortcut keys and the invoking commands, you won't be requiring the command prompt because you already have the dynamic input option enabled. So that will help you to work in the graphical screen itself. So likewise, you can take away the toolbars also by using the clean screen command, that is Control plus 0. So Control plus 9 works on the command line. So Control plus 0 removes of the toolbars and the taskbar option to provide more space. So this will be helpful in the later stages of your operation, where you work with only what is absolutely essential, because by also eliminating these, your computation speed, that is your rendering speed, will also get drastically improved. So suppose you are working on a low-end PC wherein you are limited by the RAM capacity and you have to render a large object, then you can do away with certain screen occupying parameters like what we have seen to fasten the reaction time. So this is one tip that you can look into. So now let us bring back to screen. So by pressing on Control 0 again. Okay. Yeah. So now, so let us look into the next command, popular command is the steering wheels. So steering wheels is something is very unique to AutoCAD. So that is highly useful when we are operating with complex models and we have to go around the model frequently. Okay, so now when we invoke the steering wheel command from the view menu, view a steering wheel, so now we can see something that is floating around here. Okay, so based on the mouse screen, it can be positioned. So now it means that when we have invoked this command, the mouse cursor is limited to these functionalities. So we can use this to quickly opt to a viewing option that we require. Suppose if we want to invoke the zoom command that we have seen earlier, using the steering wheel, we can take away which is required. So you can see we also have got different options that are listed. So let us look into the steering wheel command in detail now. So now let's continue to look into these different aspects of the steering wheel. So let's invoke the steering wheel command again here. But now let us also look into what are the different options that the steering wheel can give us. So typically in this drop down menu, you can see there are different types of variants of the steering wheel available. So what we have here is the full navigation wheel, full steering wheel. So this is what we were seeing earlier. So typically we can break the entire steering wheel component or the wedges into two types. The outer one, where you have the zoom, pan, orbit, rewind commands, has the view object wheel. That is, these commands are used to navigate the given objects. Whereas the inner segment, where you have the look, walk, up and down, center commands, they also call that the tour building wheel. So it means that for a 3D elevation plan or in a civil engineering drawings or even in our 3D objects, so we can use this to create a moving camera kind of view. So consider that you have a drone in hand and you want to go through the drawing, or take a different shot, as in have a different view when in a orthogonal view. So these are the different commands that will help us to navigate a different object or a 3D drawing. So to simplify the options that we have, you can also right click on it to select which is required for you currently. Suppose if you are working only on the object commands, that is only on 2D, then we can give only view object. So if you can see, it has broken down into this fourth segment where you have the center command, zoom command, rewind command, orbit command, and right clicking again, and in basic wheels you can alternatively select the tour building wheel. So in that case what you have is the forward command, up and down command, look command, and additionally the rewind command. So let us go back to the full navigation wheel. What we have seen here is the zoom command, the rewind command, center command, and orbit command comes in your object wheel, whereas the forward command, the up and down command, rewind, look, and forward comes in your tour building. So forward is typically similar to your walk command. So alternatively, if this steering wheel is going to occupy the full screen, then you can select a mini wheel. So this is your full navigation, whereas if you click on the mini, suppose a mini object wheel, so what you have got here is the mini version of the wheel with only the 4 commands, and you can select which is what, and you get a name tip that is highlighting outside. And if you hover it on it for a longer time, you will get the tool tip, a description on it. So in this pan, if you hold it in, it will show like what is the purpose of this tool. So it used to move the view. So suppose if you click on that, the thing is you have to hold down your left mouse button to stay on the current command. For example, if we want to zoom it, I have to click on it and then move my mouse arrow up and down. And if we want to rewind the steps through the different movement options, then we have to click on this command, rewind. So by clicking on the left command, left button still longer, I can scroll to whichever view I want to. So earlier we were using the pan command and rewind command, all the same. So let us rewind back to this. So these are the different applications of your mini object command. So likewise, we can also get in the mini tour building command, where we have the same 4 commands described only as a mini wheel. So this is typically very well used if you want to navigate around your drawing, and also in lot of presentations where if you want to detail a specific section and then go back to the original drawing, then you can use these commands to full use. This is a 3D representation of selecting different commands instead of your command prompt. But again, if you are very familiar with your shortcuts, and then you can very well go with it. So this is one another option that AutoCAD offers you to have control over the navigation tools. So next, what you have here again is the mini full navigation wheel. So here, instead of 4 quadrants, you have 8 quadrants or 8 wedges. So on these wedges, you have all the commands listed. So let us go back to the full navigation wheel, and let's look into every command one by one. So first let us focus on the objects command. So currently the object focus here is the rectangular plate with a single M8 hole. So if we long press the zoom command, and as you could see, the pivot point is set in where we have placed our navigation wheel. Suppose if we move the object here, then the pivot point is held here. So the zoom is affected with that pivot in place. And whereas with the pan command, with that grid as the center point, you can pan around. And rewind command we have already seen in. So these are the various last navigation options that we have used. The next also we have the orbit command. So typically orbit very much predominantly used in the 3D model. So let us quickly have a view of it. We click on the orbit and you can see again a pivot point has been set, and when you move the mouse arrow up, down or left, right about the pivot, you vary the axis. You can also see what is the orientation. See, suppose right now it is in the front layout. Typically we were operating in the top layout, and so when you are operating with 2D drawings, this orbit tool will not be of much use to you. But if you are extensively working on a 3D model or in architectural drawings where you have to operate on different elevations, then this orbit command will be of heavy use to you. Also, in a normal 3D drawing that we typically use, suppose if you want to quickly change the view, instead of selecting the views here, you can use the orbit command to select the view of interest to you. So you can take the isometric view or whatever. So this is a dynamic and axis selection option. Okay, so you can change the view accordingly. Okay, so let us rewind back. Right, so these are the typical the object views, and in object we have one more command as the center. So when you click on the center and you hold it longer with the mouse button, the next expectation is that you have to click or drag on the model to set a pivot point, because right now you can see there is no pivot point that has been established. Alternatively, if we move over to the object, you can see the pivot point being setting upon. So suppose if you want to center upon this pivot, then holding on it and then click on the center and then position the pivot and leave out your mouse button. So now the view is centered upon that pivot point. So this is your center command. And next is the alternate tour building. So let us go into this basic wheels to have a better view. So yeah, so here with the up and down command, clicking on it, you can move up or down. So now this up or down is being operated upon the layer XY. Whereas in the look option, you have a free look option. So it's kind of an orbit, but the thing is, it facilitates the 3D structural view of the component with your current position. Forward command is again similar to your center command, but this adjusts to the 3D object that you have. So when you click on the forward and click on the object of desire, then you can set the pivot point to set the distance from which the model has to move forward. So currently our object does not support that, because this is rather a 3D building kind of view, so I'm not dwelling much into it. So next, let's go back to the previous step. So these were the tour building wheel, and earlier we were seeing the object building wheel. So this summarizes the typical usage of your steering wheel. Alternatively, if you want to invoke this command instead of your view steering wheels, this is one way of invoking. And in order to select which are the different options, then you can use this port to select which are the different wheels you want. And alternatively, you also have a command for only 2D wheel. So as you can see, only pan, zoom are available here, because these are the typical 2D commands that you use in So you can set in this as your default view. So alternatively, you can also invoke the view command by typing in navigational steering wheel, nav yes wheel. So by clicking on it, it will again invoke the latest selection that you have invoked, because earlier we were selecting the 2D wheel, so you have got the 2D option. So now let us again invoke nav yes. Additionally, what you have is the wheels mode and the wheel display. So in wheels mode, so you can select the different views that are option. Let us look into one by one. The maximum number that it can take is 3 and it starts from 0. So once you have clicked in, so see, this is the 0th mode, wherein you have the view object wheel, wherein you have orbit, rewind, zoom and center. So let us again select the different, so let us click on escape, select the other mode. Now it's wheels mode. Let us select 1. Now let us again involve nav says wheel. See, for the command 1, what you have got is the tour building wheel. And one more tip is that if you are repeating a command over and over again, then alternatively you can click on the up arrow button to select what are the earlier commands that were invoked in the command line. See, as you can see, currently we were invoking only these two commands in the command mode. So only these two are listed in the circular options that is available. That is the list of commands that is available in your command prompt. It has been listed. So now click on nav wheel mode. So let us select on 2 and again click on up arrow to select navigation wheel. So with this you get the full navigation wheel. And finally, with the mode 3, what you have got is the 2D. So typically you have 4 modes. So first, for mode 0, it is your view object wheel. For mode 1, it is tour building wheel, and mode 2, it is full navigation wheel, and mode 3, it is 2D navigation wheel. So these are the different navigation steering wheel modes that you can select from. And next is to view the different properties of the steering wheel. So let us invoke this command, steering wheel command, and then click on right button to select what is the other steering wheel settings that we can invoke. So typically in this you can see steering wheel settings. So onto this screen you can combine the settings that you want to view for both the big wheels as well as the mini wheels. So first command is the display of the wheels here. So with this you can control what is the size that you want to have the big wheels. Whether it should be extraordinarily large or small, or based on your convenience you can set it. The default conditions are the wheel size or medium for both the settings for big and mini wheels, and for wheel opacity you have 50%. Opacity means that the transparency of your wheels. Suppose if you are working on a drawing that includes the dimensions that are laying behind and your wheels are obstructing the view, then you can control your opacity. For example, let us keep the opacity minimum most as 25 and click on OK. Now we can see the opacity has become 25 and we can still view the object in behind. Whereas if our opacity is maximum at 90%, then you can still able to see the wheel, but it is superseded by your the commands in the wheel. The drawing is still visible. So based on your comfortness, you can select whatever opacity is, but we can retain currently with the same settings as prescribed, 50%. So next is your option to select the display, whether the tool messages or the tool tips to be displayed or not. So by default it's on. And next is the zoom tool. That is, when we click on the zoom, if you remember, we have to long press the left mouse button and then move it up or down to enable zoom in or zoom out. If you select this tool, this button, enable single click incremental zoom. So for each and every click on the zoom command, it will increase the zoom by 25%. So it means that you need not move your mouse button up or down. So let us quickly view into this. So we are selecting this zoom tool and click on OK. So now I'm just clicking once on the zoom tool and the command zooms by 25%. So this is the utilization of zoom, enable single click incremental zoom. So next is again based on the walk command. For that, whether the movement should be constrained to the current view plane. So this is the command for that. Next is the for the look tool, whether to invert the vertical axis. So inverting vertical axis means if we select on this, moving the mouse button up, move the drawing downwards. That is, it will invert the motion. So let us check this also, and let us select the tour building view. See, in the look view, so I am moving my mouse down, but as you can see, the drawing goes up. So likewise, so we can select the invert vertical axis for look tool. So now the views has been inverted. I'm doing it again, moving thing up and down. So you can verify this motion, because as you are not able to see the mouse now, maybe it will be difficult to visualize how it is happening, but you can use this. So basically, if certain people are comfortable with the inverted axis, then they can take it using this command. So next again we have the upright command. So that is viewed for the tour building view. So that will help you to maintain the up direction whenever you are using the orbit tool. Okay, so for 2D drawings, as per my view, this is not required. So we can still make use of the zoom commands. And next is the rewind thumbnail. So what should be the number of previews that are generated, and also invokes how it is displayed in the steering wheel. So the default option is on demand. So it means that the thumbnails are generated on demand for the rewind tool when the selected bracket is positioned to whatever frame is required. Whereas the never command means that there are no preview thumbnails that are generated when a different view changes. This review thumbnail is pertaining only or external to steering wheel. So that is what is getting occupied here. So it means that suppose if you are selecting the automatically option, so it means thumbnails are generated after every view change, even outside the steering wheel. So whereas if we specify never, then it means that if you're not using steering wheel to generate a different view, then those are not stored in this thumbnail. So by this you can control which previews needed to be held in your rewind option. So this is the difference between your undo command and rewind. So rewind is predominantly specifying only the views that have been generated, whereas undo also does for commands. So here commands are not taken into, only the views have been rewinded. So next you also have the walk tool. So when you are using the walk command, and that means you are walking through a layout, so consider a drone that is going into, so you can control the default speed. So currently it is 1 unit. So typically see the motion is typically 1, whereas if we use the plus button, the speed has been incremented. So alternatively you can check here. If you want to preset the normal walk speed, then you can click in here. So the normal walk speed is there. Okay, so this concludes the steering wheel settings. The other disadvantage, or rather a workaround, is that every time you go about this using the steering wheels, there is a high possibility that you go outside the operational limits. So to come back, you can go into the zoom to extents option to make sure you come back to your original view of the drawing, and again to reorient your layout, you can select on the current view plane that you are using. So this reorients our drawing. And so this concludes our steering wheel option. So as you can see, steering wheel is typically very much used when you have a very large drawing and to have perform different navigational techniques in tandem with each other in sequence So instead of relying on commands, you can quickly ensure the navigation commands are taking place using your steering wheel. So based upon your practice and your utilization, you can make navigation tool to work patently for you. So that concludes the steering wheel topic. So next, let's quickly look into the additional drafting techniques such as donut and solid option. So typically solid and donut are used to fill a 2D object. So those are again 2D commands, but the inside sections are filled. So let us quickly look into the donut command. So we'll invoking it by typing in do the donut, and so the inputs that are required are initially the inner diameter of the donut, and next the outer diameter of the donut, and finally the center. So let us say the inner diameter to be 50 mm and outer diameter let us consider it to be 100 mm. See now based on the dimensions the donut has been created, but it's not yet positioned and it requires for a center. So assume we are positioning the donut onto here, right, and then click on enter. So this donut can be considered as a ring or a spacer washer or kind of thing. So to demonstrate that, maybe we can use this donut command. So now you can see here by default the donut command is filling the inner space of this object as a solid. So this is the application of the solid. But during printing options, your printer tries to fill out the entire space in here, and it will take a lot of time to print in certain devices, and also in certain computers it might take longer to process it. Suppose if you are zooming in certain workstation it might take a longer duration to reprocess it. In those conditions, then you have the option to turn off the fill command. That is, you're still using a solid command, but you're turning off the fill. So let us quickly look into type in fill to invoke the system settings. So with this fill command, you have two options of the system settings. It's either the on or the off. So typically it's in on mode. So let us select the off command. But right now we can see there is no change that has been affected. So for this we have command in AutoCAD called as a region. So it's kind of refreshing the view or refreshing the object properties. So that is called a region. So one more setting where region is used is when suppose we are zooming onto this object. So I'm still using the scroll button. Say I'm zooming to the maximum extent that is possible. As you could see, this circle now has become not a uniform curvilinear object, but rather a collection of small linear lines. So, but if I want to have this view as normal layout printing a view, then I have to regenerate this object. So in that condition, the regen command helps into. So remember, we were also talking about this region to affect this to look into how this object will look without the fill option. So let us type in the region. So now first part is you can see the fill command has been replaced by similar sort of a hatching command. So it denotes that this 2D object is a solid object. And coming back to the original topic, see now this object is kind of smooth but not completely. So let us keep this view and type in the region command again. Now you can see it has become smoother. So what region command does is it reviews the object performance as well as the computation performance to suit to the current view that we are having. So this is in short of the region command and the fill command. See, the earlier region what we had done was for that object. So for that zoom extents, for that scaling, the processor has optimized the view. So that's why you can see the lines are closely populated. So that mimics again a solid view. Suppose we want to region in this view. Now we can see it has optimized. So suppose if we want to region in this view, now the number of lines has still reduced. So Thereby, AutoCAD itself optimizes the solid fill option using the region command to ensure that the performance is optimized. So this is an example of a donut command. So let us take off this object. So as you can see, when we click on the object, it entirely has been defined as a singular object, even this solid. So this is the difference between a 2D line object versus a solid object. So I'm deleting this. So now let's look into the solid command. So this solid command is used to generate a triangle or a quadrilateral, whereas the donut command was used to generate a ring or a plate kind of thing. That is not a plate but a washer kind of object. So this solid command, when we invoke this, typically it will expect a minimum of 3 points. So the positioning of the points is very critical for this command. So for right now we can see it is asking for the first point. So we are specifying the first point and next the second point. As you could see, we are unable to see where the first point is set up and so on. So you have to be careful in setting up demonstrating the points that are being allocated. So next you click on the second point, and the third point for a quadrilateral or for any object, it always should be in the diagonally opposite side. That is, our second point was here and hence the third point should be here. Suppose if we click on here and then click on the next point, fourth point, see, it will look for a diagonally opposite line here and then constructed a different polygon. Right now the fill view is off and hence you can only see the object. Suppose if we enable the fill object and then region, you can see it. So this is not a triangle. Please make sure we have demonstrated 4 points: the first point, the second point, the third point and the fourth point. So this is a quadrilateral of this order. So let us select this object and delete it. Repeat the option for solid to demonstrate a proper quadrilateral. So the first point, second point and third diagonally opposite to the second point and the fourth point. So now you can see a quadrilateral that has been set up. And also please note that AutoCAD does not terminate the command. Like in our polyline, it is still expecting or continuing the object, but it is not prompting as the fifth point but rather the third point. So it means that it will take the previous 2 points as references for the next solid. So typically the first point was here, the second was here and third was here and fourth. So for the next object, the first point is this, second point is this, and suppose the third point we want to specify it here. See, I'm unable to select the third point here. So it means that it is exceeding the command here. So I have to select it diagonally opposite. Yeah. So it is selecting here and now the fourth. Now the object has been created with these 2 points as the command. So typically if your selection point is erratic or doesn't satisfy the inherent rule of AutoCAD, then it won't get selected. We can also alternatively demonstrate it. As you can remember, our limits was the paper sizes of currently of A2. So suppose I am selecting a point outside, you can see I am unable to select the third point anywhere outside this frame, because typically our image itself was of the largest dimension possible for those limits. Right, so this was your typical limit that is available to you. So you also have to make sure this limits again will help you to ensure that any object that you are drawing is out of your limits are controlled. So this is one more advantage of using your limits command. So now with the solid command, you can see as we are continuously drawing the object, it looks like a similar object, but if you hover on it above, you can see what are the different objects lying beneath. So this was our first object and this was our second object. Let me just hover correctly. Yeah, this was our second object and this was our third object. So one thing is that you always have to hover along the edges to select the object, not on the fill surface. Why? Because let us look without the fill option. So here without the fill option, you can see they are similar to polylines, and hence you are able to select only the edges, not internal to the object. So the solid command is again a different view of a 2D command, filling the internals of the boundaries of a given command. So this is why you are not able to select the object with the filled view. So always select onto the edges of the dimensions. So this concludes our 2D solid objects. So now let's look into the various selection techniques that AutoCAD offers with the different objects. So to have a view of this, let me just invoke the command line option. And now if you could see, while normally pressing the left click mouse button, the default selection object is invoked. So as you could see, it immediately asks for the opposite corner to be specified with a normal left click. Okay, so here you have to see what is the default option that is available. So it's called as a box command, and in box command it always expects you to give a opposite corner as selected to the first point. But there are two variants to this box command. If the second point is towards the right hand side of the first point, then you can see it is highlighted in blue. So it means that whatever objects that are enclosed within that selection window will be selected. For example, let me close this option by clicking the opposite corner. So as you could see, the objects selected are with the inside the selection, whichever objects have been there have been selected. So this is a box command of a window selection that selects all the objects inside the selection window. The same selection command works differently if you select the point to the left of the first point. So let us click on the first point here and then select the second point onto the right. As you could see here, now the selection window has turned green. Earlier it was blue in color, now it's green in color. So depending on the position of the second object, whether it's to the right or to the left, the box command differs. So now what it does is, now as it's in green command, it will look for the command objects that are only within this selection, or whatever is passing through the object will get selected. So now these objects were within the selection, whereas this object passed through the select command. So by this you can select which object you want. So this is the default boxing command of selection. So the next method is the fencing option. So you can click on it again, and two ways of selecting the subcommands are either you can click on the option that you have in the option menu here, or alternatively you can click on the down mouse arrow to select the next command that you want. So now let us select the fencing command. So fence means that through whichever objects the line passes through, that object will be selected. See, when we move this line across, you can see the objects getting selected at once. Suppose we want to select this object and then all the objects passing through the second line. So I'm terminating it by clicking in enter. So now you can see the objects that were passing through this fence had been selected. So if suppose there's a complex object with different sizes, or consider a polyline, an arc, and so on, and you have to select multitude of components, but they have different boundaries, then you can select the fence commands to draw a polyfigure through which all the selected objects can be highlighted and worked upon. So that was the fence command. So next, look into the next command, a window polygon. So in window polygon, what it means is it's typically same as the box command, except that box is a rectangle, whereas here you end up with a polygon. So whatever you are seeing in the initial polygon, that is W polygon, means it is within the selected polygon. So suppose if we are selecting a polygon of this area, then whatever objects that are enclosed within this polygon have been selected. So this is the W polygon command. Alternatively, you have the next command, that is the C polygon. So in C polygon, you can select all the objects that are enclosing within it. First point, the second point, third and fourth. You can see the color that is being varying as blue and green. So you end up with selecting all the objects because it passes through whichever objects that are touching the boundaries of the polygon will get selected. So typically you have to be sure of what selection that you want to intend to select, whether it's inside the selection area or passing through the selection area as a whole. So based on that, you get designated blue space or a green space, and by default you have a box command, that is a rectangular command. And if you want to go for multitude selection, then you can go for a polygon based one. And alternatively, you also have a fence command to select all the objects that passes through the line that you draw. So those lines need not require to be closed, whereas the box or the polygon needs to be enclosed, whereas the fence command can be an open-ended one. So this is one type of selection tool that is available. So next, we also have a select command. So we can invoke it by clicking on select. So here you select the objects individually. So let me just close the command line because in my PC it takes rendering time. So we click on select command and select the objects that we want to select. Suppose by mistake we have selected this circle and we have to do away with the selection, then we can type on R for remove to remove the object. And if you want to add some more objects to the selection, then you can click on A for add and click on the next object. So this type of selection is based upon the object or the feature, wherein you select the feature one by one. So where this selection command is of predominant use is that if you want to do an editing option onto the given object, so then you use the select command. So in certain commands, suppose if you click on the move command, you are expected to select the objects here. So it means that this select command succeeds the move command. But suppose if we have selected the object well in before, okay, and then inside the select menu itself, if you click on the move object, pardon me, so you select it, select the objects of interest, close the command, you get the object selected and then click on move command, then those objects are pre-selected and it goes to the next step of the move command, that is it expects the endpoint or select the base point for movement. So this is one way of utilizing the select option to pre-select the objects that are intended to be edited and then go to the respective command. So these are small tool tips for you for quickly operating with your editing menu. So what we have seen was the different views, zooming command, and next we also looked into the steering wheels, and also we had solid and donut option that we have seen, and now different selection commands. So based on that, this concludes the basic navigational techniques that are available in AutoCAD. So next we'll look into some sample exercise files. So now let's practice the friction plate drawing that is shown here. So we'll try to use all the tool commands that we have seen so far. For today's session we have seen different navigation techniques, selection techniques, and zoom commands and all. So let us try and use those. And parallelly, last week what we had seen was using different editing commands such as move, copy, array, break, mirror commands. And previous to that, we were seeing circle commands, arc, rectangular commands, and line commands. So we'll use these fundamental base commands to draw this diagram. So here you have to be very particular about the dimensions, key dimensions. So before proceeding to draw any new drawing, always make sure you are very clear with what the drawing entails or called for. So first, the application you have to be very clear. So this is a friction plate that's going to be used in an automotive comp engine or a gearbox. So here you could see you have on the center a slotted hole or a spline hole wherein this friction plate will get assembled onto the drive shaft using a sliding mechanism. So this slot will ensure that it can travel along the shaft, but it will get constrained by these slots, and hence when there's a rotational motion of the shaft, the plate also revolves with it. So this is one way of constraining the motion of a unit. So this is how your friction plate works. So typically this is in your clutch housing. So when you declutch, the friction plate material is pushed against the flywheel, so it breaks the mechanical force or the rotational torque that is available at the engine. So that typically means it slides away from the clutch. So when you re-engage the clutch, it slides back to its position and the friction material will hold on to the clutch, and then you get the power. So this is the functional unit of the current drawing. So you have to be understanding the each and every functional aspect of it to clearly understand what each component or what each object entails. So next, on to the boundary, again you can see some slots. So basically over and above this friction plate is where you will be getting the friction material, say it's asbestos or ceramic material that's going to be embedded onto it. So in order to embed them, you have 8 holes that are listed. So those are the riveting holes through which the friction material is clamped onto the friction plate. So next you also see 4 slots on the outer side. So that is where you will be getting the torsional springs enclosed onto those sections. So these are the different aspects of your drawing. So next let's quickly look into the dimensions that are included. So the inner circle, that is the inner slot wherein your shaft sits in, has a diameter of 50 mm. Onto that you have 4 slotted holes. So those are of rectangular cross section with width of 12 mm and height of 6 mm, and with respect to the center line it is offsetted by a 45-degree angle, and you have 4 slots in that manner. Next, if you could see the outer area where you're riveting your portion, where the holes are located. So the holes are located at the pitch circle diameter of 122 mm, and the overall material external dimension is 154 mm. And again, the spring area where the spring is going to be seated, that clearance width is of 30 degrees with respect to the center, and at either part of the center line it is distributed, so it is equally slotted with 15 degrees and 15 degrees there. And also the rivet holes are also located from the center point of the axis in 30 degrees, and each and every subsequent rivet holes is spaced 30 degrees with each other. So this is the typical dimensions inference from this drawing. So always please have a note of the units again. So all the units here are mm, and then again what is the dimension space you are working on, what is the maximum dimension, and check whether your limits are all okay, and then look for key dimensions that will help you to construct the drawing, and finally the application where it's going to be used. So now we'll start the drawing. So in the new drawing we'll start off with ensuring the units are in millimeters, and next the limits have been turned on, and also the lower and upper limits for A3 or the A2 size or whatever you are working on has been ensured. So we are using the same limits session. So to ensure that we stay within the extents, we first initially click on the zoom extents option so that the maximum dimension of the limits is captured. So next, now start off with the initial inner circle, that is the inner shaft area. So we select the circle command, center as here, and select the diameter of 50 mm. So once it's done here, so let us go back to this object, and now next objective is to draw a slot of, that is a rectangle. So let us initially position it outside here. So the dimension is going to be 12 mm in width and 6 mm in height. So now let's move this rectangle over to the circle that we have drawn here. So this is going to be the object. Clicking on enter, and then the base point is going to be this, and next we are going to position it along the point here. So next is we have to move this slot inner, because as you could see on the dimension, it's not on the outer but on contact with this circle. So in order to effect that, we again use the move command, select this object, select this, and then click on to the object. But as you could see, the snapping is snapping onto the perpendicular point, but then it always shows the nearest point. Our objective is it has to be positioned perpendicularly down. So let us use the polar snapping on by using ortho snapping, that is F8. So once you have done that, it will ensure that the snap stays to here, and you can see the nearest point is taken as here. But there might be a little bit confusion stating that, see, now we have snapped onto the nearest point, but when you zoom it closer, there might be seen as a difference, but you can verify it by regenerating the command. So now you can see it perfectly sits onto this. So now let us come back to the overall view. So now we have positioned this rectangular slot onto this inner circle diameter of the friction plate. So now going back to the drawing, we can see that this plate is not on the 90-degree axis but rather 45 degrees inclined to the center line. So we'll use the rotate command to move this object onto this position. So we are going to rotate it with reference to the center of this circle at an angle of 45 degrees. So this is done here. Next, what we are going to do is we are going to use the polar array option to replicate the other instances of this rectangular slot. So before that, we can also see that this component needs to be eliminated, right? So towards that, we use the break command that we have seen in the previous week. So the first off is we have to remove these two sections. So first let us try and remove this bottom part of the rectangle. So here the first selection point is taken by default, so let us click on F to override the first selection point. So we are selecting this point and this point. So now we have removed the bottommost part of this rectangle. So now let us use the array polar command to replicate this object. So the center point is going to be on the circle and the number of items is going to be 4. Alright, so we are done with this. So next is to break off this segment. We have to remove this arc. So one way is you can use the break command again to select the object and go about in anti-clockwise direction to do it, or alternatively what you can do is you can also remove the circle as in whole and then try and draw an arc between them with the same dimension. But when you're using the break command, again you are effectively breaking the polyline, then ensuring that it is taken into separate objects. So this is now a separate entity, whereas this is a separate entity. So you can go about in those. So one way is the break command. The other way, let's see how we can use the arc command. So we are deleting this object and then using an arc command and pressing on down arrow, we can select the center of this. And then first part, so let us take away the ortho command. So yeah, the arc, center part, start point and the end point. Always ensure that you select the center point so that you can quickly use all the objects that is already available here. You can click on the up arrow to quickly select the latest option that is available and ensure you are selecting the center here. And the first and second point always to be in the anti-clockwise direction. Yeah, so with this we have constructed the center part of your friction plate. So now let us go back and now draw the external component. The next component what we've seen is the slot area where the spring is going to sit in. So towards that you can see that the pitch circle diameter is same as the inner circle diameter, that is the external slotted spring area, that is 122 mm dia, and the external circle is 154 mm in dia. So let us draw two circles for that manner with this same center point, diameter as 122, as well as one more circle with the same center point of diameter 154 mm. So now the slot, as you could see, is from the center point along this axis or this axis, it is 15 degrees towards this and this side. So we can use the same option that we have done earlier, but now let us use the line command to do it. So what we are going to do is the start point, let us specify it here, and then let us give an arbitrary line, that is say as 100 mm, but the next point as an angular approach setting is it's always measured in 0 from this point. So the line, it should be 15 degrees from 90 degrees, so it means that the angle is 75 degrees here. So this has constructed this point here. So likewise you can, as it is uniform, you can, okay, right now let us trim this out. So instead of using break command, one more thing what we can use is you can select this object polyline and then click and drag it. So now you can see it is coinciding onto the intersection point. So alternatively, this is internally what's doing is it's using the stretch or lengthen command that we'll see in the ensuing classes, but right now we can click and drag to reposition it. So now let us use the mirror command to replicate this object, enter, along this vertex. So I am using F8 mode to ensure that we have the orthogonal command. So next, by default it asks whether we have to erase the source object or not, and by default it's no, so we are selecting no. So now you can see this object has been created. So we have to create the other objects also. So let us use the array polar command again to replicate this. So we are going to replicate this two lines with the center here, and the number of instances is going to be 4. So now you can see that the intended shape is coming into fruition. So now we are not required of this inner circle except for these points. So let us again take this off, and also this. So let's see the same way of using the R command for the inner point as well. So center, I'm removing the ortho command F8. So selecting the start point here and the end point here. And similarly, one more R command with the center as here, start point and the end point. Now we can use the array polar again to select these two objects and selecting the center point as here and selecting as 4 again. So now you can see it has beautifully considered both as the spring area as well as the rivet hole areas also. So this is how we can extensively use just the basic commands of move, offset, command to ensure that we are getting the intended shape quickly and fastly. This array polar is a heavily reliable tool that you have to be very familiar so that you can use it to your benefit. So next let's draw the riveting holes. So we'll use the circle command. So the center point is located on this PCD. So towards that, right click and go for the snap override and select the from option. So you are offsetting from this point at a distance of 61 mm, that is as the PCD diameter is 122, so the outer radius is going to be 61. And next we are going to enter the angle. As you can see, this hole from the center axis here, it is offsetted by 30 degrees. So again the angle is going to be measured from this, so it's going to be 60 degrees from this point. So you have got this center point located. Next is the diameter. So the diameter of this hole is 12 mm. So now it's got positioned here. So now let's again mirror this out, or you can offset by 30 degrees here. So let us, you can take in both ways. Let us try the mirror out command first. So this is your object and your center line has to go through this object. So let us try and see whether we are getting the center line here. Yeah, so this is the midpoint here, so we are not erasing it. So see, using a mirror command, we have mirrored this object to here. So now this hole in this dimension. So let us quickly check whether our intended calculations is correct or not. So you can just measure the angle, this, okay. So rather you have to use the dimension command to ensure it. Okay, so let us park it a while now, but you can see the dimensions are perfect here. So next we have to use the array polar commands to move these objects across the PCD. Yes, so with this we have constructed the friction plate Emend. So the dimension part, let us hold it a while now. The quick way of dimension checking is you can use this dimension command to check whether the objects are in the same dimension or not. But here you have construction lines and so. So in the next sessions what we'll do is we'll look into the different line types and weights. So there you can ensure how the dimensions are located and how to construct a construction line, and from then how to measure the angle. But here in this session what we have seen is we have used the fundamental editing and drafting commands to ensure that we are able to arrive at the final drawing effectively. So with this we'll summarize and close the final week 3 session. So this week what we have seen is different navigation techniques that will help us to go around the object what we're drawing in AutoCAD. So first we started off with zoom command. We looked into the different sub options available in zoom. That is all or center or dynamic zoom or zoom to extents, zoom to the previous version, previous views, then zoom to scale or zoom to scale of page, or zoom to a specific window or zoom to object. Next we had looked into the pan command to move the screen with reference to different requirements. Next we had detailedly looked into the functionality of steering wheels. We had looked into 2D wheel, view objects, tour building view, and also the full navigation view. And also we had looked into the different mini wheels that are available for each and every one of the previous application. And next we looked into solid drawing and donut drawing. So those are 2D solid models. So with that we were able to draw solid quadrilaterals, solid triangles, or solid circles. So with that we also seen how we can make use of the regen facility to ensure that the object regenerates for better computing and viewing performance with the current extent or current view space. So next we also looked into how turning on or off the fill command to ensure it is having less impact on the plotting device. So after seeing this drafting techniques, we also looked into selection techniques. So in selection, by default we had the box selection, and in box selection, based on the right or left hand side positioning of the second point, we were able to select either all the objects inside the window or passing through the window as a blue and green icon respectively. So in the same way, we also looked into W polygon and C polygon to have a polygon based selection window. Next we also looked into fence command, wherein we had the liberty to draw lines through the objects that are interest so that those can be selected, and it was an open-ended selection, whereas all the previous selection options were close-ended. So next we also looked into individual selection commands using select command and using addition or removal of the selected objects. And also we saw that for certain commands that require selection, we could pre-select the objects and then invoke the respective commands such as move or offset, so that the pre-selection menus are considered for. So finally we looked into a sample drawing of a friction plate where we had used the basic techniques what we have learned over the weeks, that is circle, arc, rectangle commands for drawing, also with line command. Next we used editing commands such as move and then break. So with this then we also looked into array polar options to replicate different views, and also we had used mirror commands to replicate the mirroring of the object. So with this we conclude the week 3 session of AutoCAD training. So welcome all to the week 4 session of this AutoCAD course. So here we are going to see the different Emend techniques, that is the editing techniques that are available with AutoCAD to be used. So until previous week, what we are seeing is we started off with the course introduction, went on with how to use the various orientation tools, and next we looked into what are the different zooming techniques that we can use, how to navigate around the drawing. So now this week we'll focus heavily on the different editing techniques that will help us to fasten the drawing requirements. So initial techniques that we look at is the introduction of the text command. We'll look very in detail to each functionality of the text command and subsequently build on it to the next level, that is the multi-line text command. So we'll dwell into these two topics very heavily, and the next sub properties of these two commands will be the style command. So we look into what are the different styles that can be employed and how it can be applied to the various text object that we are going to include in the drawing. And also regarding the properties, we'll look into the line type property and how to apply it. And parallelly, when we operate on multiple textual objects, we require to edit the properties of each and every one of it. So we'll look into the methodology to select the required objects using a filter command that's called as a quick select, and also we'll look into how to modify those properties in different manners. So next what we'll see is the additional editing command that succeeds the last week course. We look into scale command, extend, join, trim, rotate, lengthen and stretch. We'll look into how these commands go in pairs and how they support each other, and what are the key editing techniques that we'll be repeatedly using to fasten the drawing. Okay, now let's start with the text command. So we have two variants of it. One is called the text and next is called an M text, multi-line text. So these two are different text options that are available for us for one of the annotations that you can use. So annotation is something that you add information to the drawing. Some of the examples of annotations are, it can be notes or label to a particular drawing or a feature, or you can plot in tables. For example, if you're plotting an assembly drawing that consists of n number of parts, you can insert a table to indicate which part is what. And then also you can use this annotation for dimensioning and tolerancing, and next for hatches and callouts and blocks. So these are the typical annotations that we use, and for enabling the fundamental of it, that is to give a notes to the drawing, we use text and M text. So let's look into the first option, text. So you can invoke it by the text command txt. So once you specify it, let me also invoke the command line option. So let's go back again, text. So the first expectation is to the start of the start point. Next you also have two different options, that is to specify the justification or the style. So the text command expects just 2 points, that is it asks for the start point and next the end point within which this text has to be positioned. So this justify and style allows you to position the text differently and also define the style of insertion of the text. We'll look into one by one. So we'll just start off with the basic command. Now we can see it also highlights what is the default setting in this window. So the current text style employed is standard, followed by the text height to be 2.5 units, and in case of annotator it's showing no, and the default justification is set as left. So to typically denote it, let's start off with this point, and the next point is required for height, because as a single line, based on the height of the text, you can control how it's going to be sized upon. So okay, let us go ahead with the 2.5 mm diameter itself. So next it asks for the rotation of the text. So let us right now just stick with the 0 degree, that is going for a horizontal line of text. And now the text cursor is inserted. Ask for a text to be inserted. So let us just say text space text. So now this when you click on escape, it terminates the command. Sorry, let me repeat it again. Text, the start point, test text. Yeah, so not the escape, but you can click anywhere on the screen to come out of it, but the command gets extended, so wherever you push in the text, you can continue the text option. Now clicking on escape terminates the command. Now as you could see, the text is inserted, but it's of very small size, so you can zoom to extend to just see where the object has been positioned. So this is the single line text overview. So now let's see what happens if we keep on typing the test requirement. So let me just remove this command line, going back again, and now inserting the text command with the same height too. Alternatively, suppose if you want to specify the height by selecting 2 points, that also can be done. That is, instead of explicitly giving the dimension of the text, you can specify the height by specifying 2 different points. So the distance between those points will be taken as the text height. So suppose if we just give an arbitrary distance of this, so for this length, the text is going to get inserted. So the previous orientation that we have given is taken directly. So now let us directly so we just test 2, and then I'm clicking on enter again, and I'm writing one more line, test 3, test 4, and then terminating by clicking on escape. So now we have used the single text line command with using multiple enters to type different lines, but as you could see, each and every line of text is considered as a single object. So whatever lines you enter, if you give the enter command, that is treated as a separate object or a separate entity. So this is the major difference between your text and the multi-text command. So next, let us see how the commands are going to get positioned. That is the different justification and alignment options that we have. To denote it, we'll just quickly draw a rectangle and a line across here. So first, okay, let us draw the center line, and then let us draw one more line here. So this box has been configured to just have an idea about how the text is going to be distributed across the baseline or the center line, or justified from left to right. So this will give you an idea from where the originating point is and the end point is. So for a quick understanding, let us give out identification using text command here, and let's say text height of 25 mm and height of 0 is 0. Yeah, so as top. Okay, so this is not visible here. Let us check why. So the object is not getting highlighted. So quickly let us use this measure tool to just investigate how it is. What's the distance of this? Okay, so what it's having is there is 86 mm in length. So maybe that's the reason why our text is not getting displayed. So let us try it out once again. Text command. So this is the start point, and say let us say 35 mm as the height, rotation angle 0, top. Okay. So this looks a bit too big. Let us try it out with the smaller one, 20, top line, and then one more text. So this is going to be your bottom line. And then so this is going to be your left line, and then this is your right line, your center line. Okay, so just to ensure that the first text is visible, you have to type in enter and then click on escape to terminate it. Okay, so the start point is here, center, and the next point is here. So we are continuing the command now using this same text button itself, baseline. Okay, so idea is kind of a bigger dimension here to just have a view of understanding. Okay, now let us type text into here and see how the various alignments are going to get affected. So let us go into the text option again with the command line option enabled so as to have the views. So right now, before specifying the start point of the text, we will specify the size, justify. Alternatively, you can also push down the down button to select the option from it. So right now we are selecting the justify option. So here you can see the various commands that are available. We have left, center, right, align, then middle, then fit. Then we have certain abbreviations TL, TC, TR. So what it does is, what you can see here is there are two characters. The first character denotes the position, that is T for top, M for middle, and then D for bottom. Next character to the right denotes the orientation, that is whether it is left aligned, center aligned, or right aligned. Likewise LCR, so that is getting repeated for these three combinations. So that's what we have had here. What we have is we have the top, bottom, and then the center, that is the middle. And then again we have this orientation, that is this is the horizontal orientation. Now the vertical orientation is left, center, and right. So based on these combos, you can arrive at different options. So now let us again choose the left option from the dynamic menu. So now what we have chosen is the text command is going to be the same, but just the alignment has been updated to left aligned. So here what we have given is we can select the start point. So let us specify the start point as here at the start of the center line, or to see how it is. So let us keep a text height of 25 for a better understanding, and then the text rotation will keep a 0, no rotation. Now let us enter the text as sample text. See, what can be understood is, now if you click on this object, click on escape to come out of the text command and click on this object now. So what you can see here is this is the base point that we have specified. So actually this line is going to be the base of the text, and the entire text box is aligned to left to this point. So this is how your left command going to work in. So let us delete it out and then repeat the text again. So I am selecting the object and clicking on delete. Sorry, it's the erase command. Yeah, I have little problem with the GUI interface becoming slow when I'm enabling the control line, so it might be a little bit delayed. Okay, so I'm turning up the command line again. Okay, now let us repeat the command again, text, and then click down barrow to select the justify style. Next let us go for the center align. So For understanding, let us keep the base point as here. Let us not choose the center line, but rather here the baseline. As you could see, which point we are selecting will be acting as the baseline. So just extrapolating from this center line to this point, that also serves as base. So specifying this and retaining the same height as 25 and then the angle of 0. Now let us type in the test sample text. So right now, if you select the object again, what you can see is we have two orientations. The first is again is aligned to the baseline, and next, based on the selection point, the text gets distributed evenly on the left and right so that it is center aligned with this point. So this is how your center line is going to work. So the rotation angle for center line is again with respect to the base line and the center point, you can vary the rotation. So let us check the rotation once. So let us try and override on the same command to understand how the rotation works. So we select the same center point, same height, but rotation angle let us say as 45 degrees. See, from the axis now it is aligned 45 degrees. This is the baseline. It's been turned for a angle of 45 degrees. So this is the angle 45 degrees because for this angle the baseline is going to run through this, and hence the angle between this baseline to this baseline, that is the reference line, is going to be 45 degrees. So this is how your rotation is going to work with respect to the center option. So in this rotate command we can have one more variant. Suppose if you want to have the text in the upside down manner, you can affect that by specifying a rotate of 180 degrees. So let us use this text command again and let us overwrite on the same point to have how it affects, and the text height is same, and rotation let us specify as 180 and type in sample text. So this is to ensure that your initial alignment is okay, that is the angle is 180, but for ease of typing AutoCAD shows it as the same format, but you click on outside and then click on escape to have it affected. So now you can see that the text has been rotated 180 degrees, that is the text has been specified upside down. So this is how your command is going to operate. So let us quickly now go to the next one and use the erase command to delete the text that we have done so far. Okay, so now let us go back to text, and now in justify let us select the right justification. So as you could see now again the requirement, you can see it specifies the right endpoint of the text baseline. You can see in the dynamic info tool. So the rightmost point in the baseline is the specification followed by the height, and let us keep the text rotation as 0 and type in the code sample text. So now the text is right aligned with this point. Okay, so this is how your text aligned with respect to left, center and right on the baseline is going to act. So next command is in justify we have the align option. So in align what we does is in the previous commands we just select the left or the center or the right points of starting the text. So here what we do is we specify the endpoints of the baseline, and based on the number of characters the height is constant, but the width of the characters, that is the size of the individual characters, is adjusted in proportion to the height. So with differing endpoints dimension the height position is going to vary. So let us quickly see how it's going to enact. So this is your first endpoint, whereas let's select the second endpoint that's here. So this is a short text, and now let us type in the command sample text. As you could see, the height of the text is dynamically altered based on the number of characters the text is going to have. So this is one thing. So let us do one more repetition of the same command. So in this point let us say sample text size 2 or 4. So what it does is it will try to constrain the text object within the start and end point so that it does not exceed the boundaries. So this is the aligned justification available in the text command. So next we'll erase this to erase these two. So next text in justification is the middle option. So what it does is it will align to the baseline center and middle line center of all letters. So let us try and keep the same base point here. So it's actually asking for the midpoint. So let us keep the midpoint and same height and same rotation as 0 and typing it sample text. So now as you could see, it is holding it within the middle point of this text object, as well as the center point that we select is the center of the axis as well as the center of the baseline. Whereas earlier when we selected the center option, it aligns with respect on the baseline but with respect to the vertical center, but here it goes to the center of the baseline itself. So this is your middle command. So the next command in justification is the fit command. So there is a subtle difference between a fit command and an align command. So what align command had done was, we specify the endpoints of the baseline, and based on the number of characters, the size is adjusted along with the height. So this is what we see. But whereas the fit command, we specify the area within which it should constrain, and hence the height will be remain constant. Whereas in the previous align command, the height is going to vary. Whereas here the height remains same, but the character width will be getting altered. So let us quickly see how it's going to be. Again, we'll specify the first endpoint here and the second endpoint here. So now text height is provoked here, because the earlier command we didn't get the text height for align. So here we are constraining the text with respect to the height as 25. So now let us try the sample text. As you could see, the width of the text is getting constrained here. So let us repeat one more command here, saying a sample text of higher length. So as you could see, the object gets restricted within this start point and end point with the same height of 25 with this, right? But based on the number of characters, it is trying to squeeze in the character's length within it by varying the character width, the size of the character in individual character width. So this is your fit command is going to operate upon. So based on the requirement of your dimensions, you can try and use this variable, but typically you can stick with the fundamental dimensions that you're going to use, that is the normal left align or center align or the right align, and using the middle or the center command. Because if you go on use this, it will impact the readability of your drawing, because as you could see, whatever the text length is, it is typically easier to read these rather than this, because the fundamentals of your dimensions denote that each character should be of uniform dimensions, because you can see the width of the characters within which the character falls in is going to be common across. But when you try and use this justify fit or align, here you could see is going to be different from E and T. So this aesthetically does not look good. So that's why it is not recommended for a typical drawing. But in case of special requirements wherein you have to constrain the dimension of the text, then you can make use of these. So let us look now into the other commands in the justification object. So now what we have is again a combination of these commands. So we have the left, center and right align commands with respect to the position of top, middle and bottom. So let us look into TL first. So it's asking for the top left point of the text. So let us try and go with this dimensions what we have. So we are specifying the topmost and the left point, and we are specifying the same height as 25 and text rotation is 0 and as sample text. See, now you can see that if you click on the object, you can see where it is referred to. This is the top left point of this object text, whereas the height is denoted by this point. So this is your height and this is how your object gets positioned. So based on your text length is going to increase or decrease. But the height is be the same and the width between the text is all the same. So this is your top left. So next let us go into the text command again without deleting the object. Let us see how it varies. So now let us go for top center. So let us use this point because this is going to be top, whereas this is the center point of that. And text height is same, rotation angle is 0, sample text. Now select it. There is an overlap, but this is just to show you a variation how it affects. So this object is now aligned onto the top and to the center. Right, so the same is going to affect it when we use the TR option in text, that is aligning to the top right point. So hope you have got the context flavor of this. So similarly you have the next is the middle center, middle left, middle right, and next you have the bottom left, bottom right, and the bottom left in the command. You can try and using whichever variant is better for you. So typically let us go back to the original default option left. Okay, so we have reverted back to the command. So next let us look into the other variant of the text, that is now the style options. So it actually provokes for the different style options that is already present in the system. So inside style option we have a predefined option called as the standard, and also there's a question mark here saying that there is no other available, but you can select the standard option. So to look into like what it does, what are the different properties that are available in text style, so you can do it by two ways. That is, the first, in the annotate panel you can go to this text style, wherein you can manage the text styles here. So this is one way of doing it, or rather you can go to the format menu bar here and then go to the text style. So both provokes the same option, wherein you can customize the code that you want. So here for the standard style, as you could see, if you click on it, first option is it can't be renamed, but what you can do is you can change the orientation or font name that you want to do. Suppose if you want to change from Arial to say Calibri, then you can select and then click on apply, wherein you can see a font overview here, what would be the end effect that is going to affect. So suppose if you want everything to be in bold and then it should be in Calibri format with the width factor of say 1.25 and there's no oblique angle, and this is the default, then you can apply and save it, so that this will give be the standard format for all. As you can see, now the properties at the back side it got updated. If suppose if the options are not updated, then you can still go ahead and see, now we have reverted back to the old setting. As we had given cancel, it gets reverted back. You can still go ahead and give out a purge command. So what purge does is it removes all the unreferenced text style that are taken away. So as you can see here in this purge menu, you can have the text style options, wherein if there are any unreferenced, then you can purge all. So why this option has come? Because in this drawing we have not used the annotative style. So it is asking to remove this option or remove all of the sub menus that are available in the respective menu. For example, within textile menus we had an option called annotative that we are not using it. So you have an option to eliminate an unused function, but it is not recommended to do this. So the purpose for showing you here is, suppose if you have created multiple or the previous users have created multiple text options, that is they have created a new text style, say user 1 and so on, okay, and you're not using that, then instead of selecting it manually and then doing it, all user specific controls can be removed from the option here. So to do that, you enact the purge command. So that is the option of purge, whereas in style you can edit your gender command. So let's now go back to the standard command. So here there is an option to set what type of annotation that you need to apply to the text. So suppose if you want the text to be in the annotative format. So annotative means that standard text refers to any text that is available on the drawing. So next what we have here is the annotative text style. So annotative means that the text object remains the same even when the scale of the other objects are changed. So that is, the text remains annotative to the viewer scale. So this is the application of annotative. So suppose there is already a text style called as an annotative that goes as default, and suppose if you want to update this standard text style as annotative, then you can still enable this option to make this as annotative. A quick way of identifying whether the annotative style has been on or off can be identified with the symbol here, small icon that will display whether the text style is annotative. So with this we can specify with respect to the paper text height, it will vary. Suppose if it's 0, then it means that the default text height is automatically taken. Whereas if it's set positive number that is greater than 0, then the text height is being set automatically based on the paper text. Okay, so this is what you'll be using in case if you want to set the text size to be annotative. So one more key information to be looked at as the effects. Actually there are varying properties, it does not apply to all. Right now you can see that only upside down and backwards have been selected. It means that only these two options are available to be used for the text command, whereas the width factor and the oblique angle, these two commands have no impact on the single text lines. They all have an impact on the multi-text line only. So this is one key thing to be noted. And another thing is that suppose if you are working on an existing document, suppose consider this as an existing drawing document that you have opened upon and starting to work, whether this has arrived from somebody else, right? So you find that the text is of different text style and you want to apply a new text style, suppose this user 3. So you can see if you click on user 3 and then set as current text style, you do not see a change of the text. What you can see is, as the standard was the text style used to create this object, whatever change you enact to this will reflect in the drawing. Whereas you can recollect that this new text style was created only after typing out these texts. So it means that whatever change you make here does not reflect on the current setup that you have. So this cannot be done even if you try out region or any refresh of this won't work out. So why? Because there's also a property called as a quick properties. So suppose to check it, what are the conditions of this is, you can select here and see that it is a standard text style that has been employed and it's not getting updated. In order to change it, you can right click on the object and then go for Q properties, quick properties, and here you can see what are the settings with which this object was created. And suppose you can now change the selecting whatever you want to apply it. So this is one type of doing it. So now the other way of applying the updates to all the files that you have, that is all the objects that you have together, is to have a shortcut command called as a Q select. So that is basically the quick select operation. So it acts as a filter to select what are the different layers that you want. So suppose if you want to address only the text size or the height of multiple objects, then you can look into here. Now this quick select filter, it applies to the entire drawing here, and what are the object types that you want. So is it either multi-line, multiple, or suppose it applies only to line, then you can update in here. So now our requirement would be on text, and on the text what particular property do we want to address to. So you can see the different properties that are associated with the text, and we want to update this text style. So once you do that, you have an operator called as equals or not equal or select all. So suppose whatever we want to update, we can select it. So here the style must be equal to the value that we want. Suppose if we want to make it as an annotative standard, then we can click it out, and then how this change to be affected. That is, should it be included in the new selection set or should it be excluded in the selection set. Selection set as in the properties that are applying to this selection, so this drawing set. Okay, so based on this you can refresh or apply the changes in bulk to your drawing. So this is the application of the style command. So the next step is, once having entered the text, suppose if we want to modify the text, that is, if we want to update this text content here, there are two ways of doing it. One thing is, you can select the object and double click it. That will go into the text edit mode. You can see it in the command prompt here, text edit mode. So wherein, suppose I am updating with the capital R here. So in the right. So this is one way of updating. The other way of updating is, you select the object and type in DD edit. So once that is done, it again goes into the text edit option, wherein you can update the text as you want. So this is a functionality to update or edit the text that you view. So the next fact is that if you are typing in any special characters, then you can use some sets of Unicode or control codes to enable the insertion of text special characters. Suppose if you want to introduce the degree sign here, then typing in percentage C will actuate the degree symbol. Likewise, typing in percentage P will give in the plus minus sign. Next is percentage D will automatically convert to your degree sign. So these are all certain frequent commands that you use. Also, there is a provision to enable or disable the overscoring or underscoring, that is underline or overline. So that again can be done by using percentage. Okay, let me click in here. Percentage O for overscoring. So now if you write in here top, you can see that for this text an overscore has been assigned. So it actually acts, the control codes whatever you are using can be used as a prefix in case of symbols, or if you are using an underscoring or overscore on or off, it can be used anywhere. So once that a label has been turned on, it will apply for all the subsequent commands that you want. So if you could see here in the, let me come out of this, and okay, so the on or off command is not displaying here, but anyway we can use the overscoring to edit whatever text we want to do. So suppose if we want to underline a text object, then you can use percentage U. Next, so this is how you underline a text. So this is the variations of using the special characters of control codes. So next we'll see again inserting these special characters using Unicode formats. So what earlier we saw was the control codes that are specific to AutoCAD, whereas let us see some Unicode. So these are standards that can be used across the platform. So that starts with \U plus symbol 00 D and then following with a 0. So that will introduce your degree symbol. So next is your for plus or minus, it is \U plus 00 capital B and 1. Similarly, for degree symbol, it is \U plus 2205. So this is the variation between the Unicode and control codes. For ease of use, you can stick with control codes as it is much faster to apply those symbols and then start with your activities much faster. So next hack what we can see here is, see, you're working on this drawing now and all your annotation and text is scattered all around, but you still, this information is not currently required for you to view. Suppose if you have to operate on this object and there's an overlap or disturbance between the view, then we have an option to disable the text that is displayed in the current view. So to do that, you can type in qtext command and you can see the dynamic display. The input required is either an on or off. Suppose if we enter the on mode, that is, the text will be hidden and it should be replaced with an object or a box denoting its boundary. But in order to enable it, then you have to regen the image again. So if you could see, the text objects are being replaced with the box denoting its boundary. So now you can still focus on your work area. Why this is useful is because you can differentiate what your text objects are and you can selectively mask it to improve your performance. But if you still want to hide all those things that are available here, then you can do that using layers command that we'll see in the subsequent week. It means that you are slicing this entire drawing into different layers, and suppose assigning that all the text can be assigned to a single layer whereas the drawing can be assigned to a layer Y, then the first layer of text can be hidden completely so that you can operate only on the drawing layer. Okay, so now to enable back the text, you have to disable the qtext command again and then type in regen so as to have the view back. So on the single text line object, we can also perform one more operation similar to the mirroring operation that you do on an object. So the expectation out of a mirror command is that it will flip the text object horizontally or vertically along the axis that you want. So to enable that, we have a command called as the mirror text option. So this is either turn on or off the control that the mirror command has over the text. So that is, by default, if you use a mirror command, the text won't be mirrored. So let us quickly check what we are speaking now. So let us pan in this way. Suppose we want to mirror all these objects that we have here onto the next line. Suppose. So we want to mirror across this line. As you could see, drawing object is being mirrored. Sorry, let me repeat it back. The selected objects are all the objects mirror across this axis. See, the objects are exactly mirrored here. However, characters are not flipped. That means that the orientation is remained held the same. So this is what the default mirror command acts on the text. Suppose if you want to mirror the text also across the axis that you want, then you have to select the mirror text command. So by default it will be 0, that is you are disabling it, and you have to enter 1 to override the system variable so that your mirroring will apply to the text also. So let us now repeat back the mirror command. We have selected all the subject and then enable mirror. Now you can see the text object have also become mirrored. So this is one system variable command, mirror text, to enable mirroring of the text. So now let us go back and disable the command so that we'll have the same view. So now let's move on to the next important command of the text line, that is we have a multiple line text. Till now we were seeing the single line text command. So now let's look into the multi-line text. So we'll quickly select all these images and then erase them out. So the multi-line text can be invoked with the mtext command. So now you can see the difference between the single line and the multi-line is that you have a floating icon called as an ABC that denotes that it's going to be a multi-line, and next it asks for the specification of the first corner. So once you specify the first corner, and then the next requirement is to give out the next corner, or also we have additional options, the text properties that can be defined as height,
justification, the line spacing between the lines, the rotation, the style, the width and the columns. So we'll just go with the default setting first and we'll select the opposite corner. So once it is done, there are key features that you can look into immediately. That is, one thing is that you can see there is a ruler that applies on the top to help you to analyze like what is the spacing and all. So that is enabled in this one. So if you could see, this is looks like a additional one. As you rightly guess, it's a additional ribbon that is available, that is the text editor ribbon. It means that it includes the tools that are used and for formatting and editing, particularly to the multi-line text. So as you could see here, initially you have the style menu wherein you can select which style that you want to apply and what is the text height and what is the masking, that is background masking, that is required, and other properties, that is you have the bold, italics or the strike through command or underline, overline enabling. Earlier we were seeing to enable it or disable it using the command line object, but here you can see that it is also available in the graphical interface. Next, you have a dedicated command for selecting the type of justification you want. Next, we also have an option to define the structuring of the paragraph through bullets or numbering and specify the line spacing. So this is similar to what you expect out in a Microsoft Word or a PowerPoint. So that means that this multi-line text, instead of the regular CAD interfacing, this can be edited in a GUI way, that is what graphical user interface, and also popularly called as from the all the processing softwares, that is the word processing softwares and the PowerPoint softwares. They are typically called as a WYSIWYG, that is what you see is what you get. So in similar ways, now you can type in all the requirements to your text command operations through a graphical interface or through using these command ribbon button. The next, also we have an option to specify the number of columns that you want to specify within this. Is it either a single column or multiple column? Alternatively, we can also include all the symbols. So if we click on here, earlier we were seeing the command prompt to insert the different symbols that we want, that is the command line code for control codes as well as a Unicode code. So here, instead of remembering them, you can directly select from here also. Next, you also have an option to spell check the entire text that you do, and also text editing commands are available here. So this is your typical overview of the mtext command. So now let's look into each and everything. Suppose we are typing a command here. Okay, so we are clicking in outage. So now we see that using the mtext command, we have written 2 lines of code. But if you select this, you can see that this 2 lines of code pertains to a single text object. So this is the basic difference between a single line and a multi-line text. If you recollect, a single line text, even if you type in multiple lines of text, each line will be considered as a separate object. So this is the first difference that you have. So again, then if you double click on it, it will go to the edit mode. So instead of the DD edit that you have in the earlier menu, so here you can do empty edit, that is the multi-line text edit. So this invokes the editing of the multi-line object. So next we can see the other properties that will be useful for us. So this is a GUI interface. Alternatively, by right clicking onto this box, you can have additional commands. So here we have the insert an external field that you want to do. So this is a normal copy paste options that are available. Next is the insert field. So it means that if you are referencing to a tertiary object in the AutoCAD environment, then you can insert that field as a reference. So suppose if you want to insert the date and in what command it is, then you can insert that as an object into this line itself. So this is a field editing option that you have. So here again, once you click on the field and right click it, then you have an option to update the field or edit the field. Suppose the current date that we are working on is 14/4, and suppose we open it up in a later date and want to update this field, then you can click on this object, right click and then update field to reflect these changes. So this is the functionality of a field. Okay, so let us delete it and come back to our point here. So again right clicking on, so now we can see an option to insert the symbol directly from this typing space. The same symbols and in the control codes as well as in the Unicode force are available, and also we can introduce a non-breaking space, that is you introduce a line break here, so that also can be enacted through this command of control shift and space. So alternatively these are the frequent use commands, and suppose if you want to insert additional symbols, then you can click on symbol and then other, so that will invoke the additional character maps that are available. So here you can look into what are the different options that you have. So this is similar to the line of the other word processing software that is available to you. Suppose you want to introduce a gamma symbol into it, so you can take the corresponding symbol. So once we select this letter gamma, then you can see the associated the Unicode symbol for that. So it is U plus 03B3. So if you click on that and then select the object and then click on copy, then that is get taken in copy. Now you can right click and then paste it to introduce the symbol there. So this is the usage of the other symbols commands in the multi-line. So next what we have here in the text is importing a reference text from a different file. So suppose if you have saved a text template in the .txt file, then that again can be inserted into your drawing. So next what you have is the alignment of the paragraph. So you can do it in the graphical ways, that is if you want to justify this paragraph alignment, so then clicking on this, so now it is justified. Suppose if we want to do it in the, so you select this text and then click on the left justified so as to enable the left justification. So likewise you can do. So earlier what we saw was you can do this by going into the command of mtext, and so in mtext what we have to do is once we specify the boundaries, then before specifying the next closing the boundary, you have to specify what is the height or the distance. So now let's look into one by one. So specifying the h option height, so thereby you can define the text height. So as in the single line object we had used 25, that has been carried forward for the mtext. Suppose if you want to change the text height as 30, now it will get updated. But as you are in the command line and in option property, so the command reverts back to the previous requirement of specifying an opposite corner. So now let's look into the justify command again. So here you can select what type of justification you want. So as it is a multi-line command, the fundamental alignment operations get done away with, that is you get a combination of the alignment only. So you have the justification as top left, top center, top right, middle left, middle center, middle right, and bottom left, bottom center, and bottom right. You do not get an individual text left, center or right commands because essentially involved with multi-line text. So this is one difference that comes along with the justification option in multi-line. Next is the line spacing, that is command L, or you can select in the dynamics here. So how are the lines between the individual lines spaced? So there are two options to it. So the space should be at least so and so distance or exactly so and so distance. So with these options you have an option to select the spacing factor or the distance. So when we selected the command as is, that is it should be exactly so much of distance, and the default distance is selected, you can see in the angular brackets, that is 1x. Suppose the default spacing between the lines should be 2 line spacing. Now you can see that, so the line specification value should be between 12.5, that is 0.25 times, and 200, that is 4x. So let us say the distance value as say 25. So because as the minimum most value 12.5 corresponds to 0.25. So we have selected the specification distance as 25. So alternatively, if you want to specify in terms of factor, then you have to specify with the x command. We'll use the exactly command and then say as say 2x. So now the factor is being captured as 2 times. So earlier that 25 denotes the spacing between those two lines in units, now in terms of factor. So next we have the command to rotate the text, that is using the rotation option. Again, as in the single line test, by specifying the angle with respect to the baseline, you can specify the rotation. So next command is the style command. So earlier in a single line, you have to either select the styling earlier or have to update it individually for each and every object, but here you have the selection to use with the in the command itself. So based on here, if you click on the down line, you can select the different styles that are available. So right now this style we have selected is the user 1, so you can select with that. Suppose if you want to change the styling also, you can do it once you have gone into the multi-text editing properties. So next is the width command, that is the width of the text line. So here you can specify the width that you are requiring for. Suppose it's of 50 units, then that width can be specified. So as you can see, now the ruler gets aligned according to the width of the text line. So alternatively, you can also dynamically adjust the text height and the width based on the requirement. So this again text, when you go for that, typically you can use the same for single line and multiple line, because this text offers a varied way of controlling the text that you have. So and again with this you can rely more on the dynamic way of selecting text, so that it is helpful for you to quickly address the options. So in the next text of the text option, we have the columns option. So that can be invoked with this command with columns, and you can see there are three variants to it. We have a dynamic column setting, a static, and a no columns option. So no columns, it means that it is a single column, whereas in dynamic it means that you can control the columns dynamically through the UI based on the requirement. There are no hard fast boundaries for the columns that needs to be defined first. Based on the requirement, it is flexible to be adopted. Whereas in static, it means that you specify the total width and height of the text object and also the number of columns. So based on it, the columns are divided and split into. So let us look into one by one. So first is the default column width for dynamic is, let us go with the same settings. 750 for the column width, gutter width for 125, and the column height is 250. These are the default settings, so let us go with it and see how it's going to vary in the GUI. So suppose we want to give in two columns that specifies the serial number as well as the component name. Then in that case, in this ruler is where you can specify the column. So see, right now we have a dynamic column that makes sure that the height is getting adjusted, whereas the width is getting gone. So suppose we want to insert a column here, that is, say it's a serial number, and then specify that we need to insert a break to it. So we can press it by clicking Alt Enter or the screen over there. See, now the width of the column is mentioned here, so we can dynamically control this width. So as seen earlier, we had specified for the dynamic columns the width to be of 750 mm. So that is what is mentioned here. So likewise, we can extend it. So this is the total width, and now we can expand the width accordingly. So but as you could see, the column width are controlled based on it. So it is uniform in structure. Whereas if you type in the, say it's a product name of spec, it gets wrapped automatically. So this is how the width is going to get controlled by the initial setting. So by varying that, you can update the dynamic column settings. So this is how the dynamic column option is going to work through. So the next option what we have is a static column setting. So in static columns, you can specify how many columns you want. So suppose we have a requirement of 4 columns, then the width spacing is maintained accordingly. So this is the width between the columns. So that also can be adjusted Suppose if we invoke this, select this object and right click, so go to the column settings here. So now you can control it dynamically, that is for the dynamic columns with an auto height setting, we can adjust now the width, the height is same but column width you can adjust, and maybe you can reduce the gutter size. So suppose it's of 15 mm only, so that it will get closer. But the point to be noted is the properties denote that we have a constant width that is of the columns, so that is going to be held constant. So based on that, the total width of the dynamic M text is assigned. So this is how your dynamic columns is going to be employed with the M text command. Whereas also you next have the static columns that does the same job, but rather you specify how many number of columns that you want instead of dynamically entering in the GUI environment. So this sums up for the mtext, the column commands. And next let us go into the specification of the additional tools that are available with the mtext command in the ribbon prompt. So I'm double clicking onto this to invoke the other commands what we have. So here we also have the bullets and numbering that options are present. So this is similar to the other word processing softwares you have, so we are not dwelling deep into it. So next also we have the find and replace for choosing any text within the option. So it invokes the similar view of the word processing softwares that are available, so you can make use of it to search any text within the full drawing. So next, alternatively, you also have the other commands, that is the different character set that you can call in for the language set, and next the editors that need to be shown. So this is what we were talking about, the WYSIWYG, that is what you see is what you get display box. So with the latest AutoCAD settings, now it is always in the enable mode. So what it does is, it helps us to directly edit the text in the current UCS view, or also control the in-place text editor that we're going to use. But normally in the 2D setup, that might not be of much use to us, but it might be have an impact if you're placing a mtext in a different layer or a different angular plane, then it might be of impact to you. But the concept is that by default, when unchecking this option, whatever text that are going to be written in, typically whatever is difficult to read, that is of small text or a large one, it will be always legible, and it is always oriented in the horizontal plane, so that we can easily read and edit. So if we want to enable this, then we can select it by using this command, I mean with this selection. Alternatively, we can also use this command line object, that is m text fixed. So it will show this option is for the in-text editor. So by default it's 0, that is it's the option is checked, or else it can be set to 2 so as to disable it. So based on the requirement, and if you find the editing with the mtext command to be difficult, then you can make use of this command to facilitate faster editing. Next also what we have is in the command additional settings is that the toolbar setting, that is if you are difficult to edit with the text editor ribbon, alternatively you can also have this text formatting toolbar that goes in. So it's in the classical view, so wherein you have the text style, then the fonts, the sizes, then the different options, then also you have the text formatting matchup, that is the format command that you see in the word processing softwares. Then you have the different alignments and text subscript, superscript options, and symbol options with the angle specification, and then also the spacing between the characters can be controlled. So these kind of extra commands is what you can take from the text formatting floating toolbar also. So this component is enabled through the more command, and also here you can access all the options that you find when you right click on the text space within the mtext command. So this is what is a consolidated view of all the requirements you have. Suppose if you want to have this additional characters, then again you can expand this out to check. For example, this clicking out look into the paragraph properties, that is to say what is the position of the leftmost corner, rightmost corner, and henceforth, and how much should be indent. So these kind of detailings also can be taken from this extra box here. But suppose if certain commands are not available, then you can again take it off through the text formatting. So it depends on our requirement to use whichever we want. So next, finally, what we have here is uh, the background option. So when turning it off, you can see the text mtext boundary disappears, but it's all the more useful to have it enabled so that you can determine like what is the width of the size, what is the gutter width and all. So it is easy to visualize and then operate accordingly. So finally in this command, what we have in editor settings is the highlighting of the text color option. So we can select what is the highlighter that's required for the text character. So this you can make use of the requirement whenever you have. So this sums up the additional commands for the text editor window. So finally we also have the option to enable or disable the ruler so that it's either required to be visible or not. So suppose if enabling back, if the ruler is not visible, then you can exit and then come back again to the same text editor to view accordingly. So this is pretty sums up the mtext command. So depending on your usage, you can either opt for the mtext multi-line text or the single line text command. So next, let's see the color option that is available within the AutoCAD environment. So it can be invoked with the command called as color. So what you can see here is similar to the text highlight color option that we saw in the mtext purview. But in mtext purview, the color that is specifying is in view of highlighting the text that is going to be selected. So it's not about changing the text color, but rather just as a background highlighter impact. So let us quickly go into it to differentiate. So let us click on this object and then select the, in editor settings, text highlight color. Suppose if we keeping the color as green here, next when you select the text, the highlighting color will be of green. So this just to differentiate. Suppose if we have a drawing with different layers and of different line types and line color, then you can use this option to differentiate the highlighting that you're going to use it. But the generic color that we are speaking about denotes the painting the different objects that we have with a unique color sets. So the tabs that you have is similar to what you had in the command. So it's the index color, true color, whereas color blocks. So what happens is index is the prefix AutoCAD color index, that is it varies from 0 to 255. So it has this prefix color option that are using to highlight whatever you want. So this is how it varies. So it starts from 1, that is red, that is the standard color variance. Next you have the intermittent variance for each and every one of it, and finally the maximum color that is available to 255. So by this you can arrange it by either the layer or by block that you are constituting the diagram. So we look into these color details more into when we are looking into the layers. But right now when we want to select these colors, what we can do is, suppose if you want to change this color size to be say black and click on OK. Just as in your command for text that we have seen, the formatting style, it won't get applied because this was created using a different color set. So if you want to change the color of it, then you have to go into this and then select the colors that you want to apply. So suppose if this is the color that is going to get applied, then you have to select it and then select black in order to apply it. So for the text objects, for applying the color, you have to get into this object editing command and then apply the required color. Whereas this color command is a generic command that applies to entire of AutoCAD, and you can segregate it by either layer definition or by block definition. So based on that you can vary it. Whereas in true color, it's an extension of the index color, that is it is a continually variable color option that you can choose from. So typically pattern of varying from 1 across to 0 across. So you get a whole spectra of colors that you can select from. You can see the hue that is going to be varying here. So based on that you can vary the intensity of it. So suppose if you select this and then you can select the entire range, so you can see how the combination of RGB, the base colors, varies to figure out the resultant color. So this is your true color option. Whereas also we have color books, that means it refers to any third party color books that are available, so that you can set blocks of color that you can look from. Suppose if we select this color set, we have different variants that are available, so that these are like a prefix color combinations that are available, so that also you can enable. So suppose if you are having a printer set of certain variant, then you can get this. These are the different third party options that are available here. So this is a short on the color option that is used in AutoCAD. So next we have the line type that is going to be defined. So you can invoke that by typing in the command line type. So once you invoke that, you get the line type manager window, wherein you can show what are the different line types that are called for in this window. So typically you have these three as basics. You have line type by the layer, by block, or a continuous description. If you select it, you can see that these are the default variants wherein you can't rename it. So suppose if you want to have a unique line type that needs to be inserted, then you can load a prefix line type that is available. So you can see here the different options that are available and their unique code identification. This is an ISO continuous dot type, and so on and so forth. So whatever is required for, you can call for and then add to your database. So now this is typically a hidden line set, and then you can load line set. So once you draw it, as you can see here, now the line type has been defined as in the hidden line here. So now when you construct a line, as we have selected black color as the line object, so it is turned in black. So let me just revert it back to the layer command now and redraw the line. So on highlighting, you can see on zooming it, you can see that the line type is now defined based on the selected line type. So this is how you select the options that you want. Suppose if you want to change it in the even without invoking the line type, that is after invoking a default line type, if you want to modify it, you can also do it by selecting the object, right clicking it, and then going to properties and selecting the line type that you want. So suppose if you want to revert back to the continuous line, you can do so by this, and also if you want to vary the line color also, you can do this. So this properties toolbox is a very useful tool set to vary the properties of the given object. So this is a short on the line type command. So you can also see what are the other commands that are available. So what we have is we can also have this scale factor for this line. So for this line, the description is given and also the scale factor and the object scale is given. Suppose if you want to apply the scale factor to the object, you can very well define as a global parameters. Next, we also have an option to select what are the line types that needs to be visible. Suppose we are invoking large number of line types and only those that are called for needs to be displayed, then you can use the option that are available here. So based on this, you can have a variance of line type that's to be managed. So this summarizes the line type command. So right now what we have covered is all the basic text commands that are invoked in AutoCAD, that is the single text, multi-line step, and the properties involved to it, that is the styles, the color and line type. Now let us look into some more editing techniques. So let us erase all the object. And let me zoom back to the extents. Okay, So now further editing techniques what we have here is the stretch command, scale command, extend, join, trim, rotate and lengthen. So let us look into each and every one of it. So now let's start up with the stretch command. So the stretch functionality is used. We have to change the size of an object when the change is restricted to only one direction. So in that case, we can use the stretch command to either stretch the component or compress it based on the direction and magnitude. So towards this, let us try and constitute different objects. So for this command to work in, we have to have multiple objects wherein we are extending only one of the objects or stretching one of the objects with all other objects being intact. So towards that, let us say construct with the ortho mode on. So let us say we are constructing individual object, because if you extend the P line, it's going to be treated as a single object, but right now using line command we have created two different objects. And let us construct a third line that is of a similar manner, wherein we have to stretch this line to this point, to this object. So in that case, what we can do is we can invoke the stretch command, and we have to select this object that needs to be falling within this crossing polygon method. So typically what we do is we use this specification to select this object, and now the base point that needs to be selected, so it has to be selected from this, and then this the endpoint. So what you can see here is, with the first and the third object being intact, only the second object that was selected has been stretched to from the base point to the intended endpoint. So basically you're altering the size of this line, the dimension of this line, using this stretch command. So we have some variations to it. So let us revert back to this. So if we use the stretch command and then select all the interacting objects, now selecting the corners, it will cause the object to get moved, because these two are associated, and hence these two objects are treated as a single entity, and now it will act as a move command rather than a stretch command. So this is how the stretch is going to vary depending on the selection that we have. So the next option, instead of specifying the endpoint, we can also specify the distance that is going to be stretched upon. So let us go back in the same way. We are selecting this object, and in displacement we will specify the distance of displacement. So typically we have to move along the x direction without modifying the y direction. So in this coordinate, it's all about x, y and z. So in x, let us say it's going to move around by say 100 units, whereas in y and z there is not going to be any variation. So now we can see that this stretch is again enacted with 100 units across the x-axis. So this is the application of the stretch command that we have seen. So next is what we have as a extension to it, that is the extend command. So right now the stretch has been used as a combination for both extend as well as the move command. Okay, so just before extend, let us look into the trim command effectively. So as you can see here, now there are two intersections towards this object, and so we want to terminate this part and also this part. So in that case, we can use a modification for the object as trim. So that can be invoked by using the trim. So once you do that, it asks for the objects that needs to be trimmed. So the objects that are to be trimmed are these two. You can click on enter, and next what type of trimming needs to be done. So we have to select the type of trim. Suppose if we want to trim by using the fence object, so we can select that. So whatever objects it goes through the fence will get deleted. So typically you can use just to delete it. You can see the hidden lines are going to be the deleted component. So that is the option of using a fence command. So this is the one way of editing the object. So reverting back, next using the C command for a crossing. So now you can select the objects that are falling within. So when you're crossing the objects, so whichever boundaries that touch in get eliminated. The object within the boundary is retained. So this is the using of cross command. So you can correlate that whatever select and command that you have seen earlier applies to this. So the next option what we have is the project option, in which view of plane of projection that you have to trim into. So in that case you can select what is the different layer. So as we are in 2D, currently we may not have an application towards it, but if there are trim that needs to be made based on different planes of projection, then you can invoke this option. The next trim option is the edge option. So wherein again it determining based on the 3D element, we can, this calls for extension. So let me go back to this command trim. The edge. So based on the implied edge extension mode of the an object. So this is used when this object is trimmed by another object's implied edge, that is a projected edge, so that the objects get intersected in a 3D space. So in that condition we can use this trim, and then after enacting the trim, whether the object should be extended or not. So that command is the sub commands that are invoked in here. So next command what we have in TR, that is trim, is the extend command. So right now final is the erase command, so that is to remove the object. By doing this, again by the crossing methodology, all the objects that are included and crossing will get erased or removed upon. So it is not a trim mechanism, but rather an object deletion mechanism. So this sums up the different trim commands that we have in our exposure. So next we have this extend command. So this extend command helps us to elongate an object to a specified boundary. So this is an extension of the stretch command, but in stretch we are doing an ambiguous stretch, whereas in extend we hard fix the boundary to which the object needs to be extended. So to understand it, let us draw a line that is of some oblique angle like this. So now the objective is to extend this object that intersects with this object. So towards that we can invoke the extend command by EX and select the objects that needs to be extended. So it does not denote only to this object, but rather the interacting object also. So typically these are the objects that are going to get interacted, and once that is done, which object to be extended. So if we hover above this object, you can see now the object is going to get extended. So alternatively, if there are several objects that need to be extended, then we can now use this different commands that we have, the fence, crossing, or the project. Difficultly commands are similar to the earlier trim command that we have seen, that is the fencing type of selection and so on. So we'll go back to the original setting. So in extend, these objects and this object to be extended, whereas in fence, if you can select, then which is the first fence point of selection. So this again denotes to the object of extension. So you can see this works only when this fences the extension object. But if you just select one object and then select the other object, it does not show that the object does not extend to it. So it's always required to select all the objects that are getting interacted. So let us do this selection one more time, and let's see. We also have a command to trim the object also. That is, if we shift and select this object, you can see the trim command getting activated. Whereas if we remove the shift, you can go with the extend command. So this combo allows us to do both the activities simultaneously. Likewise, if you invoke the trim command, we can select the objects of influence. then you can see that this is the default trim option. While selecting the shift button, you can also invoke the extend option. So this is a quick fix approach for the modifying the object of interest using the trim and extend command. So that we will be extensively using across our modeling sessions with respect to other commands, because stretch and lengthen can vary, because we can override those commands by using the two commands itself. So now let's look into the lengthen command also. So lengthen command is invoked by specifying len, so lengthen. So first it will ask for the objectness to be considered, and also it returns the dimension of measure. Suppose if we want to extend this object, you can select this object, and once selected, it also returns the distance of the object. It shows that the current length is of say 110 mm. Suppose if we want to extend it, we have the object, the control using a delta distance or extension based on a percentage of the total, or the direct interference of the distance using total, or a dynamic measure. So let us invoke the delta command first. So what is the delta length? It has to be increased. So suppose it has to be increased by unit of say 50 mm. Next, it again asks for the object to be extended. So now, depending on the direction that you specify, if you bring it to this line, you can see that it is getting extended. Whereas in this line, it will get extended to the other area. So this is one way of doing. So I'm giving the undo command, or rather will come out and then keep on lengthen again. So the next is the percentage option to select how much of percentage of length. So suppose if you want to reduce it, then we can say, like say 75% of the original length. So now it is getting trimmed. 25% of the component it will get trimmed using this. So the next variant of lengthen is again the total distance that is going to be specified. So what is the distance it will be lengthened? So as we saw, the original length was 110. Suppose if we are giving a total length of 50, then it will get truncated accordingly. Suppose if we give a positive distance say of a higher length of say 150 or 200, it's going to get extended. And next, the final one is the dynamic input. So once specified it, so then we can make use of the handle that is going to select it to extend or trim accordingly. So as said earlier, the stretch command and lengthen can be used in multiple ways, but however the extend and trim can be used extensively and interactively so as to make sure that the intended end objectives are met. So next critical option that we are going to look now is the join command. So that command is typically used to join two objects into a singular object. So that can be applied to a line type of object, that is a linear object or a curvilinear object. So let us quickly look into such examples. So suppose we have connected, like say, one more line to be here, that is in this line. So let us just draw a linear object to be easy. So selecting a line and then keeping the ortho mode on. So this is the first line, and suppose we have a second line that present in the same axis. So we need to join these two line objects into a single one. Then you can use the command as J for join and select the objects that to be joined. So with these two objects and click on enter, now it's extended and then merged as a single line. So this is the linear extension or linear joining example. So now let us try and join a curvilinear object. So towards that, let us invoke an arc with the start point here and the center point as here with the end point as here. So let us zoom back. So now we can again use this join command to select this object and then click on enter. So now as we have selected the object of the circle, then its option is selected there to select the arc to join to source or to close. So now we can use the CL command to close the arc to form the circle. So if suppose we want to extend to a different objects make use of the first one, that is the so this is the source object. Okay, yeah, it has to be in circular object in command. So typically this arc with close option and the linear join option is pretty much used to merge two similar objects on a same plane at once. So this is with the join command. Next we have two more commands, that is the scale command and the rotate command. So let us try and do it. So let us call for a rectangular object here. So this is the object of reference, and suppose we have drawn in a scale of 1x time. This object is taken as a reference to a different drawing where the object is of in a scale down version, say it's of 0.25 times of x. That means the dimension is the same, but it has been scaled down. The reference scale in the drawing is of a different unit. So in that case, what we can do is you can use the scale command sc to scale down or up the object that is required. So if you are the first requirement is to select the base point of scale. So suppose using this base factor, and then the scale factor is asked for. So depending on the scale factor, so you can see here dynamically you can see how it varies. So the original object says as 1, whereas less than this or higher than this. So suppose if you want to scale it to 0.5 times of the original object in the numerical one 0.5, so now the object has been scaled accordingly. It means dimensions are reduced by 50% to enable this scaling option. So alternatively, the additional commands what we have is to have a copy or the reference. So in case if we use the copy object, then the original option is object is retained. So with the scale reference option, what we are doing is we are specifying a reference length to which the object needs to be scaled. So after selecting the base pointers here, let us select the R option. So it asks for the reference length. Suppose the dimension of a reference length is say of this width, then we can select this reference length, and then we specify the final length that needs to be, that is the new length. That is, suppose if the new length is of dynamically say this, and hence now the object is scaled in reference to the original object, and then final is attained. So this we can use if we do not have a hard and fast ratio of scale, but rather when we are importing two drawings wherein one does not have the proper dimensioning it, then you have to scale with a reference length that is available. That is, if there is two objects going to be fit into two together, then we have the common interference layer, so that you can have that layer as a reference and then scale the entire object accordingly. So this is used to scale the entire drawing on a whole to match the properties together. So this is the scale option that would be useful when you are porting drawings across or have to modify the dimensions based on the requirement. So next we'll quickly look into the rotate command. In the previous assignment we had looked into this command, a previous activity. So let us quickly see what are the options available in rotate. So let us select this rectangular object for rotate, and then the requirement is base point similar as scale. Then you can see we have similar options as in scale. We either have a copy or a reference. In case of a copy, the original object is retained. So we have selected copy, and then now we have to specify the angle of rotation. Suppose if your angle of rotation is 45, now the original object is retained as well as a copy with a 45 degree of rotation is enacted. So now one more variant of rotation is again the reference menu. That is, we can select the object that needs to be referred. That is, the reference angle is this, whereas the new reference angle is this. So likewise we can quantify, because right now we are just keeping it on a blank space, but suppose if we have a predefined angle dimension that is available, then we can use those two dimensions to enact the rotate option. So this is the next drawing that we're going to plot. So this is called as a latch plate, mechanical element wherein this plate is bolted onto a surface which has a slot in between through which the latching element goes in and gets locked so as to have a mechanical mating with it. So this is called as a latch plate, and here we are going to look into the dimensions that are critical for our drawing. So typically this drawing is of a rectangular dimension wherein we have 4 holes of 5 mm diameter drilled onto the plate, and internally we have a slot of with 12 mm, and we also have a overlapping circling holes of 20 mm and 4 mm radius in diameter, and each of the surfaces are either filleted or chamfered. The chamfering angle varies from 15 degrees, and then also it goes to 135 degrees of included, and the filleted radius is 5.6 mm for the external surface, and in the internal surface is of 2.5 mm in radius. So this is the general dimensions of the latch plate. So for this model, what we'll try and do is we'll replicate using the fundamental shapes that are available to us and what we have covered earlier. That is, we'll use the rectangular option, the circle option and line option only, and through that we'll use all the commands that we've learned earlier, that is the offset command, the trim command, extend command, mirroring commands. We'll try to make use of all these commands to bring out the final drawing. We'll start off with the latch plate design. We are going to replicate the key dimensions and then make use of the commands that we have learned in this today's session to replicate the diagram at the earliest possible time. So towards that, as the first step, we always ensure that our units are all in millimeters as per the diagram, and then the paper size, that is the limits that are going to be set, and so the lower corners are always 0 and 0, and let us retain the same dimensions as 420 and 297, and then zoom back to your distance to make sure you are within the operating range. So now let us first construct the overall external dimension. So consider this as a normal machining operation. So for this latch plate dimension, the machining plate has to be a width 63 mm and a height of 35 or roughly 36 mm. So towards this, let us construct the drawing first. So let us construct a rectangle that's going to be, say, let's start this point from here, and the next point, the x-axis, it should going to be 63 mm, whereas in y-axis, if you could see the distance between those two holes, the 4 holes part is 30 mm, and the fillet area is 5.6 mm. So on a total, the distance is 41.2 mm of height. So let us zoom back to this. So this is going to be the rectangular plate onto which the machining operation that's going to be enacted. So now let us leave out the fillet area to the last. So now let us draw the key dimension. Next is the specification of the circular holes. So now the circular hole dia is of 5 mm, and that is located from the center point of the center axis 15 mm in length. So towards this, let us draw a reference line for our analysis. So let us draw a reference line as for now, and towards this, let us make it to be a construction line for our sake. So you can do it by two ways. In this line type, you can add a center line that is going to be add for. So you can use for the center line command that is already there. So you can include this object and then again select the properties and then select the line type to be center. So this is one way of doing it. The other way of referencing a center is in the annotate command. You have a center line option. So it means that the center line for these two objects will get enabled. So this is one way of doing the plotting the center line for the required object. So now before proceeding off with the whole drawing, let us also draw the inner segment, because we have a inner referencing to the inner cutaway section. So towards this, let us try and offset this object. But if you offset the object to mimic the inner surface, what you can see is this entire rectangle will get offsetted inside. So let us first explode this component into individual sectors. So if you select this object and click on enter, now this object is broken into a constituent lines. So now let us go with the offset command, and this offset distance to be 9.4 mm, and the object to be offsetted is this. Okay, the distance need to be mentioned, distance object, and the point on which side is going to get offset. So this is the offset for the innermost left hand side surface. So now let us try and offset for the other line. So we'll reference this object to be offsetted. But as it's a center line, we are not able to do it. So let us construct one more line here along the center. This is a pseudo reference line, and then invoke the move command for this object with this base point, and then on the distance is going to be 8 mm. So now we have constituted something like this. So now we will use the extend command and select these two objects of interest, and then extend this, as well as using shift command we trim out this. Okay, the center line is also been selected, so we will select only these two components, and then shift select for trimming this. So now we have obtained this innermost part of the circle. So the next point is the curvilinear element that we have. So that is a combination of two circles, one a smaller one and the larger one. So the smallermost circle is of radius 4 mm, whereas it's located at a distance of 33 mm from the rightmost part of the plate, but that lies on the same axis. So let us again use the same circle command, and then specify the base point as from here as an extension. So on the x-axis we are going across minus 33 and no displacement y. Circle. Okay, so at a minus 33 mm of length, so we will be specifying the radius as 4 mm. So this is the first circle. Next is the second circle that again has the same reference point but with a 20 mm radius. So we will construct the circle again with this geometric center and with a radius of 20 mm. So this is the object that we have got. So now you can see that this circle is going to intersect this object onto the next surface. So let us for a while now create the mirror option, but before that let us truncate this line, intersecting line, or okay, let us proceed with this mirror. Select this circle and then mirror across this point. So now this is the point of intersection. So next again we have to have a intersecting line at this point. So we'll again draw offset a line from this point, just drawing a pseudo line and then moving it from this point to a length of 6 mm. So there you go, we have got the different dimensions that we want. So again, for this object to get intersected, rather the circle is off at this point, so we need to mirror this circle also. Or rather we'll select these two components together and also this. Along this point to complete the drawing that is required. So now we can prune off the lines that are not required for it. So towards that, let us zoom back to the extents to have a clearer view. So now use the trim command, and the object that's need to be trimmed are all this along with the circle. So this is not required, but nevertheless let it be there. Okay, so now after selecting the objects, now the object does need to be trimmed. Let us use the fence command and see that this is going to go and these lines are going to go. Next we have these lines. So similarly we have all these lines here. Okay, so we have eliminated this also, but no problem, we can replicate it. So now we can use the fence command again to remove this line as well as these. Now we are using the individual segments of the trim command to remove the non-essential parts. So now these are independent elements that are not required. We can remove them too. And in case this doesn't work out, so no issues. So we can still remove them off and then replicate the object that we have got here again. So it's a combination. So depending on your work style, you can do it in whatever order you want. You can also practice by this and then have an efficient way of replicating this and achieving them in a faster result. So this is the, so now we have got the innermost section. We can also trim off this. Right, so we have got this inner line. So now let us draw the next part. So here next referencing is positioning the cut surface in this part. So towards that, the referencing is with respect to the holes. So now let's draw the holes that are required. So the circle is going to be get positioned from this reference point from here. So from this base point on the x-axis is going to get displaced by 5.6 mm, and in the y-axis is going to be displaced by 15 mm. So with this, the radius is 5 mm. So this is the object that we have. Sorry, the radius is going to be 3 mm. So let us draw the holes again. So from this base point, the whole of 3. So now let us do a rectangle array to replicate the array rectangle to replicate this object. So the number of columns is 2 and the number of rows is again 2, and the distance between them is going to be 35 mm. And the y-axis distance is going to be 30 mm. So now using this we have got the holes that are positioned. So the next part is now to the rightmost chamfering that needs to be done. So here let us start off with 2 lines. So the first reference point is through this, an extension of this. So let me turn on the ortho mode on. So an intersection of this, turning off ortho. So the line, let us say an arbitrary line distance of say 50 mm with an angle of 15 degrees. So this is the first line that we have drawn. So now let's trim off this line with an offset line from this reference. So from this drawing what we can see is this length is 5.6 mm, and then we have the distance of 35 mm here, and if you subtract the overall length and again with this 16 mm and from the overall 63 mm, you can say the offset distance is, this distance is going to be 6.4 mm. So let us offset by a 6.4 mm distance of this object onto this point. So alternatively you can achieve this by using a trigonometric calculation to arrive at this length, so that you can directly specify the hypotenuse during your length definition. But right now we are just exploring the easiest way of doing it. So the next line again is going to be referred from this intersection point, and then again include an angle between the line to be drawn and this surface is going to be 135. So for a total distance of 180 degrees, so it's going to be 45 degrees with reference to the remaining angle. So this again you can set an arbitrary length of say 15 mm. Okay, let me do it again. With a relating reference of 15 mm with an angle of 45 degrees. So now we have got those surface. Now we can use trim command to select all the objects of reference, and now let's use the fence command to remove all those that are not required. So these have been removed, and this is just a reference line, so we'll take off this. And similarly, okay, before mirroring the features, one thing that is left is again the filleting of this edge and this edge. We have a command called fillet, but let us not use that right now. We'll use the circle command again. So this is again to be referenced from this point. So radius is going to be 5.6. So we can either do it this way, or we can draw the circle tangent to these two lines. So we have the option to do both. So now let us use the tangent circle option for this area. So now because we don't have a center point reference for this circle, so here we'll use the circle and tangent radius option. So the first tangent object is this, and the second tangent option is this, and the radius is 2.5 mm. So based on this, this object is also get positioned. So now we can use the trim command. So we are going to use the trim command for this as well as this object, and now the trimming surface is going to be this, and then again this. So alternatively this surface will go up and this surface will go up. So now we have attained the fillet options. So now we can replicate these objects, these lines onto the other surface. So let us select the object first. So these are the features that we are going to mirror across the line. So you can always toggle between the ortho mode off and on using the F8 button so that your axis is all maintained same. So now again you can use the trim command to now let us select this all because these all surface are going to interact. So now the fence option to remove this surface, then this surface and also this one. So there we go. So now we have completed the required latch plate diagram using a combination of the trim command as well as the offset command. So we'll summarize this week's learning. So what we are seeing was the different editing commands that were available to us with the text properties. That is, we looked into the single line text. Next we dwelled upon into the multi-line text. Then also we looked into the various properties that were available to us. That is the style command, and then we looked into the color command and applying those commands to the object and seeing how it varies. And also we looked into the line type that can be used, and in order to edit the objects we looked into additional command for selecting or filtering the objects that are of interest using the quick select, and also to edit the properties of individual objects using the quick properties command. So next what we did was we looked into several editing techniques that will help us to quicken the drawing time. That is, we looked into scale command, extend, join, trim, rotate, lengthen and stretch. So what we saw was this stretch and lengthen is kind of similar, and also it goes along with these to compensate, but we also saw in the powerful tools of trim and extend wherein they compensate each other, and when invoked the extend command can also be used trim command when holding down the shift button. Likewise, when employing the trim option we can also make use of the extend command in a single tool. So those are two powerful tools that we looked into, and also we employ these tools into our sample drawing that we looked into, and parallelly we also looked into the scale and the join command to see how it impacts the objects. So with this we'll conclude week 4 of the AutoCAD session. Welcome all to the week 5 of the AutoCAD session on manufacturability. So in this session we'll critically focus on different design for manufacturing techniques that will help us to perform good designs. So we'll look into the AutoCAD tools that will help us to do that, and also as you design your objects or design the key features, you have to keep a track on the important features specifications. So we look into several inquiry tools that will help us to investigate into those features and to keep a track of whether we are following the correct route or not. So just a quick recap of what we had looked into the previous sessions. So the last week we looked into several emend or editing techniques that will help us to navigate around the different objects and different features. So this week we'll look into the following topics. So we'll look into the key drafting topics that focuses on manufacturability. That is, the first is the hatching. So this hatch will give us information about the internal cross section of any mechanical component, or in case of a civil component it either looks for the RCC structure or roof or basement and so on. So this is the hatch element, following which we'll look into polyline commands, so that will help us to draw a line segment or a curvilinear segments together continuing, and we look into different options that will help us to draw those polyline segments effectively. Next we'll look into various commands that will help us to edit those polyline objects. Then we look into key critical manufacturing techniques, that is filleting and chamfer. We'll look into which is what and why it is required. And next we'll also look into what are the different techniques through which we can edit the object using a technique called as a grip edit command. So next we'll look into several inquiry techniques that AutoCAD offers us. We'll look into what an ID means in and what the features come out in the list command. And next we'll look into the distance command, wherein we can take in the length between 2 points. Next we'll also make use of an integrated command called as a measure job that will help us to look into features like the distance, the radius, the area, and in area again we'll look into how we can add or subtract two areas, and then finally we'll look into how the inquiry command will help us for a quick measure of almost all the features that are available with the system. So hatches are shaded patterns which generally represent a cross section of a mechanical component or any civil representation, for example like a roof or an RCC element or so. So towards that, hatch representation is very useful. So this is one of the information that gives in details to the drawing. So let's look into this right now. So hatch can be invoked by clicking on the command H here. So once you type in, you can get the hatch command. So before that, let us draw a cross section wherein we want to place our hatch section. So suppose you consider the side view of a rectangular block having a through hole within it. So how you'll do it is, suppose we have this rectangular block as say here, and next the cross section is going to be in between. So let us try and draw the center line for this rectangular block, right? So here let us draw the objects assuming that to be a 5mm hole. So we'll just specify a random hole, okay? So this is going to be my hole element. So let us just change this line property, consider it to be a hidden line. So let's recollect the line style that we had done last week. So in line type, let us add one more line for a hidden line. So we'll invoke this, and hence let us change this property using the properties toolbar. So changing the line type to be hidden, right? So what we are essentially looking now is the cross section of this. So we'll use the mirror command to replicate this object here along this line. So now we have drawn the cross section of this, and in order to demonstrate that this is going to be a cross section of this plate, then we have to fill in the hatch in these two segments, right? So let us invoke the hatch command now. So once you click on this command, we require to give in the area that is going to be hatched. So towards that, we get an interactive panel here in the ribbon area where we have multiple elements. But before that, as usual, let us look into the variants that has already been inbuilt using the dynamic input command. So right now you can see that when we pick down the down arrow, the default requirement is to select the object or an internal point for selecting the hatch area. Alternatively, we can also revert back the selection of the object using this undo command. And finally, we have this setting option. So let us invoke the settings to understand what are the different options that we have in hand. So once you invoke the hatch settings, you can see the settings open up. It's common for both hatch and a gradient. So the concept is the same. You are filling in the internal section using a representation. So hatch means you use one of different layers that representation that you have in a uniform format, whereas in gradient you fill in the color and then you try to vary the intensity depending on the patterns that you choose. So you can consider this hatching is going to be either a black and white and then uniformly spaced representation of the design type, whereas in gradient you use colors to denote a cross section or a component. So in this hatch and gradient, what you can see is the left pane alone changes, whereas the center pane remains same. We have an option in the right side that is also common for both the hatch and the gradient. So you have one more option here. Sometimes if you invoke the first time, you won't be getting the island properties menu, so that you can invoke by clicking on this button here. So let us look into the unique parameters for hatch and gradient initially. So once you click on the hatch tools, you have the type and pattern that can be selected from. Inside the type drop down, you have three variants. That is, you have the selection to choose from the predefined or user defined or a custom type. So predefined are something that are already coded into your tools, that are preset and commonly referenced across. Whereas in user defined, you can create your own pattern, the line type that you want to define, and then store it across. And a custom pattern is something that you use any one of the predefined file format and then modify it according to your use, and then you can save it as a custom file form. So next, what you have is the pattern that is going to be selected. So based on the type that you have selected, the pattern is going to vary. So right now it is in the predefined format, and when you select the pattern, when you select the down arrow, so the first 6 patterns that are going to be listed are the most used pattern, the predefined patterns. So based on that, you can select whatever you want. Suppose if you want to have a preview of how this pattern going to look into, then you can click in this 3 dotted symbol that opens the hatch pattern palette dialog box. So wherein you have the variants that are called for. So first variant is your ANSI format. In ANSI format, you have different nomenclatures, and you can have a view like how it's going to be used for different materials. You can have a lookup into each of these variants and to see which variant is applicable for what. And next you have the ISO codes and then other predefined file formats that are available, and also you can create your own custom tool set that you want to do. So now let's go back to this, and then the next command, that is you select the color within which the hatch needs to be defined. So the initial selection is by default selecting to the layer application, wherein you can also vary the color that you want to do by using the color option here, and that also is taken as a preview in this swatch command, wherein it selects a combination of both the pattern as well as the color. So suppose if we go for a ISO pattern, say this pattern with the color of green, then you can see how it looks with both these combos. So this is the swatch for a preview. And then suppose if you select a custom pattern, then you can make use of any combination that you can select. So this, let us look into the later stage. And in case of predefined, you can see the next variation where you can optimize the command, that is for a given predefined pattern. So let us just look a simple cross hatch, this ANSI 31 pattern with black stripes. With this, in this next panel, we can specify what is the angle of distribution of the patch and what is the scale of the pattern. So the angle denotes the hatch pattern angle relative to the x-axis in the current view that you have. So this is the default pattern, and that reference to a 0. So it's kind of a relative reference. So once you change the angle, suppose if it's already an angle, then the angle that we specify gets on a relative to this. So next we have a scale option, wherein we can expand or contract the predefined or the custom pattern. So this option is going to get highlighted, that is the angle of scale, only if we select a predefined or a custom format. Whereas if we go for a user defined, the scale is not going to get highlighted. Wherein you have the other variants that will get enabled, that is usage of the double. That is, in case of user defined patterns, this double will enable us to draw a second set of lines that would be positioned at 90 degrees to the original set. So that is, you create a replica of it that is already rotated to 90 degrees to the original set. So thereby we'll be able to generate a cross hatch pattern. So the key part is that this double will always be enabled only if you select the user defined pattern. It's not available in the preset pattern. So suppose if you want to select a cross hatch, then you have to select similar patterns that already defined as in the predefined setup. So next what we have is the relative to paper space command. So this is this option typically will get available only in the layout menu. So this is used to scale the hatch pattern relative to the paper space units that they are specified in the layout. So with this, the display of the hatch pattern can be controlled at a scale that is applicable to the layout that we have selected. So typically right now, as we are not at the layout view, it's not selected. And then when we move on to the user defined pattern, you can also see the spacing command getting highlighted up. So this denotes the spacing of the lines that is going to be defined in the user pattern. So by this you can control how the elements are spaced between each other. And next we have an ISO pen width. So if we select any one predefined pattern that is of the ISO standard, then you can get this command highlighted, that is ISO pen width. So wherein we can control the width of the pattern. So this denotes the width of the line that goes into the pattern. So next, the subsection denotes the origin of the hatch, that is from where the hatch has to be started or originated. So whatever we do it gets selected in the system variable called as a HP origin mode. That is by default it will go for a 0, 0, that is it sets to the global origin in the current view, wherein we can also specify a given origin. So by default it will get to selected to this option, and when we select a new origin point, then it can select accordingly. So the next option what we have is specifying the boundary extents, the rectangular extents of within which the hatch object should be included. So with this option we can select the 5 different combos that we have. That is, with respect to the bottom we have 2 options, and to the top we have 2 options, and then or rather setting the boundary extents to a center. So by this we can select or include the boundaries extent that can be applicated to the hatch. So next option is again to store the selected variant as the default origin. So this is the origin command that we can use of. So next, going into the gradient variant, the unique set of parameters available to it is to select either it's going to be a single colored variant or 2 colored. So in single colored option, you have the base color selected within the several options, wherein the rest of the color will be in the black color. Whereas if you select the 2 color option, you can set a primary and a secondary color object, and based on this selection you can select gradient style that is going to be applied based on the templates that are available here. So next you have the orientation of it, like how the gradient is going to be focused and then distributed. So now when this centered option is selected, then the gradient it evolves from the center and towards the direction that is specified. But if we unselect it, now it gets aligned to a corner or to a specific face, and then from that you can also select like how the position of the gradient is going to be revolved around the subject view. So suppose if the angle is of 345, you can see this blue patch is on the top left, whereas if it's going to be 0, it's on the left side. So it basically goes from 0 to 365 to specify the center or the location of your gradient hatch. So this pertains to your gradient tab. So now let us go and look into common options that are available for both the hatch and the gradient. So now what we have done is we have specified what is the type of hatch that we need to do and what are the colors that are going to go into it, and what are the angle and scale settings so that it will have a good representation. And also this origins point will help us to manipulate the hatch in a later stage, so you can either go with the default or modify it based on our requirement. So once we have selected this, so how to apply this onto your drawing? So that is where these key points come into. That is, you need to specify the boundary within which hatch needs to be placed. So we have two ways of doing it. You either pick a point, this point refers to an internal point. So you pick a point within which AutoCAD identifies what are the boundaries and will apply the selected hatch to it. Whereas in the next part, where we can select the object rather than it, that means we are selecting the boundary within which the hatch needs to be located. So we can do this in two ways. So once we have inserted the hatch pattern into it, that is, we have defined the boundaries of within which the hatch needs to be plotted. Next, we have an option to either to remove the boundary from the selection, or suppose if the original hatch has been moved to a different location or modified its boundaries, then we can use this option to recreate the boundary of an already created hatch. So we'll look into different methods one by one in the representation. So in the next command, what we have is in the options selection to either make it annotative or not. So what we have seen earlier even in text is that making it annotative means that the referencing is going to held in, and so whatever we do, the changes can be cross applied when we map it to an annotative system. Next, we have an associative thing. That means that hatch or the fill can be updated when the boundaries are modified. That means we are sticking the hatch pattern to the boundaries. That is, we are linking both together so that whenever there is a change in the boundary, the hatch pattern gets updated accordingly. So next, what we have is an option to select a separate hatches. So when this gets selected, it will enable to whether the single or the multiple hatch object will be created when separate closed boundaries are specified. So it means that we can either create a uniform hatch or an independent hatches based on multiple selection that we have. So next, order of selection of the boundaries within which the draw order can be selected. So once we select the boundary, it will look into how to fill the hatch based on this object. So whether it should be sent to the back or the front, or how it should be positioned within the boundary. So typically by default what we have is the hatch should be sent behind the boundary. So this will play a major role if you are trying to separate between different layers, but predominantly when you operate on a 2D space, that might not be directly useful for you. So next, what we have is specifying or attaching this to the which layer that needs to be associated. And also we can control the transparency of the layer, and this again goes by the command of the layer. So these denotes to the layer properties that we have. So next, what we have is the inherit properties option. So this is used to select the hatch or the fill command within the specific boundaries to take in all the properties that we have with the original hatch setting. So this command actually controls the system command called as an HP inherit. So this will control whether the hatch origin of the resultant hatch, that is the newly created hatch, is determined based on the earlier setting that we have spoken about, that is the HP origin setting, or within the by the source object. So by selecting the hatch object from which the properties we want to inherit, we can right click on the drawing area and use these properties to switch between and select object and selecting the internal pick points to create the boundaries. So this is the usage of inherit properties option. So this is a common area between the hatch and a gradient. And then in the expanded menu, we still have something called as an island. So island means that when we select the boundary, see, this is the external boundary within which there are two objects included. So how the hatch algorithm should consider and which part to include and which not. So this island detection will help us to do that. So based on that, when we click on the boundaries, it can select the hatch that needs to be inserted. So this we'll look into a practical example. So next what we have is the retention of the boundaries. That is, when we create a new hatch, should those boundaries be defined, retained as a separate object or to be associated with the same hatch or not. So next we have the boundary set command, wherein to which it needs to be linked to, whether it's in the current viewport or to create a separate boundary set parameters. Next we have the gap tolerance. So it means that when we use a hatch boundary, what is the area within which it should be there. So if we specify the default value of 0, then it means that the objects must enclose the area without any gaps. But if we give a positive value to it, so based on that, any gaps that are found can be ignored and the plot will get elected. It means that suppose if the object is not fully closed, then by default if you are specifying a 0 tolerance, it cannot plot, it will throw an error. We'll look into it separately. And next, again, as in inherit properties, we also have an inherit options to select whether to use the current origin or to use the source hatch origin. So this in detail covers what are the options, different options we have. So now let us look into one by one. So in this setting command, we'll look into first selecting the pick points. But before, let us look for a cross hatch pattern. So we'll go into the interactive part and then maybe select this and see 131. And we are using the default parameters for angle of 0 and a scale of 1. So now we are using the first point to select the internal point of the object within which we need to specify the hatch. So now our hatch to be located within this and this. As you could see, once you hover over the area, the algorithm identifies that it's going to be an internal pattern, and hence it assigns the boundaries of so and so, and it will try to project the intended view. So once you click on it, now the hatch has been applicated. And also even though you click on it, the command continues similar to your line command. That is, it will go on to the next object or requirement within which we need to specify the hatch. So if you want to go back to the settings command, then you can type in you can select the down arrow to again invoke the dynamic inputs for this hatch command, because you are still in the hatch command. So now you have an option to either select the objects or pick an internal point. So with the settings object, we had actually picked an internal point. Now let us select the object. So for selection object, if you hover it around here, you can see this was a rectangular object. So now trying difficult to pick out which area it's required. So this is why, based on the requirement or based on the source object that you have to cycle between selecting the object or selecting the internal boundaries that you have. So let us go ahead and then select with the internal point so that we can position the hatch. So once you click on it and click on enter, it will come out of the hatch command and your ribbon also goes away. So if you want to edit it, what you can do is you can either type in select the hatch and then type in hatch edit command, or invoking hatch edit also opens your settings dialog box, as well as it will also invoke the panel. Or alternatively, you can double click onto the hatch pattern to invoke the hatch editor tool menu. So once you do this, now you can select modify the commands that you have. So let us go back into the settings menu. So we'll go to hatch edit. And now let us look into the next option that we have. So here what we have is the scale option. So now first let us try and change the angle and the scale together. So if you could recollect, this angle is going to be referencing from the x-axis. So suppose if we are rotating this by 45 degrees and click on enter, now you can see the hatch gets updated, and with the original angle itself is 45 degree with the x-axis, that is the default pattern. So now turning it by 45 degrees again, it's going to change the pattern view. So let us invoke hatch edit again with this object selected. Now let us revert back to 0 degree, but rather now we will try and change the scale. This is going to be similar to your scale command that you use here. So we'll give a higher magnitude and see how it goes. So now you can see when the scale is increased, it is zooming into the object, that is the hatch pattern get enlarged. Whereas if you give a scale value that is lesser than 1, then it's going to go in a reduced mode. So now you can see the processing and then locating again seems to be difficult. So that's why you need to specify the hatch that is both readable and editable. So suppose if you are operating on a zoom extent of this size and your object is going to be in here, then when the representation is not okay, that is not able to understand like why it is being filled by a solid color, but rather it's a hatch. So supposing if you are viewing in this zoom extent, then our hatch edit scale should be of a higher proportion. So this is how you vary your scale and your angle of rotation. So now next stage, if you could see, when you select on the object, as we had invoked this hatch object together, that is both the internal surface together, you can see these two are referred to a single hatch object. So when we you can also see a pointer that is highlighting here. So this will control the dynamic addition of your hatch. So let us try and move this object to see how it affects. So let us select this object with the left mouse button, click and drag to elsewhere. Suppose let us say, let us position it outside here. So now once you move it outside, you can see that this single selection point now has split into two different areas. Let me select this object again. So now what you can see is, you remember this was an associative type hatch, and also we had enabled the boundaries that were selected. So now typically let me just go back to the hatch edit to have a view. So here right now we have the option to display the boundary of this. So now when we click on that display boundary, now you can see the boundaries of the respective hatch. We can use this dynamic to edit to modify the hatch boundary. So now assuming, let us click and drag this, that is we are reaching essentially the stretch command that applies to this object. So once we position on to this, as the object was already in an associative manner, so whenever the boundary gets changed, your hatch also gets extended to it. But right now this hatch is not associated to any object, so that's why you can see the current associated object is not highlighted. So it means this hatch is independent and is not associated to any object, but rather it is just enclosed by the object. So suppose if you want to recreate the hatch based on the boundary, so now you can click on this recreate option. So once you click on the recreate option, it will try to ask like what type of boundary that should be selected. It should either be a polyline type of boundary object or a region type of boundary object. So when you select the polyline type of object, and then the next requirement is a yes or no boolean type of requirement, whether the hatch should be associated with the new boundary. That is, we are redefining the boundaries as well as the hatch object. So once we do this, we are selecting the command as yes, y, and then selecting it. Now the associative and other commands get alerted because now the hatch is recreated with an object boundary. So now if you select outside and then click on the properties, you can see there we have a hatch, and then also we have a polyline object, because this polyline object is what we created using the recreate object. So this is the looking into how the hatch edit properties of associative and modifying the boundaries will affect. So next what we have is, suppose if we want to remove the boundaries of a given hatch, then you can click on this remove boundaries object and select which object the boundary has to be removed. So towards this, you can't select the hatch, but rather you have to select the boundary. So suppose if you're selecting this boundary, now the associated hatch is removed. That is, we right now have only the hatch and the boundary that has defined was removed. So it means that the hatch right now is without a boundary but still enclosed within the object. So now let's look into the next topic, that is the island detection. That is how AutoCAD can identify two different objects that are included within a larger boundary and decide upon which object or the boundary to be selected and how the hash should be applied. So towards that, let us draw a simple shape. So let us try and draw a polygon with 6 sides with this center and then circumscribed about a circle, assuming the radius to be 45, right? So, and then we'll try and position a circle of approximate dimensions like this, and then again position it outside within a rectangular boundary. Consider something like this. So now let us invoke the hatch option, and so now we'll go into the settings to look into this island detection option. So now this is in the enable condition, that is AutoCAD will try to identify separate object zones within the given object. So now if you could see, right now it's in the normal island detection methodology. So now let's see how it does. So when we pick the points, the first internal point, if we pick in this, and next, as you could see, once it is selected, the island is detected that there is a separate object enclosing within a secondary layer. So by that, the polygon has been identified as an island and the same hatch pattern has been applied. So this is your property of setting the island to be a normal detection. Suppose if we select this outer, then only this has been applied. You can see dynamically the selection is getting updated. Whereas if we select the ignore option, then it ignores the complete object and then run the hatch throughout. So this is the key differences between the 3 island options that we have. Suppose if we did remove this, then the software does not look for any island detection and only those internal boundaries specifying to the requirement will be selected. So this is the island detection option that goes into. So just quickly summarizing the different options that we had made is, we had looked into the type and pattern of the hatch and then also looked into the angle and scale of it. So based on the requirement, we can first go in and then also we can edit as per the modification, and then the origin requirement is there. Suppose if you want to move the origin or you're working around a non-linear boundary, then if you want to specify the separate origin point, then you can make use of these to position it. But rather if you have a well-defined object boundary, then this might not be an applicable option for you. That is, it will identify the object boundaries and set in hatch directly. Next, you have the option to select from how you are going to define the boundaries, whether you are going to pick an internal point or select the object directly, and then once you have applicated it, whether you have to remove the boundaries, that is, you remove the boundaries as a separating object, that is, consider only the hatch alone. So in that case you can do it. And suppose if the hatch boundary has been modified, that is, the object has been taken away, then you can recreate the boundary to create a separate object files enclosing the hatch. Next, we can also view like what is the selected object, current object wherein the hatch command has been done. So this is your view selections option. Next, we have different options to select how the hatch needs to be propertized. So that is, first, to make it annotative, that is, the annotative properties get applied to this hash. So whatever global level annotation update you can make can be applied to here. And next you have an associative property, that is the hatch associating with the object boundary. Next, the option to create separate hatches if you have complicated object. Next, again, where the hatch should be positioned, and again with respect to the layers. So then we had looked into the different island options. So these are the key areas that is typically looked at. So we'll see a unique case where if the object is not a closed one but rather a open one. So in order to demonstrate, let us look into a open-ended object. So let us consider a line that approximately of length 190 mm through, or typically a square. But consider the third edge is short of completion, that is, it's an open-ended object, it's not an enclosed one. So in that case, if you try and invoke the hatch option and try and pick the internal point, you will get a AutoCAD warning message saying that a closed boundary cannot be detected. So what it says that there might be some internal gaps within the object, or the selected area, the boundary object must be outside the display area. It is highlighted by using a two red circles, and if you want to remove it, we have to rectify it and then use the redraw or region command. You can also see it AutoCAD suggests certain options to remove this. That is one thing, to zoom to the maximum limit onto that and check whether it's actually closed or not, and then choose a specific boundary that can help us. And suppose if the object is still open, then come out of the hatch command and then use the extend or the stretch commands to close the object, and then specify the object boundary. And then the third point is to check whether the plane of reference is the correct one and you have an enclosing object. Whereas the fourth one, if in case of open-ended objects, if the precision is not needed, then you can use the gap tolerance setting that we have. But there's a hack to it. Sometimes gap tolerance effect might not serve as intended, because if you want to change it, you can change in this option menu, wherein you can have a slider. The size varies from 0 to 5000. That's the maximum units of gap tolerance that can be specified. But consider that object to be a closed one and then try and impact. So in certain cases, even if we give a gap tolerance and then give it, it might not detect. So, but you can, instead of going for the gap tolerance, you can very well overcome the situation by using the object selection command. So even with no gap tolerance, you can still select the object, the boundary objects within which you can denote the closed area. So now you can see, based on the selection, the hatch is applied, and this is for how it varies. So this done with the hatch command. So we can also have a quick overview of the hatch toolbar, wherein if we want to edit this property, then we can use one of these drop down menus or the selection menus to change the properties without going into the hatch edit command. So here again we have the different options that we have: the hatch transparency, the angle of the hatch, and then again the pattern scale. Then also we can set and change the object origin. So this will, changing an object origin will change the hatch reference. Suppose if we select a random point like this, say this, okay, suppose if the origin point is set to be this, and hence the hatch will get allotted accordingly. That is, if considering that start point to be here and the it has to be distributed, this edge should not fall closer to the hatch point, then you can modify this. So this is how your set origin command is going to function. So then also we have this matched origin, so that if you click in the source origin and select the object of source, then you can one second, the source for this, then you can match the property accordingly. So this is one option that we didn't explore earlier. So this concludes the hatching of the objects command. So now let's look into the pline command. We had dwelt upon this area in the initial weeks, but let us look in more detail now. So let me just select everything and then remove them. Okay, so now you can invoke the pline, that is the polyline command, by typing in pl. So it start off just like the line command. It asks for the start point. Okay, so for quicker understanding, let me also bring in the command prompt to see what are the different option variants. See, the first requirement is the specification of the start point. So once that is done, you can see the next options that are plotted. That is, by default, it will start plotting a line command. So it expects the next closing point. Whereas you can also see the additional options that you have. That is, you can use the option of arc to specify or to continue the next point as a curvilinear element rather than a linear element. Then you have the specification to specify the half width. That half width denotes the width of the next line segment. So that we can edit. That is, we can create a thick line. So that we will see how it option. And next we can also specify the next line segment using the length option. So by specifying the length, a new line segment is drawn using the length at the same angle as the previous segment that we have created. So suppose if the previous segment was an arc, then the new line segment will be drawn a tangent to that arc segment based on the length of the previous arc. So that is your length command. Then we have the undo command to do away with the changes that we done with the most recent line segment added to the polyline. Whereas we also have the width command that will denote the width. So it's a combination of your width as well as the half width. So width denotes the top to the bottom width of your line, whereas half width denotes only the half of the segment. So you can use in tandem within what you require. And also a key point to be noted in the polyline is that this polyline once created can be edited and convert into a spline, that is a smooth spline if required. So that will help us to draw a contour profile kind of thing that will be useful in your advanced drawings. So with key characteristics of this spline to be taken note is that they can also be drawn with dot dash or complex line types commands. That is, you can edit with the line property. Next, as we had looked into the detail, that is, the line width can be made uniform or non-uniform segments. So considering that you have drawn an initial segment with a higher width, and then later you can taper the width as required, that is, you have a non-uniform width to the subsequent length. So then the sequence of lines and arcs that you are using can also use to form a closed polygon or an ellipse. So that also can be done. That is, you are converting this polyline to the subsequent models that you can generate out of the basic line and arc commands. So next, these 2D polylines can be edited to be either inserted or move or deleted the vertices, so that it can be joined to several lines or broken down into its separate constituents. So next we can also apply the fillet and chamfer commands to these, and also as discussed earlier, we can turn this as a spline and then also use curve fitting option to use in a 2D polyline. So that option we'll look into the later stages. Next, for this 2D polyline, we can also make use of this calculate area and perimeter command, so that because it is going to be treated as a single object. So that we'll look into the measure option in the later session today. But these are the higher advantages of the polyline command that we can opt for. So just going by, so if the next point length is going to be 150, now what we have made use is that we are extending the line command. That is, the first segment of this P line has been a line. Suppose let's close with the next command of say arc. So then you can make use of all the arc commands that we had looked earlier. So that is, we can either specify the angle based or center based or the direction based. So based on these, we can extend the arc parameters. So Suppose if you want to define the center and then proceed, then you can type in or select the center option and then specify the center point, following which now it will refer to the original R command of center. So the next requirement for that command is going to be your endpoint, and also you can specify the angle and length as an option. So we won't be dwelling into those in much detail, but this is just to give you an idea like how you can combine line and circle together to create polyline segments. So as you can see, this typically constitutes like your spline object. So this is how you build upon it. Suppose if you want to revert back to the line command, then you can click on the L or the line option. So once it's done, then it will go back to the previous one. So now let's look into the length command. So suppose if you are exploring this length, now the length requirement is asked for. Suppose if we are keeping a length of say 200, so now this length of 200 units is drawn with tangent to this arc element. So now let me zoom to the extents, and now let us continue one more line here. But before proceeding, let us try and change the width of this line. So by invoking the W command, so once it starts, now it prompts for the width of the line. Suppose if we want to have a line width to be of say 2 units, and it asks for the specifying the end width, that is it asks for a start width and an end width. So keeping in constant, it will plot a thicker line, whereas if suppose if we want to have a tapered object that we were speaking about earlier, then we can again still invoke the width command. So suppose the starting line to be of say 5, or to have a better clearer picture, let us say the width to be of 25, whereas the closing the width to be of 1. So now the next endpoint is required for. So let us say it's going to be of a length of say 200 units, and then now let us zoom back. Now you can see you have got a tapered element. So now also instead of the width, you can specify the half width option using H. It again asks for the start and the end point of this the line segment, but rather than the entire width, it refers from the midpoint of the segment. So we can try and create the same thing by using the start width as 12.5 rather as earlier, because earlier we have specified 25. But as you could see, the software considers the previous closing width as the start of this current width. The previous closing width was 1 unit, and hence it carries over the same command and then computes the half of it and returns 0.5. So this is how it's going to work. So now specifying 12.5 to ensure a total width of 25, and then closing width again saying as 0.5 with a length of 50 units. Then see it still starts with the middle and then go about. So it's a uniform object, that is it's a symmetrical object. So using this half width command again, we can try and get the same use as the width option. Now also we have one more command of this P line, is that instead of closing the edge manually, we can use this C option, that is close option, to close the object automatically. So now it gets referred to the first start point of your object. So now this object together, even though it has multiple shapes, so let me just turn it off the command line. Now select the object. Now you can see this entire object is selected and is treated as a single object. So if you right click and go into the properties, you can see that it has been constituted as a polyline. So this sums up your P-line requirements. So now let's look into the polyline edit option, that is P-edit option. So that will help us to modify the polylines that we have drawn. So this P-edit directly opts for different options that are required for editing. That is to either open up the polyline or subsequently close based on the requirement. Next, to join the polyline segments, or specify or modify the width and edit the vertex points or fit it to a requirement. So next, also to modify this as a spline, and then using a decurve option to restore the polyline to its original state as it was originally drawn. Next, the line type generation to generate a line type in a continuous pattern based on the vertices of polyline, and using the reverse option as well as the undo. So we'll look into one by one now. So first we'll explore what is this, why this p edit command is used. So this, as we said, is predominantly used to modify the polylines that we have drawn. So we can edit it using the p edit, or also using the properties palette or grips, that is editing with grips. We can also that means that if you double select the object, and then this is what you call it as grips. That is, based on selection of the scripts, you can modify the object that you want. So then also the properties that we are speaking about, right click and then changing the properties, wherein we can specify the vertices and henceforth and so on. But this pedit command is a comprehensive package containing all the commands. So it is used to move the polyline, edit or delete the individual vertices, that is individual vertex points we can have control over. So next, we can apply an uniform width throughout the polyline segment, or as specified here, we can control individually to each and every polyline segment. So next, we can also create an approximation of a spline called as a spline fit polyline. Next, we can display non-continuous line types that we have seen earlier, that is with the dotted line or the hidden lines, so with and without a dash before and each of the vertex. Then also we can change the orientation of text of line type that is assigned to a polyline by reversing its direction. So these are the different modification properties that we can use through the pedit command. So first thing is, once you invoke the pedit property, you are required to select the polyline. So when selecting the polyline, you also have a dynamic input for multiple. So typically multiple will enable the selection for more than one object. So when we select this option, the edit vertex option will not be available. So suppose if you have to modify the vertex, then you have to go for a single polyline command. So suppose if we look into the multiple and select this object, you can see once the object is selected, you do not have the option to edit the vertex. It is not visible. So let me just repeat it again. So I'm just using a poly edit command and using the default selection for the polyline. So once the default polyline is selected, then we have this option for edit vertex. Whereas if you use the pedit command with multiple options selected, then we do not get the vertex edit command. So this is the major difference between a multiple polyline edit as well as the single object selection. So multiple will be used when you are doing the edit option for a group of objects, not for a single one. So now let us go back into the single polyline object and we'll select this object. So once done, we have an option. The first option is the open, that is, if the polyline is a closed one, the current one is a closed one, hence it will ask us have the option to open it up. So if you click on it, you can see that the last command that we used to close up the polyline had been undone so as to open the polyline. Next, we have got the command for close. So it means that you can close up an open polyline. So this is the first open or close option that is used to edit the polyline segment that is created last for either opening or closing the polyline segment. So next option what we have is a join command. So this join is used to join a line, an arc or any other polyline to a open polyline if their ends are connected or close to each other. So suppose if the ends are not coincident but within a distance, then we can set something called as a first distance. That is, the ends are joined by them trimming them, extending them or connecting them with a new segment. So in this join command, once you select join option, then it will ask for the line. So right now you can see that it doesn't operate, because first you have to make this polyline to be an open one. Second, let's see what is the variant of it. So towards that, let us just make this as open. So now we are selecting the single polyline and making it open. So this is done. So now let us consider that we have a single line segment that goes approximately here. So it is something like this. Okay, so in this case, now the objective is to join this line segment to this P line and vice versa, and then convert it to be a single object. So for it, in order to use the P edit command, if you select the single P line object and then go to join, and then it asks for the select objects command again. So when you click on both these points, you don't get any other input. Why? Because for this pedit command to work for join, you have to select the multiple objects command. So once you do, because originally what you want to do is you have to join two objects together. So even when executing the pedit command, you have to make sure that you have selected the objects of importance to us. So that's why you have to opt for multiple objects and then go about. So now you go on, select the two objects of interest and click in enter. So once it's done, the algorithm identifies that the first object is going to be is already a polyline, whereas the second intended object is not a polyline. So it asks for an option whether to convert it to polylines or not. So let us click on yes to convert it to a polyline. Now let us use this join option. So once you put on this join option, as we discussed earlier, there are two options, that is either to specify the first distance, or we can mention the type of join that we are going to use. So we have three types of join mechanisms. That is, the first one is the extend, that is it joins the selected polyline by extending or trimming the segments, whereas the second one, add, what it does is it joins the selected polylines by adding a straight segment between the nearest endpoints that are available. So the third option what we have is the both, that is it joins the selected polylines by extending or trimming if possible, or else it joins by adding a straight segment between the nearest point. That is, it will try and execute a combo of both the extend as well as the add mechanism to give out the end objective. So now let us, for instance, we'll try use the extend option first, and once extend option is done, what we can do is we can specify the approximate first distance. Consider, let's say, like 100 units. See, now it get extended because in the same line we can see this object here. So now let us just undo and see how the other command works in. So we'll go to the pedit object and select multiple commands again, and select these two by the cross fencing option. Now again the option to convert to polyline, yes, go to join, and now join type as add and say first distance of 50. So in that case, again, as they are coincident, they take and directly join the segment. So now let's consider a different point that does not coincide with this object. So that is, let us draw a line something like that. That is, it does not merge directly here. So let us see how the algorithm looks into this concept. So let's select these two lines for multiple. Select this object, convert it line, use the join command, and let us use the same command, but this time let us use both the options. Let's see how the object is merged. So for the same first distance of 50, you can say based on that it has added one more segment. So instead of extending, it constitutes the add command in order to close the polyline. So this is how your join command is going to work based on the different join types. So next, the option what we have is the with command. So now let's look into this. So with, once we've done it, So it asks for this line width for the entire command. So suppose if the line width is say like 2 mm, now all the line is get adopted as 2 mm as uniform one. Whereas if you want to go to the default one, 0 is the default width of the AutoCAD system. Next, have an option to fit a smooth curve that runs along the polyline vertices. So that is done by the fit command. So once it's done, the object that we had get converted to a smooth curve respective to the tangent direction of the available vertex points. So this curve is going to consist a pair of arcs, that is each and every segment is going to be arc segments joining the vertices together. So suppose if there are any special requirements, then the software also does introduces new vertex to solve it. So let us use the U command, that is undo, to come back to the original point. So right now what you can see is this was the object. So the curve was done by modifying these vertex into a curve. So we got an arc here, and an arc here. But in order to introduce this, it introduced one more vertex. So let us look into the fit command again. You can see it introduced one more vertex to make this point as a smooth curve. So this is the option of the fit command. So next what we have is a spline command. So this option uses the vertex of the selected polyline as the control points or the frame of the spline curve. So this will be used to open or closed based on the original polyline. So this curve will pass through the first and the last control point. That is, as is the open end, this curve will pass through the first and the last vertex point, and it does not imply that it has to pass through all other vertices. Only the start and the end points are relevant, wherein it gets pulled towards the other points without passing through them. So if we also specify more control points, then we can have a full effect on the curve. So let us look into it. When we click on spline, you can see that the object, the start and end point is remain same, but a smooth object is given. So in order to have a quick understanding, let us duplicate this curve using a copy command, and again we'll specify the same base point as here. Copy. Okay, so just for ease, let us keep it as 0.1, or the base point to be 0 and angle to be 0. So you can see we have created an object that will overlay on it. So with this command, now let us use the p-edit option to look into how the spline curve is going to operate on it. So now you can see the original point persisted. So what it does is the source point and the end point is maintained the same, whereas this spline will tend to be pulled towards the vertex point. These vertexes of the original curve tends to act as a control point, and thereby it will control this spline curve. So using this spline, actually we will be getting two type of splines, that is either a quadratic B-spline or cubic B-spline. So these curves will be different from what we are currently using, this fit curve. So there's a separate option called as a spline variable. So that will look in the subsequent curve. So once we use the spline curve, we also have an option called as a D curve, that is to revert the polyline to its original state. That is, instead of spline, it will go back to the original state of the polyline. So now you can see that we didn't have this information. This is the original line, whereas this was created after recurving. So this D curve removes all the curvilinear objects that are present here and gives us only a linear object. That means this curve element is removed and then replaced by a linear object. So this is what the D curve command does. So next command in the pedit is the line type generation. So this line type generation will act only on a continuous pattern type of line, that is not in the straight line. So we have to modify this onto a dashed line or a hidden type of line to understand this implication. So towards that, first let us remove the duplicate copy that we have. So right now we have only one element here. I have removed the other one. So now by selecting this and going to the properties, let's change the line type to be a center line type concept. So we'll zoom on to one of the vertex to see how the line type generation happens. So this is the basic type of line type that we have. So now when we go to the pedit command and using the line type generation, we'll be getting a boolean type of requirement, whether off or on. So by default, when it is in off state, this option generates the line type starting and ending with a dash at the vertex. So it means that we have a at each vertex, if you see, we have a dash here. So when we change the option to in on state, now each vertex will have the smaller line segment there. At this join point, you can start it from it's not a perfect longer line, but rather with the pattern that is running through the vertex as required. So this is the line type generation command. This is just a kind of a region command that will help you to optimize the view that you want to have. Suppose you does not want the end point to be like this, that is, it has to be ensure that it is of continuous segment. Then you use this to show the sharp vertexes that you have. So this is the major use of the line type generation command. So let's look into the next command, the reverse option. In between, I also would like to highlight the other way of selecting the pedit command. So that is, one way is you can right click on the line after selecting it. So you can select the recent input that you have given here, and alternatively, once based on the selected object, you also get the menu specific to the selected object. So here you have the edit polyline command and also other commands that are looked into it. So let us just go into the edit polyline. So now we have this reverse option command. So once you typically give the reverse command, you can see that you don't see any observe major difference to it. So why? Because to enable the reverse command, you need to enable certain system limits. That is, this P line reverse width. So this is the system variable that you have to turn it on to 1 to enable this. And again, to have a better view of it, it is useful when you apply it on a line or a P line that is not symmetrical, because right now this line is a symmetrical line, so you may not come to appreciate the variation of the reverse. So this reverse, actually what it does is, suppose if the line type is a text based line type, it can change this text orientation, or rather if this line type is of a different line width, then also it can change the orientation as since it is reversing the vertex order. Let us look into one by one. So first let us try and vary this line type into a text-based line type. So towards that, you can go to the line type objects and then try and load a line type that has a text in it. So suppose there is this line type that denotes a text-based line, that is, this indicates a gas line that is coming in. So let us load this one and try to apply to this layer here. So now you have got the text here. So let us also change the scale of it to have a better readability. Right. So we have this scale as 5 now. So now we can see that this is the start vertex for us and this is the end vertex, and this is how the text being positioned. So now let's click in it and then go to the edit polyline option and type in the reverse command. So this again you can see there is a little variation of this start and end point, but this would be more predominantly seen when this applies to a P line with a varying length. So let us create one P line and try and edit the width of it. So we have this width command wherein we'll let us go into the so let's create a new polyline command, and after specifying the start point, let us specify the width of selection. So let us specify the start width to be 1 and then the end width to be 5 to create a tapered line. So now you can see this taper effect here, and when you select this P line and then click on the edit option, the P edit line, and then now you click on the reverse, you can observe that the direction has been flipped in. So this is how your command for the reverse option will work. So next let's look into the edit vertex option. So for its understanding, let us go back to this linear line type. So with this, we'll see how we can make use of the edit vertex option. So after selecting this option, going to the edit polyline. So as it's a single object, you have this edit vertex command highlighted. So once you do that, you will get a submenu of different variants of this edit vertex option selected. So first you have the two buttons that will allow us to select which vertex point needs to be edited. So it is highlighted by the X mark here, and when you go about the next command, so then you can look into how it cycles between various vertex. So if you want to go back to the selection, the previous one, you have to use the previous vertex. So this is done by your next and previous to cycle across the points. Even if it's a closed polyline, if you keep on cycling to the next point, it does not go to the start of the next point. So this is the start point and an end point. Even though it's a closed circle, it won't come to this point. So we have to select it individually and then do the task that is required. So suppose let us position at this point. The next command break is similar to your break option. So that is, once you click on this, now this polyline will get divided into two separate polyline segments. So once you click on this, you also again have an option to fix in what point of operation do you want. We can cycle internally here also, or if you want to execute the command at this vertex, then you have to click in the go command. So once it's done, let us come out using the exit command and see how it has reflected. See, on that vertex, the object had divided into two different polylines. So this segment is also a polyline, whereas this is also a polyline, but that has been divided as two. So going back into the polyline command again, edit polyline for the edit vertex option. So now next what we have is the insert vertex command. That is, you can select a new vertex for insertion. Suppose if you select this vertex as insert, so now the first point is retained, whereas one more vertex has been constructed and through which the polyline has been adjusted to it. So based on the selection methodology, we can select new vertex and then AutoCAD will plot the P-line automatically. So next we have the move command. The move command, what it does is, based on the selection of the vertex, we can specify a different point of origin for it. So based on this, now you can see now the vertex has moved, and so the polyline has also updated and redrawn to the actual point. So next we have the region option. So it acts similar to our region command. The thing is, this option is most often used when we are using the width option, that is when you control the line width here. So based on this, you can specify or modify each width of the segment separately. The difference between the vertex width versus the overall width is that when you click on the width as here, you get the same command as in what you get for a individual polyline width command. Whereas if you edit the in the p-edit option, when you edit the width of the polyline, it is applied uniformly throughout all the segments of the polyline. Wherein with the edit vertex command width, you can specify separately. So now with this as starting vertex, now suppose if we give the starting vertex width as 1 and the subsequent next segment vertex is linked it, suppose if we keep it as 3, or to have a greater impact, let's keep it as 10. Now you can see this source vertex has been edited to a width of 1 and the end vertex, that is the next vertex point, has been updated with the distance of 10. Suppose if this command is not visible, if the changes are not visible, then we can use this regen command to regenerate the entire polyline. So next we have this straighten command. So as the name implies, the straighten command is used to straight a segment of a polyline. So the first requirement is that we need to move the X marker to the starting segment from where we want to start the straightening, and then have to select the straighten option. So first let us move the point to the next zone. So considering this arc segment we have to straighten, so now we have set the X mark to the starting segment of this. Next let's use the straighten command. So next we'll give the go line. So as you could see, the immediate next segment of the polyline has been straightened using this. So we can also use the command what we saw earlier, that is next and previous, within the straighten submenu to change the selection of the point. But anyway, this has to be positioned on the start of the polyline segment that needs to be straightened. So next what we have is the tangent option. So this option is used for the user to attach a tangent direction to the current vertex, so that it can be later used in a curve 15 methodology. So we'll look into it now. So this is, suppose if we give the tangent vertex direction to be in this way. Next we'll come back to the overall menu and then use a fit option to it. Now let us go to the edit vertex and specify the, okay, let us go to the edit vertex and go to this point. So as we had already mentioned a tangent here, so now this segment has been drawn along a tangent with this line based on the angle that we have specified. Suppose if we want to vary the tangent angle, so subsequently the fitted curve line has also been updated. So this is how we can control the fitted curve option to set a tangent to the specific direction that we require. So this concludes the edit vertex option of the pedit command. Now let's look into the next manufacturability command, that is fillet option. So before going it, let us erase all the selection here, and now let us try and draw a rectangular plate of some arbitrary dimension. So out in the field, that is if we want to manufacture a plate, then this plate has a safety risk that is associated with it. That is, these corners, these four corners are sharp edges, so that might inflict any damages or hurt the operators or the users, the end users. So in those cases, and also this is in a safety concern, and in a structural concern, these sharp edges possess the stress concentration points. That is, if this material is subject to stress, then the stress energy will get accumulated in this and it's prone to failures initially. So most of the designs that we manufacture, they have to avoid all sharp edges at all costs for these two causes, that is for preventing any safety concerns and also to improve the structural strength of the material. Those cases is where we use a fillet, that is the trim of the edges in a curvilinear manner, or if we want to trim off the edges in a linear manner, that's called as a chamfer. So chamfer we'll look into the next part. Right now with fillet we'll look into. So if you could recollect, in rectangle command we also had an option to specify the fillet of it, but rather if you have not used that and if you want to use it independently, then you can invoke fillet by the F command or fillet. So once you do that, the first requirement is to select the object. Also we have other menus, that is to undo the setting that we had made, or we can rather apply the fillet to a polyline and then specify the radius of fillet. Next to whether turn on or off the trim command, and then finally to apply this fillet to multiple objects. So these are the different options that are available with fillet, and let us just go ahead directly and then select an object to see how it reflects. So you can see once the requirement of this fillet is to specify the first object and then followed by a second object. Even though this is a singular object, when selecting the command using a fillet, you can see it is prompting for a first and second objects. But right now, even though applying this, you can see there is no variation of fillet. Why? Because once we invoke this command, you can see in the command line what is the default setting that is carried over. So the current setting is the mode of fillet is in trim mode, that is in trim on mode, whereas the radius of fillet is set to 0. So now let us go ahead and update the radius. Suppose we keep a radius of 5 mm, and now the first object of selection is required. So this is the first object and this is going to be second object. So once done, you can see that the fillet has appeared onto the edge of the application. So once applied, you can see that the fillet has been applied to the edge of this object. So this fillet will apply to the selected object only. So in order to apply this fillet command for all the edges, you have to go for the internal fillet command of the rectangle. But right now for this fillet, it all considers only 2 line of objects. So this is the first method of doing it. So the next method to select whether the trim option can be selected or not. So for that, let us draw a line to have it in more detail. So now let us invoke the fillet command again and specify the radius of say 20 units, and selecting the first object and then selecting the second object. So now this radius has been applied with a 20 mm distance. So this is the fillet command with the trim command on. So let us invoke back the fillet command again, but rather go for an undo option, or rather we'll go for Ctrl C on the overall to undo it. Now using the fillet option and then selecting the trim command. So now the default selection mode is a trim method, wherein let's see how a no trim will act. So using this, again you select the first and the second object, but now you can see that the edges are not trimmed and only the fillet is obtained. So this is the option to use the trim command. So next we can also apply this to a polyline. So towards that, let us draw in a 3-line segment. So consider it to be something like this. So the reason why it is ticked, because a latest command what we had used for polyline during polyline demonstration had a width of this. So if you want to edit it, then you can use the pedit command. But okay, let us do that to have a clearer understanding of how the fillet will impact. So let us keep a width of say 0. Right. So with this, now invoke the fillet command and rather now select the polyline. So the requirement is to select a 2D polyline. So once you select the 2D polyline or hover above it, you can see a preview of how the fillet is going to act upon. So once you click that, as the trim command is in the in no trim format, it has not trimmed, but all the edges have been filleted with the base radius that has been selected into it. So this is the application of the trim command. Alternatively, we also have the option to apply this trim to multiple surfaces. So let me just revert back to the original requirement, that is we have a single two-line object and as a polyline object. So we'll invoke the fillet command again, and let us increase the fillet radius to have a better view, and use the multiple command. So then it will ask for the first object, second, and so on. So that is, you can keep on applying this. Alternatively, so this will apply the trim option to more than one so unless we enter the enter command or come out of this using the exit command, it will keep on prompting it. So you can also use this if you have multiple surfaces that you have to do together, then this is one way of doing it. So the other key points for fillet is that if the trim mode is to be set on, then the filleting between the two lines will be done only when both the object length is more than the trim length. That means that if suppose consider this line, maybe you can use this measure methodology to check what is the line width. So this is approximately 147 mm and this is around 176 mm. So let us try a fillet option of radius 150 mm. So in that case, if we apply it using a no trim command, then it will apply. But whereas if we enable the trim command, then for this radius it will show that the selection is invalid, because the radius that we specify using a trim command should be lesser than the minimum length of the two objects that is going to be selected. And suppose if we want to override a preset fillet radius in the system menu, that in, so considering that we have a smaller object here and we do not want to set in the 150 mm radius in it. So in that case, when selecting the object, we can click in shift button and then select in to override the fillet that we have. That is, now the default fillet value will be set as 0. You can check here, even though the radius is 150 here, suppose if you want to cancel it out and then does not want to do it, then by using the shift option, the fillet is temporarily set to be of 0 radius. And in terms of layers that we are speaking about, if suppose the objects of fillet are on the same layer, then the fillet line will be on that same layer. So it means to say that this is going to get retained in the same layer of view that you are going to use. So next is that we can also fillet line segments in a polyline that are either continuous or separated by an individual line segment, and also that converge within the drawing limits. So in those cases we can still do it. Whereas if we try and fillet the boundary edges of an associated hatch, then it will remove the hatch associated, because the boundary gets altered and hence it removes it. Whereas it will maintain the associative if the boundary is a polyline object. So in order to maintain associativity, you can convert the boundary line as a p-line object, a polyline object instead of a region, so as to maintain the associativity. So next what we have is the chamfer. So chamfer is similar to a fillet, except it instead of a rounded edge, it will have a straight beveled edge or a cross cut edge. So this again removes the sharp edges from the system. Chamfering of an element is predominantly used in assemblies. That is, suppose if you are assembling a shaft onto a hole, then the edges of the shaft will have to be chamfered so that it will get guided into the hole easily. And in cases of interference fit components and all those things, the chamfer is a key mechanical design element. So let's look into how chamfer is executed in AutoCAD. So now let's look into the same object. Let us just quickly remove this fillet command, or let it be there. Let's see how it's going to vary. So now on this two edges, let's execute the chamfer command. So you can type in by CHA, so that will call for chamfer, and so it again has the same options like in your trim command. You again have an option for the polyline and trim, and then the multiple selection. Then also you have a method option to select the chamfer either by specifying the distance or the angle between the chamfer elements. So let's go into the first method one, that is the distance. So once you specify that, you can also check in the no trim command to just check how it acts, because the trim is going to be same as in the radius, but let's see how the distance and the angle method is going to impact. So now we have selected the distance method, and by selecting the same methodology as in here, we have to give in. So before selecting the second line, we also have the option for selecting the distance. Now suppose if the given a length of 15 and then specifying the second chamfer distance of 15, now you can see the chamfer is, let me just do a quick measure here. So this measure command we'll look in the today's session as well, but let's see how it is going to affect. So you can see this is 15 mm from this vertex, and again this is 15 mm from this vertex. So this is how your distance command is going to act in. So similarly, if you take in the next option of angle, then you specify the angle of the chamfer. Generally all the angles will be of 45 degrees. So let us do the same for both the points. Now select the second line. You can see how this. So this is your 45 degree line with both the angles. So by this, these two objects are fillet chamfered by a 45 degree segment, whereas if you are just going by the distance of the removed element, then you can go by distance method. So this is how it going to be varied. The rest of the options, that is the in the chamfer you have the trim, then the multiple and polyline is going to enact same as the fillet command. So now let's look into the next key part, that is editing using grips command. So far we have seen a lot of input commands that will help us to move the object, stretch or scale or rotate, all those things. So instead of specifying the command or selecting it through the menu, what you can also do is you can select the object, and you can see that there are certain points that are highlighted, squares that are highlighted here. So these are called as grips, and using these grips you can do the same activity. That is, instead of calling those commands separately, you can directly invoke it. Suppose if you want to move this object, then you can click on this grip that you want to do, and now the blue color grip is highlighted to red, and now you can move it across to any point that you require. So the next variation is stretching the element. So now let us look into the same object now. So once selected, and if you select one of the corners, then it gets into a stretch mode. You can see the variation between it. And in stretch again, then you have the object to cycle between the stretch or the lengthen option by using the control option. Right, so this is your command. So as I had used a control command, so now this element was copied and then lengthened to create this new segment. So the next option what we have here is the kind of a hidden command, that is, after selecting this, the default command is stretch or move based on the selection you have, but you pressing space bar, now it will go to the next point. So suppose you can see the next move point that is required, and also the angle of rotation that you can specify. That is, what we can do is for the same angle, but for a rotation of 45 degrees, sorry, yeah, so once you position it the next rotation point, then you can get the rotation angle after circling through the spacebar. So now suppose the angle should be 45, then it's also affected. And now circle through it again. After rotation, we also have a scale factor that can be, that is, this line can be scaled internally. So suppose if you are giving a scale factor as 0.5, now it has affected as a reduction in line. So similarly, now cycling to the next part is where it comes back to the original point for moving. So these are the different options that we have within the grip selection menu. So alternatively, suppose if we draw a circular element or an elliptical element, we have additional points called as a quadrant grips. As if you hover it above, you can see that we can extend these circular diameter using this command, and the distance specified is not from the previous grip but rather from the center of reference, that is the geometric center. So by this also you can modify the dimensions of the component that you have already drawn. So this will also get applicated to text command also. Suppose if we go for an mtext command here and type in random text. So now once you click here, you can see this square button is to move the object, whereas there are two triangular grips that are available to specify the height, the width of the column as well as the height of the text element. So these are the functionalities of using a grip command. Suppose if you want to change the settings of the or the color of the grip setting, then you can go to the settings menu, and in options you can go to the selection tab to specify what is the grip size and what is the grip colors and what are the properties it should look into. So now let's look into the important terminology of today's session, that is the inquiry techniques, that is to investigate into the different components that we have inside the drawing. So this is heavily useful when you are auditing a drawing or editing a drawing. So in that case, this is of prime use to us. So let me just remove these objects and then replace them with a a rectangle and a polygon. So let me just move this. So let us remove them all here and focus back to our group here. Yeah, so let us look into what are the details that we can get through this info. So the first tool of inquiry is the ID point, that is the identification point of any vertex that we are interested in. So that is invoked by the command ID. So then the requirement is to specify a point from which we can inquire the IDs. Suppose if you want to get the detail of this vertex of your polygon, then once you click on it, now you get a float menu stating that what is the position of that vertex along the X, Y and the Z axis. So this X, Y and Z is the current UCS coordinate system reference. So based on that you can identify where it is there. So also this data is available in the command line option also, because once you move your cursor away the info goes off, but when you highlight in your command line you can see the recorded data. So the recorded data is in X axis it is in -370, Y 281 and Z 0. So this is the use of the ID command. Suppose if you want to reference to a previously set point, then Suppose if we want to know the point as in here, then before clicking onto the point, we'll click in next and at and then click on this point. So this will give a relative position to this with the last reference point. So by this we can identify the position of the different points that we have in our drawing. So the next option is the usage of the list command, list. So by listing, when we select any given object, all the parameters and properties of the selected object will get listed. So we'll look into the same polygon object now, and when we select the list option and select the object, so when clicking on enter, it will return a command of descriptions. So now it says that polygon is of a polyline type. This is the object type, and followed with it denotes which layer the object is present. Next it will go to the defined space of the model, whether it's in the model space or the paper space, and next it denotes a handle. So this handle is a unique number, alphanumeric identification. This is created by AutoCAD itself to identify the different objects for its own reference. So next what we have is the other parameters to stating whether this is going to be so based on the selected object type, the parameters will vary for different objects. So now what it says is this polyline is a closed one and has a constant width of 0, and it has a total area of so much units and has a perimeter of so much units, and it has 6 coordinate vertex points, and these are the locations with the global UCS unit. So by this command you investigate into all the parameters as well as the properties of the command. So let us look into how this list command is going to act for different objects. So now let us select this circle and click on enter. So now with this circle, what we're seeing is the object type is a circle and its properties are center point, radius, circumference and area. Whereas if we use the list command for the rectangle, this again is a polyline and it denotes in similar line to our polygon object. So this is the usage of a list command. So this you can do for any custom object that you have created to look into their internal properties. So next is command is called as the distance command. So till now what we have done was we had used the interactive menu that was available in the home bar to investigate into the various to refer whether we have plotted the correct length, correct angle and so on. So instead of this interactive command, we can again use the command line prompt to type in distance. So this distance will give out the measured value in output terms. So suppose if we want to measure this distance, the first point in here and then the second point is here. So now dynamically you can also see what is the distance specified, and also by closing it out it will give additional information, that is what is the distance of that selected between those 2 points and what are those 2 points reference, that is what is the delta x, what is the delta y and what is delta z. So it means that it gives in the plane based reference as well as the individual line based reference of distance. So this is the utility of the distance command. So this means that you can use this distance command in different planes of reference also. So you get information within that same plane and also with the other plane modes. So like this we have different options to measure the different properties, that is the radius, angle, area or distance. So towards this we also have a group measure operation called as a measure geometric property. So once you invoke this property, this where you get a dynamic referencing of all the components that you want. Suppose if we highlight onto this object, you get the diameter of that, whereas if you move it over to here, you get the length and breadth of it, and if we select the polygon, you get the internal polygon details. So alternatively, you can also select one of the different options that you have, that is either selecting the distance, the radius, angle, area, volume, or a quick measure, or again select between the different modes that are available. So we'll look into each and one now. So to start off with distance, it acts exactly as the dist command, that is you specify the 2 points from which the distance is plotted and reverted back. So once we select these 2 points, now you can get the output stating that this is a distance of 50, and also you get to continue the other options. So this command does not terminate until you terminate it outside. Next you have the radius command. Once you give it, it prompts for a arc or a circle. So upon selecting it, you get the radius of the circle. So alternatively, then you can select the angle, and again based on an arc or circle or line of between two objects that you can select. So suppose if we want to select this object, then you can click on the first line and the second line, so that way it gives the angle of reference for us. So alternate, next we have the area option. So in area we have submenus that are available. So we can check the area by the first default method by specifying the first corner point here, and next is and then the next point. Let me just close this. Okay, now let us repeat this command with the area option. The first point, second, the third, and the final, that is of required. So once you want to terminate it, click on enter. So now you get the total area as well as the perimeter of this command. So alternatively, we can also circulate within the area command and choose the other options that you want. So in area, after specifying the first point, you can also specify whether it's going to be of an arc or length. So once it's selected the arc element, so you can specify the surface of the arc. So based on that you can select. So now this is the selection arc, and we can get to know the area within it. So the next type of objects that we have is the object command. So in area we have the object. So this is by selecting the object you can calculate the area and perimeter. So this will apply on a whole. So we need not select the individual points and then request for the area, but rather select the object directly. So this is the area object command. So next what variant we have is to add an area or running it. So it means that once we click on the add area mode, it will keep on adding the areas of selection. Suppose if we want to select the area of these two, so now and then it's in the add mode. Now if we click on enter, it will result in the total area of the units, and also with latest selection it shows the individual, the separate area. So this is the add area option, whereas we also have an option to select the remove or subtract area within each other. So let us look into one by one. So suppose if we want to subtract the area of this point, so let us select the object method. So first we have to select this object and then this. So now it gives in the net result area. You can check in the highlighted point here. So this is how your subtracted area will look like. So alternatively, suppose this can act best if you're operating on a internal object. So as we have not mentioned any dimensions, it is easy to do it in the mirror way. So now clicking on to these lines, now we have got this object. So now let us look into what is the resultant geometry after subtracting the areas of the circle with it in it. So in the subtract mode, what you get is you directly go into a negative command as you start in a negative. Let's look into it. Now I'm just using the right button to continuously select the requirement. So we are selecting the area and selecting the subtract area and selecting object. So once we start selecting the objects, you can see once the subtract mode is enabled, it turns in red. And if you click on enter, what it does is it calculates the individual area of each component, and then that is the latest component, and then subtracts it from the total area that had been cumulated from earlier. So as there was no reference object available, it continuously goes on the minus object. So this is why if you again select a different object here, now we can see the total area going in negative, but the intended objective is to subtract this from the area. So what we can do is, first let us uh, select the areas that needs to be subtracted, that is with these 4 box, and once computed and click enter. Now let us add the area and select the addition object here. So with this you can get the total area that has been available after removing these 4 holes. So this is how your subtract area can act in. So next we have a command in measure geometry for the volume of a component. But this calculates the volume based on the area times the height of it. So this is typically used for to find the volume of any solids or a region. So for 2D methodology, let us not dwell into this volume command. So the next command what we have is the quick measure. So by enabling this, we'll get the selection methodology wherein we can quickly analyze what are the different dimensions of our system is. So next we have a different modes. So this is to enable or disable the quick measure behavior. So if we select it as yes, so always we'll have the quick measure enabled even without selecting this quit option. So this is about using the different measure techniques that are available to quickly look into or investigate any components that we have. So in today's session of manufacturability, we dwelt a lot into the different options that AutoCAD allows us to define additional information into the drawing that will help us to identify different manufacturing techniques or ease of manufacturing. So the first was the hatch command, wherein we used this command to indicate shaded patterns which were used to represent a cross section for a mechanical component, or in case of civil representation it's used for a roof or an RCC material and so on and so forth. So there we looked into the several types of application of the hatch and also a gradient that can be used, and how the object of hatch can be selected whether through internal space or through boundaries. Then we looked into various island detection techniques which will help us to select the objects in that's of importance to us. Next we looked into the P-line command, that is the polyline, that helped to draw a sequence of objects that is both linear as well as curvilinear using a single P-line command. So this also we had looked into the various options that we can look into and draw, that is we can draw a uniform or an ununiform length, we can combine using lines and arc, and then we can add or edit the option by using a spline command or a curve fitting based on the input. So there were several options that P-line command offered us to do. So next with P-line we also looked into the P-edit command, wherein we had the option to modify the polyline that were created in order to vary the width of the polyline segments, or modify the spline that were created to specify the tangent of the splines, and specify the orientation of the text using reverse command, join different line types, and so on and so forth. So following this we had looked into the fillet and chamfer commands. So these were typical for any manufacturing industry or other design to ensure that the basic requirements were satisfied. One towards safety, that is to eliminate any sharp edges from the design, and to second for the structural integrity, that is to eliminate structurally stressed weak points. So towards this we looked into the fillet commands that will help us to specify the radius and also trim the commands, and next the similar way we looked into chamfer by when we can specify either the angle between the 2 points or the distance between those 2 points. Then also we looked into how we can do common editing properties such as move, rotate, scale, all using dynamic selection using the grip techniques. So following which we looked into the other inquiry topics that will help us to analyze the design model that we have in hand. So we looked into ID command that will help us understand what is the vertex location of that point. Then we looked into list command, so that is to inquire more about the parameters on the properties of a selected object. So we also looked into the disk command that can use to measure the distance between the 2 points. Then as an extra measure, we also looked into the measure geometry command, wherein we were able to do expanded set of measurements, that is the distance, the radius, and then also we looked into area operation, wherein we were able to select or measure the individual areas and also perform add or subtract options to the area. And finally we also looked into how the quick measure command can help us to quickly grasp the dimension details of any object. So with this we conclude the week 5 of session, that is on manufacturability. Welcome back everyone to week 6 and 7 of this course. So we'll be looking at geometric dimensioning and tolerancing techniques, shortly called as GD&T. So till last week what we have seen is, we have seen an overview of the manufacturability techniques, and this week we'll be focusing on two topics, that is the dimensioning as well as the tolerancing technique. So moving forward, this is the brief overview of the topics that we are going to cover in the next 2 weeks. The first is what is GD&T and what are the common usage references or the standards for this GD&T. Following which you will have the dimensioning technique. So we look in the dimensioning part of GD&T. So we look into what is features, what are types, what are the different symbols that are used for dimensioning, and what are the rules to be followed when you dimension different features and objects. Next, moving forward, it's an important topic of tolerancing. So we look into what are the different definitions of tolerancing, what are the specifications of it, and we look into several key terms, the size, limits, deviation, followed which we look into datums. So that is an important terminology used in tolerancing. So we look into what are frames, references, and simulation pertaining to datum. And next we'll look into the allowances and clearances, which is then applied to fits. And then we'll look into various international tolerance grades and what are the different features wherein different grades are called for. Next, we'll dwell a lot into various GD&T symbols and their modifiers, and we'll touch a little upon the virtual conditions, and finally conclude with the different GD&T rules that are to be followed. So this is a typical GD&T encoded drawing that you see in a technical drawing. So as you could see here, you have your object here that are referenced by several dimensions. So first we have seen a basic dimension, then there's a leader, then there's a datum feature, then there's a feature control frame. So all these things we look into detail, how it's going to affect the manufacturability of this object, and then the quality standards, the inspections of this object in detail. But this is how a typical GD&T drawing will look like. You can see different boxes are coming in, there are different symbols, there are different notations. So all these together are decoded to ensure that the object is manufactured and inspected to satisfy its feature or function. So now we'll come down to what is GD&T. So first you design whatever object you are doing for three things. That is, for you design for manufacturing, assembly, and service. It means that your design should be capable of manufacturing using the commonly available techniques or based on the desired requirement of you. So suppose it requires for a special manufacturing process, then you have to adopt it. You have to know what are the different tools that you have under your disposal to ensure that the design comply to those manufacturing processes. Once that is done, how this design is going to be assembled together. So there you have different components that are going to come together to serve a function. So how are you designing those objects, the individual components, to deliver a overall performance? So that is your assembly. So once you have assembled and then the object or the material has gone to the customer, the intended person, and then it goes on to its useful life, and suppose if there is some requirement of service coming in, then how is your design catering to ease of serviceability? So this is the broad spectrum of design bringing into different categories, design for manufacturing, assembly and service. So once you have decided on your design, then you move forward to drafting that design and then releasing the drawing. So releasing drawing you mean by your verifying all the parameters that are required to put into you, ensure the quality of the drawing and then release to consumption. Consumption as in release to your the next internal customer in hand, be it a manufacturing line or be it to the next department which take this drawing to integrate into the final release. So this is an important part where you are finalizing your drafting and then releasing them to the stakeholders. So next what you have is your actual manufacturing process. So that is you start based on your design, you start manufacture your object, put together and put it to use. So once you have manufactured, then you assemble it together. So once you have assembled, then you analyze the part, you look for various critical features, the dimensions, the checkpoints, you inspect them for quality and then release. So this is what we have seen in the earlier session, that is this GD&T is heavily used for your inspection to ensure quality of your product. So this is a typical workflow of a product design and manufacturing and service. So where now GD&T comes into play. So GD&T is typically an international standardized language that is used to describe the shape, form, fit and function of each feature of a part. So this part is what we have spoken about earlier. So that goes through all this process. So we use these techniques in GD&T, these set of rules that are common language that can be understood by anyone who is familiar with this GD&T techniques, can use that to describe what is the shape of the object going to be, what is the form of the object, and how the fits of the objects that are going to interact within each other, and what is the total function, whether as the individual feature or as the assembly. So next, how to bring together all these things. That is, you have to communicate this details, the shape, form, fit and function. So how are you going to do is by using a system of symbols, then system of rules, definitions, and with these three we used to define the geometry, that is the four features that we have spoken about earlier, and also the tolerances of the mechanical components without any ambiguity. So this is the catchword here. It means that whoever trained person looks into the drawing can understand the functionality without any doubt, so that there is no mistake that can be done into the production or assembly or inspection. So this is where your GD&T is going to play a big part. So originally how it originated is during the World War II, where it saw major application. So how it was took forward was during World War II there was a rapid requirement of productionizing the the guns, ammunition, planes, warships, all these things in a large scale manner. So there a large amount of people who are involved in it, ranging from drafters, assemblers, machiners, everybody. So everyone has to ensure that the parts that were produced in millions by them are interchangeable and also ensure their functionality, proper functionality, because it's going to cost life. It's not about just winning the war, but it's about saving the soldiers and the citizens' life. So this is where the manufacturing domain, the engineering domain during the World War II applicated this GD&T techniques to ensure that all the components that they produce serve their intended functionality, and also they serve as an interchangeable part, that is, they can be easily repaired. So towards this, there are different standards that are being used worldwide. So the predominant one are the ASME standard Y14.5, or you can refer to the ISO standard 2768. So next we'll just briefly look into what are the different standards and the sub features of the standards. So here have been listed all the ISO standards. So suppose the early slide we are seeing the 2768. In 2768 we have two different parts, wherein the part 1 denotes the tolerances for linear and angular dimensions without individual tolerance indication. So in part 2 what we have is the general tolerances that are defined for features without individual tolerance indication. So like that we have different variations of this ISO standards for different applications. So this is just an idea for you to look into what standard you want to follow, want to refer, and then what are the different rules or definitions given in it to apply it to your final drawing. So next let's move on to the dimensioning sector. So here we look one by one. So what is dimensioning and how it's defined? So dimensioning is used to describe the size and geometry of a feature, a part or an assembly. So towards this dimensioning you need to have a strong understanding of the engineering judgment and also thorough knowledge of the practices that are required for it, and also the product, the fundamental requirement for it, which needs to be grasped very clearly. It means that the intended product that you are going to design and deliver has to adhere to the proper engineering judgment principles, and also ensure that you have a very strong knowledge of all the processes that are going to be used in order to produce those components. So only then you can give in the dimensions that are both functional and usable. So next, the different classifications of dimensions. So typically it's classified into two types. The first is the size dimension, wherein the dimensions are measures of the size of a feature, and next we have a location based dimension. That means these dimensions details on the locating features or the objects. So next we can also classify the dimensions into three broader groups of dimensions. So it means that inside a dimensional drawing we can categorize them into three different groups based on their application. So the first one is called as a functional dimension. So it means that these dimensions will describe the part functions or the mating relationships. Next we have a non-functional dimensions. It means these functions do not influence the part function, that is they do not affect the function of the intended part or the object. So next we have the auxiliary dimensions. So these dimensions are used only for information purpose, and they are enclosed within parentheses, so that it is clear that they are auxiliary dimension, that is they give additional info to the drawing, and for this there is no tolerances that is required to be applied to it. So let us classical example and look into how the different dimensions are set into. So this is a day-to-day application. You have your chain and sprocket. So in this chain and sprocket mechanism, the chain links are a key part or a feature. So in this chain you can see there are different features that are built into it. So to go into the technical drawing of it, a brief of it, this is how the roller chain assembly will look like, and whatever listed here are going to be the functional dimensions. It means that roller diameter, the pitch, pin diameter, these are critical dimensions that need to be controlled in order to ensure that the roller chain delivers its intended performance. The intended performance is transmission of the power from the driver foot to the wheel through the sprocket mechanism. So the roller width is going to control how this internal assembly is going to sit on the external assembly, and the spin diameter is used to control how this roller is going to fit on this pin and how it has a rolling mechanism. It should not be tight, it should not be too loose. So how it's going to be fitted. Next we have pitch. So it means that the relation between one pin to the other pin is controlled by this dimension of pitch. And then this roller diameter with respect to two consecutive rolls will ensure how the teeth is going to get locked between this roller. So these dimensions is going to affect the part function. So that's why you can say that these are all functional dimensions. Then also we have non-functional dimensions that will be required for manufacturing this individual parts. So one such thing is, you can see this plate, the plate that is going to encompass two different rollers. As you can see here, that dimension can be a variable amount because that is not going to affect the part function of power transmission. And then again in this drawing you can see, yes, there is a slot that is given that is going to help in the assembly of the parts. Suppose this is your fundamental part and you need to manufacture it in bulk for different applications. In that case, you can also specify an auxiliary dimension for a given application, stating that the number of the roller chain components or the sub-assemblies, say it's in 50 numbers for one application, whereas 100 numbers in different application. So in that case, then you can declare them into bracket within parenthesis for communicating the auxiliary dimension information. So this is how it's going to vary. So depending on the function, the designer is required to properly dimension the size and geometry of those features and then categorize them according to the various functions and then deliver to the next line. So let's look into what are the different features that are going into the dimensioning sector, that is for a dimension, what are the individual features. So let us look at this example. We have a rectangle or rather square object wherein we have 5 different nomenclatures that are used here. One is we have the dimension line, and then we have a number that is the feature size, then we have an extension line, and then a visible gap here. So this typically denotes a dimension. So with this, anyone can understand that this is going to describe the dimension or the size or the geometry of the object. So what are the features in it? The first thing is the dimension line. So it means that it is horizontal or vertical or aligned or arc based on the requirement, and that along with your extension line denotes where the measuring object is. Suppose if you are going to measure this object, then you have to use these two faces and ensure that between these faces the dimension is going to be of 30 units here. So towards that you have the dimension line as well as the extension line. So towards this extension line, in order to differentiate that as a dimension, we'll look into the various line types of it, but you can see there is a small gap that is drawn into it to indicate that this is a dimension, that is an information or an annotation given to the drawing to describe this function and not a part of this object. So next we have this leader lines. Leader lines is something where you can see an extension like in here. So towards this leader line, we'll look into more into the next week part, but a brief intro here, that is, you shouldn't cross those leader lines. That is, this, suppose if you want to mention the info of arrowhead here, this has to be here and this has to be here. That is, you cannot extend this and then cross this leader line and refer here. So next is that should not be having excessively long leader lines. These leaders should be positioned as close as the object possible to communicate the matter and should not be positioned it externally very far away. And also it should not be parallel to the dimension or the extension line what is mentioned. So there are different angular requirements to it that we'll look into the next slide. So next we have the arrowheads, that it's a part of this dimension line. So these arrowheads should be between these extension lines, and in case there is no space, then they can be drawn outside. That is, they can be drawn in this manner and then the dimension can be fitted inside, but the arrowheads are pointing towards inside the dimension line. So next we will look into the various types and symbols of communicating the dimension intention. So the types are, as we said earlier, you have a linear line wherein it can convey a horizontal dimension or a vertical dimension or an aligned dimension. Aligned as in an angular that we look into next. So next we can also have an angular one. So this angular is an arcual element, whereas the aligned is a straight line but inclined in a different way. Whereas next also we have different nodes that are available. That is, you can define whether it's a diameter or a radii or a chamfer. That is, you again communicate the dimensional intent to the designer as well as the manufacturer. So this is a typical drawing where you can also look into various symbols. We'll look into one by one. The first application of the dia symbol is here, and next you have a radius, and applicating this diameter and this radius to spherical element, you prefix an S capital letter before these two. So this is demonstrated here. So this is a spherical element here, and hence it goes for a spherical diameter of 50. Whereas this again a spherical element but an arcual one, so you say that it's a spherical radius of 12. And next here for this object is a roller. The external, the bigger one is shown as 40 diameter, whereas here it is shown as 30 diameter. And here we have different arcs. So here the arc radius is 15 for this feature and it is 10 for this fillet. So this is how you define your diameter and radius for arcual element or a spherical element. Next we also have a reference dimension that we said earlier, that is the previous Excel slide, where we see as an auxiliary dimension that is used to communicate information that is enclosed within parentheses. So that is your reference diameter. Next we have a counter bore or a counter sink operation. That is when you go for a bolt machining operation, that is in a slot machining operation, then you go for a counter bore or counter sink to ensure the fitting of those mating parts and also to positioning and location of those mating parts. So the symbol for counter bore is a open-ended square, whereas in counter sink it's an inverted arrow like this. So next feature is the X mark that is used to denote repetitive times of the specific feature or in locations. That is, suppose if you are mentioning that there are going to be 5 holes of the same dimension that is located along a pitch circle diameter or so that we have done earlier. In those cases you can use 5x to denote that there are going to be 5 holes of those features. So the number of times or the places where it's going to be located can be denoted by the symbol x. Whereas the next symbol, if you are going to denote the depth, how deep an object is going to be, to indicate that you can use this a down arrow button. So these are all available within the CAD modeling software. And next, indication whether this dimension must not be scaled, then you underline the given dimension. Next, to denote that it's the square element, then use a square object here. So that is, you can see in this example, this face is going to be of 42 units in dimension, and that is a square element. So this is your square symbol. Next, if you are indicating a length of an arc, then you type the dimension wherein above it you place a caret symbol. So next, suppose if you are mentioning that a hole is a complete through element, whatever the two surface length may be, the depth of the object may be, the hole is drilled throughout this length. So that is your through symbol. So here, as you could see, we use a combination of symbols and alphabets to denote the various dimensional properties of the object. So this summarizes the basics behind the dimensioning symbols and types and the requirements. So next, let's look into the various rules that are called for dimensions. So different kinds of rules are available in different resources. So we'll just quickly look into the key dimensioning rules that will be required to ensure that your drawing is properly dimensioned and is properly readable. So first thing is that the dimension should not be duplicated in any case, and the same dimension should not be given in two different ways. It means that quickly let us look into an example. So these are two different views of the same object. It's a symmetrical object, and in this case the total width of these two faces have been given as 94 units and the individual lands has been given as 32 with a reference dimension as given here. But as you could see here, first thing is like this dimension had been duplicated onto this view. That is not proper because it confuses the user as well as the machiner, because the dimensions are controlled features which require supervision or control. So in this case, you have already mentioned here, so there is no requirement for duplicating it. So next is only requirements or dimensions that are required to produce the component or inspect the parts needs to be used. No unnecessary dimensions that are need to be mentioned. So it means that, look back to the previous slides where we said that you're going to use a functional dimension, because the functional dimension is what needed to be ensured to produce the component or use the component. Those only have to be inferred. All other information, extra information can be typed out as notes or general info so that it can be captured. For example, if you are going to have a rectangular plate with 4 holes that are drilled to it, The key dimensions are the rectangular block dimension as well as the hole measurements and their location measurements. All other details are not required. So only those that are highly required to dimension them has to be denoted. It means that suppose if there is a non-dimension part, the designer intends to say that you can have any dimension as required or as applicable to that object. Quality inspector also would not be concerned to measure those dimensions. So this is why only necessary dimensions need to be used. So next, the dimensions should be given between the points or surfaces that have a functional relation to each other. This comes along with the point 2. It means that only those dimensions are needed to be used for functional references have to be used. So next we have the dimensions that always have to be attached to only those views that can describe the feature better. So it means suppose if you see here there are two different views of this object, and this info, that is dia 16, has been given to here, and the total length has been given here, all the arc dia elements have been given, and in order to convey that this is going to be a square element, it has been conveyed in this view where it is more clear. So whereas in this view these dimensions, the internal dimension and the width dimensions, have been interpreted in the wrong way. That means that in order to communicate that this is a square element, the designer had referred to two different faces for dimensions. So this is a poor representation of dimension. So it means that this information is captured in this form wherein it is represented by a square mark and a cross mark. So this will denote that this is going to be a square element wherein these two faces are going to be circular elements. So you must always attach the dimension to the view that best shows the contour of the feature, that being dimension, and also these dimensions should always be referred to the parts or the surfaces that have a functional relationship. You can see here this dimension has been mentioned as a chain dimension from here. So this means that this surface is of great importance, so the designer has to control this surface, and only the designer has to be ensuring that these are the dimensions that he has to take care of, the inspector. So only these dimensions have been measured in this drawing. So next rule is that wherever possible you must avoid dimensioning to hidden lines. That is, do not take hidden lines as referencing. The hidden line is just an intent of the designer to communicate to the manufacturer or the quality inspector that there is an internal structure to it. Inspection properties involve different gauges, and this hidden line referencing cannot be used to gauges properly. So always use dimensions that are referred to given points or surfaces that have a functional relation. So as you can see, everything revolves around the same function, that these dimensions should be functionally applicable and can be functionally measured. So next, also avoid dimensions that go over the object or through the object. That is, they have to always be positioned outside the object to have a better readability. So also, whenever possible, locate the dimensions in the adjacent views possible. So it means that it goes along with this part 4. If there are design intent to be captured, then the dimension data should be given in adjacent views so that they can be inferred together for the designer or the inspector to capture the design intent. Next, for example, if for a circle, it's always measured by its diameter circle with a line through it. And arc means that you use a leader and then mention it as a radius with r element 0.5. So this is typical rule. These rules mostly should be followed, but in certain cases there are difficulties in dimension, then it can be taken as exception. For example, if this diameter cannot be drawn with a circle through it, suppose it has an internal feature, then you can also alternatively use a leader to measure it. So but these are general details so that everybody has on the same page and can understand the drawing better. So next is, the holes are always located by the center lines and they can be extended and used as an extension line. So it means that the holes that are drilled to it, so they are always referred to the positioning is referred from between those centers. So the gauges will be designed so that the referencings are always between the center line. So you are aligning those production intent along your design intent. So next is the hole should be located and sized in the view that shows the feature as a circle. It should not be dimension to a feature that is going as a hidden line. So only in those view that is clearly visible that is going to be circle and is going to be hole, then only in those has to be featured. So next is always ensure that you do not cross the dimension line, extension lines or the leader lines. So these are the different rules, and the final rules is that the leaders that we looked earlier can be sloped at 30 degrees or 45 degrees or 60 degrees angles to ensure better readability and better control over the drawing. So these sums up the different dimensioning rules and techniques that the GD&T standard calls for, and next let's look into how to applicate them onto your AutoCAD drawing.